Hello and welcome to Certified Kubernetes Application Developer Complete Video Course. Since the first release on July 21st, 2015, Kubernetes has revolutionized the way IT is done. It offers a scalable way to run containers in public cloud, on-prem data center, or even as a test environment on your own laptop. Different certifications exist for Kubernetes. Kubernetes and Cloud Native Associate, or KCNA, which is the entry-level exam. The Certified Kubernetes Application Developer, or cKAD, and the Certified Kubernetes Administrator, or cKA, are the core exams. And there is also CKS, which is Certified Kubernetes Security. This course will prepare you for cKAD. And I have other video courses that prepare for KCNA as well as the cKA exam. And you can use these courses to learn everything you need to know to effectively and efficiently use Kubernetes, even if you're not interested in getting certified and you just want to acquire the skills. Despite what the name suggests, cKAD is not just for developers. It's an exam where candidates are tested on their skills to run applications in an existing Kubernetes cluster. So, you will not have to build a Kubernetes cluster, but you will have to be able to run pods in deployments, implementing all of the features that are required to guarantee a pod is scalable as well as available. This exam is about essential skills that everyone who wants to run applications in Kubernetes should master. And in this course you will learn it all. And the skills are also important if you want to get Certified Kubernetes Administrator certificate later. The focus in cKA is on the cluster. You will learn how to build and maintain a cluster and how to take care of other items that are important when running Kubernetes on-premise, in a data center or cloud, such as implementing backup, managing security and configuring the network. Also, to pass the cKA exam, you'll need to have all skills required to pass the cKAD exam. I have organized this course into different modules. The first module is an introduction and it focuses on getting you started by covering container fundamentals, Kubernetes basics, and we'll talk about creating a lab environment. The second module is about Kubernetes essentials. You will learn all there is to know about pod management. And the third module covers everything else you need to know to manage containerized applications in Kubernetes. You'll learn how to make pods scalable by using deployments, how to provide access to deployments using services and ingress, and how to provide storage, and also how to provide access to configuration using ConfigMaps and secrets. In Module 4, you'll learn about more advanced cKAD tasks, including working with the API, applying DevOps technologies, and troubleshooting Kubernetes. And in Module 5, I will walk you through a sample exam, where you can practice with some questions that are similar to the questions that you will see in the real exam. Before we get started, let me also tell you a bit about myself. My name is Sander van Vught and I live in the Netherlands. I'm a specialist in open source platform and infrastructure, and as such I'm specialized in Linux, Kubernetes and Ansible. I teach classes sometimes in person, but most of the time in video courses like this. You'll find that I have recorded multiple best-selling classes, such as Getting Started with Kubernetes, Red Hat Certified System Administrator and Linux Under the Hood. Apart from that, I'm the founder of the Living Open Source Foundation, a non-profit organization that provides open source education for free in different African countries. Now there's a lot to do in this course, so let's wait no longer and get started. Welcome to Lesson 1, Understanding and Using Containers. This lesson provides a quick overview of container essentials. It's not meant to be a complete introduction in containers, but it teaches those things you need to know about containers while working with them in a Kubernetes environment. I'll start by explaining what a container is and how it is different from a virtual machine. Next, you'll learn how to start and manage containers. You'll also learn about container logs. And at the end of this lesson, there's a lab that allows you to practice the skills you've just acquired. In this lesson we are going to explore what exactly it is, a container. So a container is a self-contained, ready-to-run application. And that is what makes it different from a virtual machine. It really means that a container is a package that contains everything that is needed to run an application. To start a container, you will need a container runtime. The container runtime is running on a host platform, and it establishes communication between the container and the localhost kernel, because containers do not have a kernel by themselves. So all containers, no matter what they do, run on top of the localhost kernel, and that makes also a difference with a virtual machine. Let me make a drawing to make sure you understand what this is all about. So let me visualize what a container looks like in regard to the operating system that is running it. So on the host operating system, you will have a kernel. Let's say your host operating system is RHEL 9, then your kernel is Linux kernel 5. whatever EL, whatever the current kernel version is. And the thing in containers is that everything is running on top of that specific kernel. So on top of the kernel, you have the container runtime. That is your container D or your cryo or whatever. And on top of the container runtime, you are going to run the container image. And if you look at the container image, you have this default application. It's the entry point application. And you have all these libraries that are dependencies of that application. And you also have glibc, which gives the container the identity of a specific operating system. So if this would be an Ubuntu kernel and this would be a Fedora container, glibc makes it the Fedora container looks like Fedora, but if you check the kernel version, it's still an Ubuntu kernel. And that is totally different as compared to virtual machines, because in virtual machines, it's not a container runtime. You have a kernel, you have a hypervisor, and you have a virtual machine, and every single virtual machine has its own kernel. And that's the main difference between containers and virtual machines. So let's talk about the different components that you will typically find in a container. To start with, there are images. Images are read-only environments that contain the runtime environment, which includes the application and all the libraries that it requires. Containers are the isolated runtime environments where the application is running. And by using namespaces, which is a Linux kernel feature, the containers can be offered as a strictly isolated environment. Then there's the registries, which is the third important component while working with containers. Registries are used to store images. And Docker Hub is a common registry, and other registries like k.io also exist. And you can even run private registries. In Kubernetes, the Docker Hub registry is used as the default registry. Now, an important thing to realize is that containers really are Linux. And that is because they are heavily based on features that are offered by the Linux operating system. Like Linux kernel namespaces, which provide strict isolation between system components at different levels. They work for networking, for file, for users, for processes, for IPCs. And that means that for all of these, you can have a different namespace and provide strict isolation between the different components. And as a result, the uses that you see in one container probably don't exist in another container. There's also cgroups. Cgroups are a Linux kernel feature that allow you to do resource allocation and limitation. So to make sure that a container can never get beyond a certain amount of RAM or whatever type of resources, cgroups is what it is all about. Let's try to understand container runtimes. So the container runtimes is the part that allows for starting and running the container on top of the host operating system. And the container runtime is responsible for all parts of running the container, which are not already a part of the running container program itself. So it's pretty important, and it's really the engine on top of which the container is running. And there are different container runtime solutions. There is Docker, there is LXC, there's runc, there's cryo. You write CRIO, you should pronounce it as cryo. And there's container D. And all of these runtimes are included in the different container solutions. And when we talk about container solutions, at the moment there's only two that matter, Podman and Docker. Also good in containerized environments is that there is a high level of standardization, which is provided by the OCI. OCI is the Open Containers Initiative. You can find more information at the URL opencontainers.org. And it standardizes the use of containers. And the good thing about the OCI is that it comes from the industry itself. It was founded by Docker, and all the major players at the field of containers adopt to the OCI specifications. An important part of the specs is the image spec, which defines how to package a container in a file system bundle. Because really, a container image is just a file system bundle. Apart from that, there's a runtime spec that defines how to run that file system in a container. OCI makes sure that there's a high level of compatibility between the different container solutions, no matter which environment they originally come from. And that means that you can easily run Docker containers in a Podman environment and the other way around. Now, Docker is a very important player in the field of containers. So let's try to understand Docker. Now, Docker is very important in the landscape of containers, but Docker is not the only way to run containers. When it started in 2013, Docker offered a couple of items, which is a container image format, a Docker file, which is a method for building container images, a way to manage container images, a way to run the container images, a way to manage container images, and a solution to share the container images. And even if before Docker containers already exist, really by bundling these items together, Docker has become the huge success that it has been. As Docker is so very common, I will use Docker only in this video course. But you should be aware that Podman is the alternative that is used in Red Hat environments. If you want to know more about Podman and if you need more details about containers in general, please watch my video course Getting Started with Containers. Let's just talk a little bit more about the alternatives to Docker. So with the launch of Red Hat Enterprise Linux 8, Red Hat started offering Podman as an alternative to Docker. Well, an alternative, they only support Podman in RHEL 8 and they dropped support for Docker. And they can do that because of a high level of compatibility. Now, Podman runs containers without the need of having a daemon directly on top of the CRI-O container runtime. And Builder is a related service that in the Podman stack is included for managing Podman container images. And there are also other solutions for running containers, although not as significant. Like LXC, which is a Linux container runtime, the Linux native container runtime, which is using purely and only Linux technologies. There's systemd and Spawn as well, which is allowing you to run containers integrated in systemd. But again, in the continuing lessons, we will focus exclusively on Docker, which will be enough to get yourself skilled as a cKAD. In this video, I want to tell you about registries. Registries are a very important part of working with containers, because they are used to provide access to container images. Registries makes it easier to distribute container images, because anyone can publish images on public registries. Docker Hub is the biggest registry. You will find it at hub.docker.com, but other registries also exist like k.io, and it's possible to create your own private registries as well. So how do we access registries? Well, that's not too complicated. Normally, registry access is free, but in some cases, additional authorization is required and you will need an account to access registry contents. On Docker Hub, an account gives access to additional features, like a higher image pool limit and webhook connections to GitHub. And you can use the browser-based login or Docker login from the command line to authenticate with the registries. In Kubernetes, you will access the registries automatically. You won't really think about it, and you will use the Docker Hub registry as a default. But you can also provide paths to non-default image locations, and that is why understanding registries is important. Let's go check it out. So let's check out Docker Hub. So here is the Docker Hub website. And they ask you to sign in or to create a Docker ID. Creating a Docker ID is free. I would advise that really you create one for a richer experience. So as you can see, I just signed in and you have an overview of the images that I've created. Nothing really important really. The only one I'm really using is the OpenShift image, but that's about all. The rest is for testing only. Now the most important part of the Docker Hub is what you find in the upper left corner. In the upper left corner you can search for anything. So if you search for Nginx, then it will go check it out, and look at that, 91,207 result. So that's a lot. That is the nice thing, but also a little bit of becoming a problem in Docker Hub. There is so much going on. Let's check out the official Nginx, just so that you have an idea what you can find in these images. So if we click the image, to start with, you have the command. I will tell you about these commands later, but this command can be used to pull the image. You have the quick review, you have the quick reference, and you have the documentation, which is telling you what is Nginx and how to use this image and how to expose it on an external port, and really everything you might want to be doing with this image is in here. So if you want to do it the smart way, which is what nobody is doing, but hey, I want to tell you anyway, then you look up an image. Let's do another one, MariaDB for instance. There we go, the official image. Wow, 1B plus. That's really a lot, isn't it? That's 1 billion. And we have the description and the quick reference and what is it. And there we go, starting a MariaDB instance, which is telling you, hey, if you do this, you need to pull, you need to provide a password as well. So stuff like this is all in the image description. So that is what Docker Hub is all about. As Docker is not the only player on the world, let's also have a look at k.io. Or key.io, if that's the way how you want to pronounce it. So that is backed by Red Hat. And as Red Hat with Podman is going their own direction, I think it's important to know a little bit about the Red Hat product offering. So here we go, and they want you to sign in, and they want you to create an account as well, but you can also just search. So if you search for Nginx in here, then what is happening? You can see a couple of Nginx images as well. K.io is not as big, but you do have images that are quite usable, especially if you are in a Podman environment. For the rest of it, it is very much what you will find on the Docker website. So I think this is enough about the images. Let's continue with the next lesson. So let's get started and run some containers. In order to do so, we first need to realize that there are many environments for running containers. We are going to have a look at Docker on Ubuntu. That's for the simple reason that Docker is no longer supported on Red Hat. That's why I'm using it on Ubuntu. For sure, you can still hack it your way into Red Hat, but you will break it every single time you update your system. So running Docker on Red Hat 8 and later really is not smart, and you shouldn't be doing it. If you are on Red Hat 8 and later, you can use Podman instead of Docker. And the nice thing about Podman is that Podman is installed by default on RHEL 8. So if you are interested in discovering the standalone features of running containers, then I would say take your RHEL or Rocky or Elma or CentOS or Fedora or Oracle Linux and play with Podman instead of Docker. You don't have to install anything. It works by default. In order to get a richer environment, use dnf install -y container tools, which will install a couple of additional utilities as well. You might want to do that. I am going to show you how to work with Docker on Ubuntu. Here is the first thing that I'm going to demonstrate for your convenience. The steps in the demo are on the slide here, so feel free to pause the recording and work with what you find on the slide. I will walk you through the procedure. So as an alternative, you can also go along with me and follow along with what I'm going to do on my screen right now. So the first thing to do is an apt-get update. Of course, apt-get is old school. You might also use apt update. That also works. You will notice that the instructions in order to install Docker coming from this slide, they come from the Docker website. So if at any pace, due to newer versions or you never know in IT, this doesn't work anymore, just look it up at the Docker website and you will find the updated procedure. So to start with, I need to install some helper packages. That's what we just did here. And yes, we need to allow that to happen. Then we are going to add the repository that is provided by Docker. Now, because of Ubuntu security restrictions, you cannot just add a repository. You need to include the GPG key and import it as a trusted key on the local operating system, which is what we are doing right here. So we fetch it using curl, and then we run it through apt-key add, and it's saying OK. And to verify, we can print the key fingerprint. And as you can see in the key fingerprint, we can see that it's Docker release, docker at docker.com, so that is okay. Now, based on this key fingerprint, we can continue and add the apps repository. Be careful not to make any typos here. So right now you have added the Docker repository, and that means that you are not installing Docker from the distribution repositories, but really from Docker itself, which is what I would always recommend, so that you have the latest and greatest software. The thing is that it happens to be that Docker is taking better care of their own software. Sometimes you better install software from the distribution repositories. In my opinion, if you want to work with Docker, just install it from the Docker repositories to get the best possible experience. So now we have done the apt-get update to make sure that the local operating system knows about these new packages. And finally, we can install everything required. I'm typing Docker CE, that is the community edition. Docker CLI, that is the package that contains a command line interface. And containerd.io is the container runtime. So this is the lower part of the solution. This is the part that really takes care of the containers. It happens to be that container runtimes are starting to live their own life. They are kind of being split off from the main container projects, and that is why it's important to have some awareness of containerd.io versus CRI-O, which are the most important container runtimes nowadays. And now, after saying yes, we can start using it. So now everything is installed and it's time to run our first container. I will later tell you that there's a better way than using sudo docker run hello world, but hey, at this moment we just want to get started, isn't it? So let's run our first container. So what do we see? We see that it's telling us that the image hello world latest could not be found locally. So it is pulling the image, and now we can see that the image is greeting us, hello from Docker. So we are good to go, and we can continue. So what are we going to do? Let's get back to the slides so that I can give you an overview and then continue this demo. So this is what I'm going to do. Again, for your convenience, the steps are on the slide. To make it easy for you, I'm just going to run it for you and explain everything that's happening here. So there is one thing that we need to do first, and actually that is not on the slide. The thing is that you can see that I have my user account. This user account is a member of a couple of groups, and I don't want to be running containers with sudo privileges. Really, that's dangerous. That shouldn't be happening. So I'm using sudo user mod -ag docker on my current ID, which is student. Now, in order to make sure that I can use these new privileges, there are two options. I can log out and log in again. I can also run a new shell, a new group shell. So if I use new group docker, then I'm in a new shell. And in this new shell, well, I'm a member of the group docker. As a temporary solution, that is excellent and very acceptable. But you might also consider just logging out and logging in, which is even slightly better. But hey, for now this will do. We just want to explore these containers, right? So I am going to start with sudo mkdir -p var www html. And then I am going to use sudo sh-c echo hello from docker, and I redirect that to var www html index.html. Just quick verification. If you do a cat on var www html index.html, then we can see hello from docker. In case you are surprised about what I'm doing here, I want to use a shell redirect. Just as a precaution, I'm using a double redirect instead of a single, because a double redirect will append, a single redirect will just crush and overwrite. That might not be what you want to do. So I'm using my hello from docker, and I'm writing the output to this new file. In order to do that, and because of the redirect, I need to use sudo ch-c. The ch-c is making sure that the shell specifics are working all right. And now we can see that we have a file hello from docker. And why am I doing that? I'm doing that because I want to show you how to run a container that is not just running a container, but also providing access to a file. And I know I'm going quite fast here, but that's for the simple reason that this course is about Kubernetes cKAD, and the purpose here is to provide just some insight into running containers. As I mentioned before, if you want more details about running containers, please check out my video course, Getting Started with Containers. So I'm using docker run -d. The -d is running the container in detached mode, that is in the background. -p is for port forwarding, because I want to be able to actually access this container. So I'm exposing port 8080 on my localhost, and I'm forwarding that to port 80 in the container. Next, --name is my Apache. You don't have to specify a name. If you don't, you get an automatically generated name, but that might be confusing, so it's better to use -name to specify your own name. Then -v is doing the bind mount, and in the bind mount, the container will get access to var www html, and it will map that to var www html, and then we are going to run httpd. Now the thing is that httpd by default is expecting its document root to be in var www html index.html, which in this way is fetched from the host operating system. In case you wonder why are we doing that, well, that is because in a Kubernetes environment, it is really recommended to access configuration that is stored in cloud. And if you want to access the information from cloud, you shouldn't put the configuration in the containers itself. And that is what I'm trying to show you here, to externalize the storage. And there we go, and we can see it's unable to find image HTTPD latest. That is common, that is what you will always see. Images need to be fetched from the registries, then they are stored locally, and then the container is starting if everything was successful. And here we can see it was successful. You can give it a try and do an SS tunap to see if you can see the port, because after all we did port forwarding, and there we go, we see this port 8080 is actually in a state of listening. And here Docker PS is showing us that port 8080 is forwarding to port 80 in the container, which means that if from the host I'm using curl http localhost 8080, that this is being forwarded to the container port. And there we can see, yay, this is a container port. And oh, we can also see that apparently this container image is reading another index HTML. Hey, that's going a little bit too far to troubleshoot right now. I think this is enough. And we have talked about storage and port forwarding and running containers. And you know what? Let's just go run another container. So I will demonstrate how to run another container, but first let's try to understand. I'm going to use docker run -it busybox. The -it will start an interactive terminal on the busybox container, and the result is that the busybox container is going to start its default application and I am getting an interactive terminal. And in order to get out of it, I can type exit, but typing exit would close the shell, which is the entry point application of the busybox container. So I need to do it decently, and I'm going to use Ctrl-P, Ctrl-Q, which is the disconnect, which keeps the container up and running. Exit is what you would use to stop the current container application. And if you are connected to the entry point application, the container will stop. And if you are connected to another shell session, the container will continue. Confusing? I'll show you. So let me demonstrate. To start with, docker run -it busybox. Again, it needs to fetch the image. That shouldn't take too long. These images are normally not too big. Now I can see a root shell, and in this root shell I am in busybox. And if I type ps or even ps-aux, then we can see what these namespaces are doing. So PID1 is sh, and sh is the entry point application in my container. Now let me first do it the wrong way. If I type exit, and next I type docker ps, then what do we get? I only get my HTTP container. Now if I use docker ps -a, then I can see currently running but also past running containers. And in the past running containers we have this busybox exited 14 seconds ago. Exited 0, so it exited with an exit status 0. That is going to be very important in Kubernetes as well. This means that the main application, we call that the entry point application, has stopped with an exit code 0. And exit code 0 means nothing wrong, all good. And that is just because I typed exit. There we go. And exit means that the shell right here received an exit command, so the container stopped. If that is not what you want, then let's try it again. Docker run -it, and let me do a Ctrl-P, Ctrl-Q. And now if I use docker ps, there we can see that busybox is still running. And that is because this shell is the entry point application. If it's your entry point application, then you can't just run exit and keep the container up and running. In contrast, if you use docker exec -it my apache sh, this is what I'm doing to open a shell in the Apache container. That's the running Apache container. I'm using ps-aux, and oh, ps is not even found. That's so typical about containers. Containers are minimal environments, and for that reason, your default commands might not always be around. So there's only a complicated way to figure out what's going on, and that is ls/proc, where I can see that I have PID1 and 10 and 101 and 12 and 9 and 93. Here on the left, these numbers are my PIDs, but I don't have PS to figure out what's happening. So if at this point I do want to know, the best thing I can do is cat on /proc/1/cmd line, and there we can see, oh, this is HTTPD foreground. That means that at this point I'm in my shell, but the shell is not the entry point. So if I type exit, then nothing is going wrong. Docker ps is showing that the container is still running. And that's about it. Let's continue. Let's explore a little bit more of things that you can do to manage containers, and then move over to the next lesson. So in this quick introduction to working with containers, let's do a quick review of what you can do to manage containers. So there's a couple of commands that are involved. I want to walk you through the commands and then I want to demonstrate what they are all about. We have already seen docker ps with the option -a to show currently, and if you use -a, also past running containers. That is nice to get an overview of what is actually going on. You can use docker start to start a container from a locally stored image. You need the image to be present already. And docker stop will stop a container using Linux cKterm. Linux cKterm is the Linux way of gently asking the container, hey dear container, can you please stop? Docker restart will restart a currently running container, and docker kill will stop a container using Linux cKill. That is like kill -9, and you should only do that if the container is not stopping decently, if you ask it politely. Docker rm is interesting as well. The thing is, if you run a container, then the image is fetched. On top of the image, a read-writable layer is created, and this read-writable layer contains all modifications that you are making in the container. If you only run the container to check out what it is doing, then you might end up with a lot of stuff roaming around on your computer, and then to get rid of it, use docker rm to remove that. Also quite interesting is the ability to inspect containers. So docker ps will show the IDs of containers, and then you can use docker inspect on that ID, which by the way works on a name as well. And you can also use the JSON path, like docker inspect -- format is .network settings .ip address on a container name. Docker inspect will show you all that is going on in the container in JSON format, and this -- format option allows you to filter out what exactly you want to see. Likewise, you can do .state.pid to check out the PID. And alternatively, you can also use ps-aux on the host to find the container PID. Let's go check this out. Alright, so docker ps -a is showing all that's going on and that has gone on. And if we want to find out what is going on, we can use docker inspect. And I am going to use that on the automatically generated name. Do you see that right here? We have this busybox container that exited 8 minutes ago, which has an auto-generated name, which I'm going to use here. And that is showing me all of the different settings that are applied to this container. Maybe more interesting to do this on a container that is still running. So Vigilant Saha. Let's do a docker inspect on Vigilant Saha. And that is showing us that, yeah, we have some IP address information. Of course, if you have a running container, there is more information to be seen about what is going on than if you have a container that has been stopped already. I'm running it through a pipe less so that we can see it page by page, and you can see different settings of how the container has been started, about the resources that have been allocated. We haven't done anything, but this is where you can see resource related information, path related information, and really you can see everything, and that is pretty cool. Now, if you want to approach a container in a scripted way and to filter out specific information, you can use these JSON paths, like .network settings, .ip address on your container name. Do we still have Vigilant Saha? I think so. There we go. So how does this work, this JSON path? Well, if you get back to docker inspect, then we can see right here the items are listed. So there's a leftmost indentation. We are looking for network settings, which is right here. And in network settings, I am looking for IP address. So in this way, you can address everything you want. You can also do, for instance, .network settings, .networks, .bridge, network ID, if you want to fetch the network ID. This works for everything. One more, docker inspect. Make sure you take your JSON syntax the right way, including the cases and so on. And there you can see, oops, that I'm making an error. It is docker inspect -- format. -- format is really required if you want to use these filters. So state.pid for vigilant Saha, and we have the container PID. Right, if I use PS AUX, or better PS facts, then we can see the containers from the perspective of the host operating system. So PS facts pipe less, and we need to go a little bit down, and if we go down far enough, then right here we have the 7328. Look at this. This is my HTTPD. How can we see that this is related to a container? Well, because of container D shim. Right here, container D shim run CV2. That is a container runtime. And this container runtime has started this container, and in this container we have a running HTTPD. And likewise, you remember the PID 7639, which is also visible as a process here that is managed by container D shim, the container D runtime. The nice thing is that all these containers from the perspective of the Linux operating system are just Linux processes. So container D shim is running sh, and if you are into the container, you can only see the contents of the container because of namespaces, but these namespaces do not apply if you have administrative privileges at the host operating system. So let's talk about managing of container images. After you fetch them, container images are stored on the host. And you can use Docker images to get a list of images. And if you want to manage them and explore the different options, use Docker image -- help. Let's go check this out. So if I type Docker images, I get a list of all my images, where you can see the image, including the size of the image. And it's nice to see that these images are not too big. Now, Docker image can also be used to give you a little bit more options of working with images. Like, for instance, Docker image ls. In case you want to know, why would you want to do that if Docker image ls is giving the same as Docker images? Well, in the Docker command, there's a new approach, and the new approach is to include the thing on which you want to work as the second level of the command. So instead of Docker images, use Docker image ls. Instead of Docker ps, use Docker containers ps and stuff like that. There's Docker image, there's Docker containers, there's Docker network, there's Docker volumes, and more of these commands, which become pretty useful if you get deeper into working with Docker. But if you just want to do it quick and dirty, that's okay as well. Now, what is important? I think Docker image ls is important. Docker image inspect is also quite interesting. So if I use Docker image inspect on the cABB, oh, no command completion here. Well, let's use the mouse then. And paste it right here. And there we can see the JSON code behind the image. Now, what is there to know in an image? Well, at least you might want to know about the environment. And most important, the CMD. This is the entry point command. And the entry point command, that is the default command that will be started when you are running your container. And if you come from a Linux background and you think, oh, that's a weird way of writing your command, yeah, that is right. You write the command in array notation. So every single item in the command is specified as a comma separated list item. So bin sh -c nop cmd /sh. But hey, we will investigate this a little bit more in detail when we talk about Docker build and Docker file in the next lesson. Is there anything else that we want to know about this specific image? I don't think so, but I do think it's interesting to get some insight in here. So if you want to get rid of your images, that's possible as well. So I type my Docker image ls and Docker image rm. Or if you want Docker RMI, that would also work. On FAB5D9FEA6A5. And oh no, what do we get? We get an error message that the image is currently in use. This is confusing as well. We don't have this hello world container running anymore. So you might think it's gone and we can remove it. Well, if you want to remove it, you need to remove it, including the container. Because even if your container is stopped, the container files are still on your local file system. And if you want to really remove the container, well, we have seen that on the Docker container you can use RM, but you can do that on the image as well. And if you try to remove an image of a container that is still there, then you need to force it. So docker image rm-f to remove it. And that will really remove it. Now it's really gone. Do notice when you are using the Docker command, we have docker image rm, which is a command. This command has options. These options are mandatory behind the name of the command, not behind the name of the container, not behind of the name of the container image, because everything you put behind the name of the container or container image would be interpreted as an argument to the container, as a container internal command, and that's not what you want. Right, I think this is about all you need to know about Docker images for now. Let's continue with the next video. In this last video, in this lesson, I'm going to tell you about Docker logs. We need to understand what containers are doing with our log files. So the container application does not connect to a standard out. And that is why logs by default are written to the container. Let's face it, if you use docker run -d to start any daemon, you don't see the output of the process. You just see your prompt back again. And if you want to figure out what's going on, you need a command to do so, and that's docker logs. Docker logs allows you to connect to the standard out that was generated by the container while you were starting it. And that's very convenient. Especially for troubleshooting. Let me show you how Docker logs can be used in an ultimate troubleshooting for beginners lab. So here we are on the demo machine, and I'm going to use docker run MariaDB. Can't find the image locally, so it needs to fetch it. That's normal. Here we can see all the different layers that need to be pulled. Once the layers are pulled, it should be able to start the container. And I'm cheating here because docker run -d. I did not use a -d, so the output is printed right here. But hey, if the output is not printed right here, then you will have a hard time. So let me run it again, this time with the -d option. There we go. And what is Docker PS showing us? Docker PS showing us that nothing's going on. No new containers. So we need to investigate using Docker PS -a. And what do we see? We see that we have MariaDB. Pensive Alice is the automatically generated name that we can see all the way back to the end. But the most important thing is we have a status exited 9 seconds ago. So it exited with exit code 9 seconds ago. And exit code 1 means that we were not successful. And this is where Docker logs is handy. Don't use Docker logs when you see exited 0, because exited 0 means that the main application has stopped successfully. And there's nothing to investigate. But this time we do need Docker logs on Pensive Alice. And there we go. And we can see what's going on. Database is initialized and you need to specify one of whatever. And you know, if you would have done your homework properly, you would have investigated the images on Docker Hub and you would have read that this container needs an environment variable. But hey, who is doing that? Not many people do. So it's no problem as long as you know what you are going to do to figure it out. So what are we going to do? Well, in order to run it, I'm going to use docker run. And this time --name mydb. I like to give it a name as well. MariaDB -e, my SQL root password is password. And what do you think? Is this going to do any better? Well, we can already see that this is not too happy because it's giving me a MySQLD unknown option -e. Now what is this? This is the very classical error that beginners always make. From a Linux background, you might be used to providing your environment variables all the way to the end of the command line. That's not how it works in Docker. In Docker, the thing that is last is your container image. And everything that comes after the name of the container image will be interpreted by the container image. I need -e to be interpreted by the Docker command. So let's switch the order and let's put MariaDB all the way to the end. So this is a successful command, right? And oh no, another problem. The container name MyDB is already in use. That's also that I wanted to show you now that we are talking about troubleshooting. What is going on? Well, we just created a MyDB container. And even if the MyDB container was not created successfully, a couple of files have been created to your computer and they do exist. So the really Docker RM MyDB, we need to remove it and then we can try it again. And this time, hopefully, we are in business. Docker PS is showing us that the MariaDB image name MyDB was started 4 seconds ago and up 3 seconds ago, and we are in business. And that is how Docker logs is convenient. And hey everybody, in case you are wondering how does that relate to Kubernetes? Well, in Kubernetes, you will see kubectl logs. It's exactly the same story, but a little bit more complicated as the cloud is involved as well. Hello and welcome to lesson 4. In this lesson I'll teach how to set up a lab environment that is based on Minikube. I'll first give you an overview of the different options for deploying Kubernetes, and next you'll learn how to install Minikube on either Linux, Windows or macOS. You'll also learn how to work with it. Once it is done, I'll show you how to run your first application in Kubernetes. In this video, I want to talk about container image architecture. So what is there to know? Well, you should know that the container image itself basically is a tar file with some metadata. That's it. And to build container images in an efficient way, it typically consists of multiple layers. And that is because every image contains components that are common to other images as well. Let's just say you want to run a database. The database needs some operating system common stuff. So this operating system common stuff, you can invent it for yourself. You can also fetch it from one of the standard images, like BusyBox. So while building an image, base system images normally are used. And these base system images, these are your BusyBox or your Alpine, if you want to go for minimized cloud images. Or if you want to go for some more feature-rich images, your Ubuntu or Fedora or UBI if you're in a RHEL environment. But all these images have some base components that you are going to fetch from a base system image. And on top of that base system image, the application is installed as an additional layer. And from that comes that the images are always layered. And behind the scenes, there's the image layered file system taking care of all these layers and representing them as one big file system. But that's something that you don't need to worry about. You should only know that there are these layers, and some of the standard images themselves already consist of multiple layers. And using these layers ensures that images are built efficiently. In the next video I'm going to show you how that works, but first I'd like to make a quick drawing to visualize what these container images are all about. In this drawing I want to visualize what these container images are looking like. So let's say that you are creating a container image that runs on top of a database, for instance. Now, what are you going to use? Well, you are most likely going to search for a database image. Let's call that database image MyDB. Now, if you are using a database image, this database image by itself is built on top of something else. And that might be a generic cloud Linux image, like Alpine, for instance, or whatever. And then on top of your database image, you are going to run your own application. So that will be my app. But if you think that your application is one single application layer, that's probably not the case, because your app will run on top of your dependencies, and every single addition to that image will create an additional layer. Likewise, if you look at the database layer, for instance, based on what has happened in this database, you will find different layers as well. Because the database has not been constructed with one command, that will be several commands. Likewise, for the underlying Linux container image, you will find different layers as well. And that is why when you use a Docker pull, you will see that all these images are being pulled. Now, all these images are managed by the overlay FS driver or whatever overlay file system driver, and that makes it more complex. And that is why, if you are going to build your own images, you should always make sure that you reduce as much as possible the amount of layers that is going to be used in your container images. So in this video, I would like to talk about tagging container images and some other container image management options. So to start with, let's talk about these image layers. Docker image ls shows the images that are stored, including version information, using the tags. If you want to remove images, there is Docker image rm. Docker image history is really the command that you want to use to show the different layers in the image. The old notation is Docker history, the new notation is Docker image history. If you want to address it the right way, Docker image history is the preferred way nowadays. Each modification that is made in an image adds an image layer, and for manageability it's recommended to try to reduce the number of image layers as much as possible. Another important task is tagging your images. So tags allow you to assign names to images, and that makes it easier to manage the different image versions. And if no tag is added, then latest is used as the default tag. So if you refer to images, you don't specify any tags, that's okay, latest will just be used. You can manually tag images using docker tag followed by the name of the image. And then you will see the image twice. Every single tag that is set on the image will show as if it were a different image versions. Tags can also be used to identify the target registry, and that might be required before you are doing a Docker push, which is the command to upload images to a registry. For instance, there is an option to run a registry on your local host. That will be on port 5000. And if you run that registry with the appropriate port forwarding, then docker tag image name localhost colon 5000 my Apache colon 1.0 will be the way how to get it there. Let me just demonstrate how you can work with tags a little bit. So let me start with Docker image ls. Docker image ls is showing the different images, and here you can see these famous tags. So if I'm going to use docker tag MariaDB localhost colon 5000 MariaDB colon latest, then this is the result, and Docker image ls will show you what it looks like. So you can see that right now I have two different entries for this MariaDB image. And then Docker image, don't forget that Docker image is the main level command, and in Docker image there is Docker image history. So again, historically you can use Docker history or Docker image history, but definitely Docker image history is the preferred way. And if you want to see what has happened in order to get to MariaDB latest, Docker image history is telling you. And in this Docker image history, and this is what makes it important, you can see the entire history of the creation of the image, which allows you to investigate where exactly the image is coming from. So that's giving you nice insight into the layered file system that has been used to work with your images. In the next video, we are going to explore options to create your own images. So in this short video, I will tell you about the different options to create your own images. In the next videos, we will explore them in more detail. So what can you do? Generically speaking, there are two main approaches to create an image. You can create an image using a running container. So the approach in there would be that the container is started and modifications are applied to the container. And you are going to use the docker commit command to write the modifications. It's a convenient, relatively easy way, but it's not the most efficient way because you really need to take care that you do proper cleanup of your container before you actually write the image. Just face it, if you would use yum install to install a package on your Fedora machine, then you would get a package cache. And if you don't clean up the package cache, that is easily 150 megabytes of wasted disk space. The most common way to create images is to use a Docker file, also known as a container file, where this Docker file contains instructions for building an image. And each instruction adds a new layer to the image, and that offers more control over the files that are added to the image at a later stage. You can really see the Docker file as kind of a script that can easily be used, can easily be ported, can easily be executed in any environment. So if there's anything you want to focus on in order to create your own images, focus on the Docker file. In the next two videos, you will learn how to work with both of them. In this video, I'll tell you about options for building custom images. So what are these options? First, there's Docker file, which is also known as container file. That's a very common way to build custom images. In this solution, the descriptive file is used, which uses a base image in which commands are executed to customize it and to add your own stuff to it. Docker commit or Podman commit commits the changes that are made in a running container to the container image, after which Docker save can be used to save it. And builder can be used to create, modify and manage container images. Now, while talking about Dockerfile, you need to realize how the terminology is working. Dockerfile is the original terminology, which was introduced by Docker. If you are working with Docker, you use Dockerfile, period. But OCI has standardized the name to container file. As a result, well, Dockerfile should be used while working with Docker. Container file may be used while working with Podman. Podman is more flexible because in Podman environments, Dockerfile is supported as well. While working with these, parent-child images are common. So a child image is an image that is created from a parent image and it incorporates everything in the parent image. And starting from a parent image makes it easier to create a reliable image. So how does that work? Well, your own customized image consists of different images. The parent image is just a generic image that is going to be included, and the child image contains your own customization. And depending on how you are creating your Docker file, multiple child images can be created. In the process, you will first create a working directory. Each project where you work with a container file should have its own project directory. And next you will write the Docker file. The Docker file contains instructions to build the image. And the most important part in the Docker file is the default command that it will start, which is done by using either entry point or cmd. Finally, you build the image with Docker build or Podman build, depending the environment that you are using. In the next lesson, we'll see how that works. In this video, you'll learn about using Dockerfile, also known as container file. So first, let's talk about the terminology. Dockerfile was originally introduced by Docker to automate building container images. In Red Hat environments, the word container file is preferred because it doesn't contain a brand name. But currently, the Docker utility only supports Dockerfile, and Podman works with Dockerfile as well as container file. And for that reason, as it's the only solution that works in both, I am going to use the word Dockerfile throughout this video. So how do you write a Docker file? Well, each Docker file starts with from, which identifies the base image to use. And next, instructions are executed in the base image to build the custom image. The instructions are executed in the order that is specified. Each Dockerfile instruction runs in an independent container using an intermediate image which is built from a previous command. And that means that adding multiple instructions results in multiple layers. And having multiple layers makes the image less efficient. So that should be avoided. In a Dockerfile, you will have an entry point. Entry point can be used to specify the default command which is to be processed. But there's an alternative. You can also enter the default command in CMD. If entry point is not specified, then implicitly /bin/sh-c is executed as the default command. Arguments to the entry point command can be specified separately using CMD. Or, as I just mentioned, you can specify everything in CMD. It looks like this: entry point command, as in entry point, and then between square brackets, single quotes, the entire command. And if you use a CMD, well, in CMD we have the array notation, where all of the arguments are comma separated and presented between double quotes as well. So it's important to realize if the default command is specified using CMD instead of entry point, the command is executed as an argument to the default entry point ch-c. In some cases that may give unexpected results, and that is why you might want to consider using entry point instead. If the command or its arguments are specified using entry point, they are not supposed to be overwritten from the command line. It's not that it's impossible, it's more difficult to overwrite commands and arguments that have been specified as an entry point. Now, while using entry point and command, you can use different formats. And that also goes for add and copy. They can be presented in shell form or in exec form. Shell form is what you could call the classical way of doing stuff in a Linux environment. It's just a list of items. So add my file, my dir, or entry point user bin nmap. And as you can see in the user bin nmap, we have the complete entry point command. Exec form is a JSON array of items. And exec form definitely is the preferred way to specify nowadays. So you would have add my file, my dir, where my file as well as my dir is presented as a comma separated list between double quotes each. Likewise for entry point user bin nmap -sn, followed by the argument where each element is between double quotes and comma separated. So using this exec form is the preferred way of doing it because it's a clearer way and it avoids confusion. Now, while building your own Dockerfile, you should avoid using multi-layer images. The thing is that each command that you use in a Dockerfile to create your custom image creates a new layer, and that should be avoided. So don't run multiple run commands, but instead connect them using $&. And that would look like this: run yum ---- disable repo, $&, yum update, $& yum install nmap. And to maintain readability, it's good practice to put the $& with a backslash behind it at the end of each line, so that it will look like this. And it is very clear that in this run statement, 3 different commands are executed. Now, once you have created your Dockerfile, you can use docker build or popman build to build the image. This command takes 2 arguments, -t followed by a name and an optional tag, and the directory, where directory can also be a dot to refer to the current directory. And if the tag is not specified, the image is tagged as latest. So docker build -t myimage dot would be a valid command if in the current directory there's a Dockerfile. Let me show you how to build images based on Dockerfile. So in the course Git repository, you will find a Dockerfile subdirectory. And this Dockerfile subdirectory contains a Dockerfile. In case you don't have the course Git repository yet, let me show you the command. It would be git clone https://github.com/sander-van-vught/cKAD. So if we have a look at Dockerfile, this is the contents. What do we see? We see a pretty basic installation that is using from CentOS 7, maintainer, it's a maintainer address. Add will copy a file into the custom image, and then it's using a run to install some software. And finally, there's the entry point and the CMD, which will build the image for you. So how does that work? Well, docker build minus t nmap dot. That would be enough. And look at that. Apparently, it has found some information in cache, and it has built the image. So we can use Docker images to verify that the nmap image has been built successfully. And indeed, I had already done it a couple of weeks ago, so it hasn't changed anything. Hey, as it hasn't changed anything, let's add no cache. And there you can see that it is really starting all over again. That's a little bit more interesting to see. As you can see, it fetches the software and it starts installing everything. And in the end, the result is a brand new nmap image, which is a custom image, and I can start running right now. So let's verify. Docker images is showing the image. There we go, 4 seconds ago. That's the nmap image. So I can use docker run nmap to run it. And there it's starting nmap. So that's all you need to know about Dockerfile. Let's move on. In this video, I will show you how to use an alternative way for creating your own custom images, and that is using Docker commit. So after making changes to a container, you can save these changes to the image, and you use Docker commit to do so. So a command would look like docker commit -m custom website server -a Sander van Vught my Apache, and you can use Docker images to verify. And after using Docker commit, you can transport it to a tar file. Use Docker save to create the tar file and Docker load from the other system to import it. Let's go check this out. Okay, in order to use Docker commit, we need a running container. So Docker ps is giving me an overview of running containers. I am going to use Docker exec -it to my Apache. And I want to open a shell. I'm using sh rather than bash because sh is normally there. Bash is not always installed. And let me just create a file, echo hello greater than /tmp hello file. Oh, ls -l in tmp hello file. Will show us that the file exists. Now I'm getting out of it. As this is not a primary process, I can safely use exit without affecting the current status of my container. And I can use a Docker command to figure out what has happened. Let me just do this Docker tab to give you an overview of all the different commands that are available. As this is not a full container course, but just a quick introduction to working with containers, we haven't been able to talk about all of them, but there are so many nice options to work with your containers. So Docker diff my Apache, for instance, which is doing what? Well, this is showing a list of differences of the my Apache container with the original state from the image. And as you can see, there are differences, including the tmp hello file. All right, so you can also see there's a C for changed, there's an A for edit. Let me also use docker commit --help for an overview of all that can be done, and there we can see how to use it. So docker commit with the options. The options are not really important. Then container, that's the name of the container, and then we have the repository colon tag. So that is what you can use to identify the new name. So what am I going to do? Well, I am going to use docker commit. What was the name of this thing again? My Apache to my Apache. And the result, Docker images, is showing that my Apache 3 seconds ago was built. So at this point, I have my own my Apache image. Nice. So now I can use Docker save -o myapache.tar myapache, and that will save it to a tarball, and I can transfer this tarball to somewhere else. Or I can just upload this myapache to any image registry that I would like to use. It's up to you what you want to do with it. So here you can see myapache.tar. Of course, I just created a tarball. I did not compress it. This is how you create the tarball. You can transfer it to another environment, and on the other environment, people can start using it if they want to. I think this is enough about Docker commit. Let's go wrap it up. To start with, I want to make sure you understand what Kubernetes is all about and why we even need it. So what is Kubernetes? Well, as described on their website kubernetes.io, it's an open source system for automating deployment, scaling and managing of containerized applications. Let's investigate. The word Kubernetes comes from the Greek language and it means captain of the ship. And that's why many of the symbols in the Kubernetes ecosystem also refer to shipping items. Probably because it's all about carrying containers, so container ship, right? That's what Kubernetes is about. Kubernetes is currently owned by the Cloud Native Computing Foundation, or CNCF. CNCF is an open source foundation within the Linux Foundation, and that's good. Linux Foundation has a long experience dealing with open source software and making sure it remains open. And the fact that CNCF is the owner of Kubernetes makes that Kubernetes is probably going to be available for everyone forever. Kubernetes is not just software. It's not even a product. It's an ecosystem. It's providing a core solution with many third-party add-ons, which are provided by approved projects focusing on different areas. Good to know for cKAD. cKAD is focusing on the core solution, not so much on the ecosystem. So at the moment that ecosystem comes in, as for instance, when you need to talk about ingress, there are multiple options. That's outside of the scope of cKAD. CNCF wanted to provide a Kubernetes certification that doesn't make any preference for items from the ecosystem. It's just about the core solution. So what do we find in the ecosystem? Well, solutions for networking, solutions for ingress, for monitoring, for packaging, and so much more. Now let's try to understand the nature of Kubernetes. Kubernetes implements a platform to run container-based applications in a cloud-native computing environment. And that is so different from running applications on a server. In a cloud-native computing environment, you need to store your information in cloud. And that's exactly what Kubernetes is doing. And that is special because the application does not have a direct relation to any server. So as a result, all that is needed by the application needs to be stored in the cloud. And to successfully run your applications in the cloud-native computing environment, specific properties must be provided. And that's what Kubernetes is all about. Kubernetes is offering Kubernetes resources to provide for these properties. And these resources are defined in the Kubernetes APIs, all of which we are going to investigate much more in the next couple of videos. Now, how about Kubernetes competition? That is easy to understand. Kubernetes is open source, and as such it's available to everyone and any company. And the open source nature of Kubernetes allows companies to use a very strong common code base and focus on features that the specific company wants to add to that code base. And for that reason, there is no real serious or significant Kubernetes competition. There are Kubernetes distributions. We will talk about Kubernetes distributions in the next lesson. The only thing that needs to be mentioned here is Docker Swarm, which was created by Docker Inc. As a solution to orchestrate containers. But because of Kubernetes, it has become pretty much insignificant. Now, how about these distributions? Well, there's vanilla Kubernetes. Vanilla Kubernetes is Kubernetes directly created from source code hosted by CNCF. Many people are using vanilla Kubernetes, but there is also Kubernetes distributions. And these distributions are adding specific functionality and a selection of solutions from the ecosystem. like Google Anthos and Red Hat OpenShift and SUSE Rancher and Canonical Kubernetes. So there are more distributions available. It doesn't matter too much because they all go back to the same open source software. Now, before we continue, there's one more thing that you need to really understand about Kubernetes. There is a new release every 3 months. And when a new release is published, new versions of the APIs may become available and old features may get deprecated. And if a feature is deprecated, you should immediately adopt the new method, as the feature will go away within the next 2 releases. Hey, one more thing about the release cycle. You are watching a recorded video course. What are we doing to make sure you have the most up-to-date information? Well, first, I will always make sure that the information in the GitHub repository reflects the most recent changes in the software. And every time it is really necessary, we just record a new version of this video course. So you will get new versions every now and then. We try to follow along with the dynamics of Kubernetes in this video course. In this video, I would like to talk about the origins of Kubernetes. And that is because knowing where Kubernetes is coming from really is a part of the explanation of its success. So where does it come from? Well, simple, from Google. Google has had an internal system with the name Google Borg, and that is the Google system that has been used for over a decade to orchestrate the Google container-based applications. And then we are talking about all the applications that Google is offering in their worldwide cloud environment to make sure that we can use the Google search engine and Google Docs and Google Maps and all that kind of stuff. So you can actually say that that's based on a pretty big environment where scalability and availability always have been a top priority. So in 2014, Google has published this document, and you can find the link right here, which has been the blueprint for the Kubernetes project. Borg not only was the origins of Kubernetes, it also was the origins of pretty important Linux features that are used in containers nowadays. Think of namespaces, think of cgroups, which both were proposed by Google as an addition to Linux. And it shouldn't be a surprise that Google internally was running their applications on top of Linux as well as the orchestration platform. So Google has donated the Borg specification to the Cloud Native Computing Foundation. We already talked about that, and that was a pretty smart idea, because by donating the Borg specification to CNCF, it is guaranteed that this specification will be available as open source software forever. So why is this open source so successful? Well, just imagine all the investment in time and money that needs to be made for a company to produce something that is similar to Kubernetes. Instead of investing all that time and money, companies can now work together on a common code base and focus on the additional value that the company wants to provide on top of that. And that's why Kubernetes is the worldwide standard for container orchestration. In the next video, before we can go further in depth, we are going to have a look at Google Cloud. That is Kubernetes in a Google Cloud environment, so that you can already have your Kubernetes sneak peek. So in this video, I want to help you to get started with Kubernetes. That is before we are going to set up our course lab environment. I would like to show you how Kubernetes is working in a Google Cloud environment. And I'm using Google Cloud for the very simple reason, not because Google is the only cloud where you can use Kubernetes. Kubernetes can run everywhere, but in the end, we have Kubernetes because of Google. So it's my little way of saying thank you, Google, by demonstrating Kubernetes in Google Cloud. Notice that if you do not have a Google Cloud account yet, just register. As a new customer, you get $300 of free credit in Google Cloud, and that allows you to learn a lot about Kubernetes. I am going to click on console, which will bring us to the Cloud console. There we go. And in the pane on the left, we are going to have a look at Kubernetes engine, because Kubernetes engine, that is what we need. And in Kubernetes engine, we want to get started with a simple cluster. So I'm clicking clusters. And there we have a create option. So we are going to create a new cluster. It's very easy to set up one of these managed Kubernetes environments. And a managed Kubernetes environment, that is just good enough to get yourself started. So I'm using create. And then it's asking what we want. Well, definitely we want GKE standard. So I'm clicking on configure. And then it is going to load the next page. There we go. Now, in this next page, the thing that really you want to do is my first cluster. Because you want to learn Kubernetes, right? You don't want to run it into production. If you want to run it into production, here are all the different options that you can select to specify what exactly you want to do. But for this first encounter with Kubernetes, we are going to use my first cluster. Based on your Google account settings, it will automatically select a cluster name and a cluster zone. The cluster zone corresponds to your default zone in Google Cloud, and all the other things, including some more minimal machine types. The entire purpose of that is to make sure you don't spend lots of money on your cluster. Using my first cluster will cost about $4 if you are talking about the US Central region. That is $4 a day. So if you leave it up and running for a month and you need to pay for it yourself, it's something to pay attention anyway. But before we are getting started, I think it's a nice way to learn about Kubernetes. So here we can see that my first cluster settings are applied and it's submitting, and now you need to wait for a little bit. The wait will take about 5 minutes, more or less. Depends a little bit on how busy it is, and honestly I don't know what exactly it depends on. But in about 5 minutes you will have your cloud up and running. You can already see what it is doing. So it has a name for the cluster, my first cluster. The location is US Central, Central 1. Then we have the number of nodes, which is set to 3. The number of nodes is really important for running your applications, because the more nodes you've got, the easier it is to load balance access to your actual application. 3 nodes is a nice minimum. We are going to do it even better later when we are going to install Minikube in a virtual machine. And there you can see the rest is being allocated right now. So for the remainder of it, we just have to wait a little bit. So here we have the cluster up and running, 3 nodes, 3 vCPUs, 5.1 gigabytes. And now we need to be doing something with it. So how are we going to do that? Well, we click on Actions. And in the Actions, there is the Connect option. We first need to connect to the cluster. So there we go. And in order to connect to the cluster, we need to use command line or dashboard. For cKAD, you want to focus on command line, definitely. There is a dashboard, and this dashboard is pretty nice, but really it doesn't get you through all the assignments on cKAD. So I am going to run, I'm going to click this command, the gcloud command, and I'm running it in the Cloud Shell, and that will open a Cloud Shell, as you can see right here. But before we can use the Cloud Shell, we have a virtual machine that actually needs to be deployed. So that can take a little bit of time. It comes with a disk, this Cloud Shell. If you don't want it, and if you want it to be faster, you can also enable ephemeral mode. For what we are doing here, ephemeral mode, in fact, is good enough. Because we are only going to spend a few minutes here in the Google Cloud environment, so that you know what is going on and can discover a little bit. Later in this course, in the next lesson, I will tell you how to set up your own course environment. But you can see that, well, speeding it up a little bit, it's not too dramatic, it's already there. So let's click this away, and there we can see the gcloud command. So in the gcloud command, this is a Google Cloud command. This is not a course about Google Cloud, so I'm just going to press enter here and authorize to ensure that Google Cloud is allowed to do whatever it wants to do. And here I can see that I am in my first cluster 1. I'll tell you all about Kubernetes and what you can do in this Kubernetes environment later, but for now I do want to tell you kubectl is the main Kubernetes command line utility, and kubectl get all will give you an overview of all the resources that exist in Kubernetes at this moment. And you will see that's not very much at the moment, but that's okay. This is a brand new cluster. And in this brand new cluster, we need to start configuring our stuff. That's what we are going to do in the next lessons. But at least at this point, we have something that allows you to get familiar with Kubernetes. In this video, I want to tell you about Kubernetes management interfaces. So in order to understand the management interfaces, first we need to talk a little bit about the Kubernetes API. The API, or Application Programmers Interface, in general is the interface that is used between a client and a server. So the client is generating requests that are understood by the API because the requests match the API interface. The API is used to standardize how to access items that are provided by a server. And you will find APIs everywhere. It's a generic programmatic item that you will find in any program, especially client-server architectures. The Kubernetes API provides an interface, but it also provides access to all that is needed to run containers in a cloud-native environment. I will tell you in more detail what exactly is involved later on. In order to work with Kubernetes, there's a couple of options. The kubectl command line utility is the main option. It provides convenient developer access, which allows you to run many tasks that are related to your application. And kubectl is the only interface that really matters for cKAD. Also, you can use direct API access, but that's more advanced, and it allows developers to address the cluster using API calls from custom scripts. Curl is the utility that you would typically use for direct API access, and I will demonstrate you much later in this course when that can be useful. Briefly, using direct API access is very uncommon, but it can be useful to get more insight in the workings of Kubernetes. Then there is also the Kubernetes dashboard, which can be installed to run on the Kubernetes master node and provide web-based access. The disadvantage of the dashboard, however, is that the dashboard is specific to specific environments. If you are, for example, going to search for the Kubernetes dashboard in Google Cloud, you will notice that Google Cloud has integrated web-based management in a very much different way. Also, Kubernetes dashboard is useless for the cKAD exam. Don't waste your time on it. So in this course, we are going to focus on kubectl. kubectl, as I mentioned, is the only interface to Kubernetes that you will need. And it has a lot of options, which allow you to manage everything that your application needs in a Kubernetes environment. A good start is to use kubectl -help for an overview of all the options. And as I mentioned, for cKAD, really it's the only command that matters. Only at the moment when you are going to do your CKA, your Certified Kubernetes Administrator, you are going to use kubeadm as well. But that's not the topic in this course. The very first command to use with kubectl, well, I would advise to just type kubectl create deploy myapp -- image is my image. Make sure to replace my image with the name of a real image to run your first application. And then you can use kubectl get all to see all that this command has created. Let me just do that for you so that we can investigate. So here we are back in the Google Cloud environment. And I am just going to type for you kubectl -help to start with. I want you to have an overview of what this command is doing. And again, don't worry about it too much. We are going to investigate all the components that really are necessary for cKAD as we move forward in this class. But here you see that many subcommands are available. kubectl create is one of the most important commands. And by the way, instead of typing -help, you can also just use -h. So if I use that -h, then you can see a lot of stuff that probably you don't understand too much about right now. So let's create our first application. kubectl create is how you do that. But kubectl create needs more information. It needs to know what you want to run. And I want to run a deployment. The deployment is the application itself. It is an API resource that allows you to run an application. I will shortly make a nice drawing to explain all about these API resources. For now, I'm just using kubectl create deploy my first app. -- image is nginx, -- replicas is 3. In cKAD, we are not so much interested in all the different applications that you can run. So you will notice that many examples that I'm using are all based on either BusyBox or nginx or MariaDB. It's about Kubernetes, it's not about the application itself. And here we are running an nginx application with the name My First App, using a deployment because that is how Kubernetes runs applications. And we implement some scalability as well by using -- replicas is 3. And now we can investigate using kubectl get all, and that is showing us that the application has been created as a deployment. The Kubernetes API, while running the application, has created a replica set to take care of the replication, and it has created 3 instances of the pod. So, yay, we have successfully started our first application. About what you can do with it, you will learn later. For now, this is good enough. Let's continue with the next video. In this video, I want to give you an overview of the Kubernetes architecture. So if we talk about Kubernetes architecture, then to start with, we have the different nodes. And the most important node in your Kubernetes cluster is what we call the control node. Apart from the control node, we have multiple worker nodes. There's always more than one. Just to keep it easy, I'm drawing in just one of the worker nodes. So what do we need from an architectural perspective on the controller node and the worker node? Well, to start with, you need a container runtime. So let's say that is container D. Even if container D is not the only runtime that is available. But Kubernetes is all about containers, and core components in Kubernetes run as containers as well. So a runtime is what you need to start with. On top of that, you need the kubelet. And the kubelet is going to be used on all of these nodes as well. The kubelet is a Kubernetes part that interfaces the container runtime. Part of Kubernetes that talks to the kubelet and makes sure that if you are going to run a container, the scheduler will schedule it somewhere. There is the kube controller manager, let's call it C manager. The controller manager that is taking care of generic cluster operations. And of course, there is the Kubernetes database itself, which is the etcd. And all of that is running on the controller node. Now you are going to interface with Kubernetes, and in order to interface with Kubernetes, you will use a client, and typically that client will be the kubelet. And the kubelet is talking to the API server, so you use the kubelet to run commands like kubectl run to run a pod. And when you run a pod, then the controller manager is going to be involved to make sure that it's directed the right way. The scheduler will get in contact with the kubelet to put it on one of the worker nodes. And at the same time, your pod definition, as well as your pod status, is written to the etcd. So from the kubelet, you really get an arrow back to the etcd, updating whatever is happening in your Kubernetes environment. Now we are going to use Minikube in this course as an all-in-one solution, so you don't even see these different nodes. But in a typical Kubernetes cluster, you will have multiple controller nodes, multiple worker nodes to take care of your containers in the Kubernetes environment. So in Kubernetes, to run applications, different API resources are provided. I'd like to talk a bit about API resources and make sure you fully understand what this is all about. So after you are using a command like kubectl create deployment myapp images nginx replica sys3, the myapp application is started in Kubernetes. We have just done it, and you have just seen how this application is implemented using different resources. Each API resource is required because it adds functionality required to run an application in a cloud-native environment. And why is that required? For the simple reason, because running in cloud-native changes the entire application behavior. If you run your application on a standalone server, your application can fetch its information from the hard disk. But which hard disk are you going to access if your application runs in cloud? That and so much more is taken care of by these API resources. And a huge part of your understanding of Kubernetes sits in the understanding of these API resources. So that's going to be a main mission in this course. So just remember, in a cloud-native environment, the application is not directly related to any server. And that means that the functionality normally taken care of by your individual servers is now stored in the cloud, handled by these API resources. So which API resources are there? Well, the Kubernetes API provides these different resources, and the main resources, the ones that we've seen so far, are the deployment, which are used to represent the application itself. And much more, but we will talk about that later. It's just the first impression that matters here. Next is the replica set. A replica set takes care of scalability by managing application replicas, which really are application instances. And there's the pods. Pods add features that are required in the cloud to run the actual containers that are running the application. What kind of features are that? Well, features that help the cloud determining about pod priority, for instance, about pod resource usage, for instance, about pod affinity and anti-affinity, and so much more, which you will learn all about in lessons 5 and 6 of this video course. 2 lessons completely dedicated to all the things that you can do with pods. But apart from deployment, replica set and pods, many more resources are provided. And you can use kubectl API resources for an overview. Now, before I'm going to make a nice drawing to visualize the most essential resources for you, let me just show you kubectl API resources for a first impression. So here I am back on the Google Cloud. Let me use kubectl API resources. And I know that a lot is coming, so I'm piping the output immediately through the less command. And there we can see the pods, and where is it? The deployments and the replica sets. But apart from that, as you can see, many more resources are available. And these resources are not offered by one API. There is the API version v1. This is what you can consider the core Kubernetes API. But as we will further investigate later in this course, the Kubernetes API is extensible. So you can see that other APIs are available. The most important add-on API is apps v1, which is what defines the deployment and the replica set. But as you can see, so many other APIs are provided, and they make that you can safely run your applications in a Kubernetes environment. Now let me make a drawing to visualize how the most essential API resources are used in the Kubernetes environment. So what is happening with the API resources if you run a container? Well, it all starts with the container, but the container itself is not managed by Kubernetes. So Kubernetes is going to put this container in a pod. And the pod is really the managed entity by Kubernetes. In the pod, you will find different cluster-related properties that are important, like volumes, for instance, which are taking care of storage. Now, this pod is being managed in a replicated way. So in most cases, you won't have one pod, you will have multiple pods. And in order to take care of the replication, there is a replica set. Replica set does exist as an independent API resource, but replica set is not normally managed as an independent resource. That is why we have the deployment. So the deployment is, as you can say, really the application. So if you are going to run an application in Kubernetes, you are going to run a deployment. And this deployment is taking care of the replica set, and the replica set is taking care of the pods. Now, apart from that, there are many other components that will play a role. One very important one that I want to mention here is the service. You are going to expose your application so that users can use the application. And in order to do so, you will use the service. So users are contacting the service, and the service has an externally represented IP address. But you are also going to use ConfigMap, for instance. ConfigMap, which is to connect site-specific information to your application, like variables, or secrets, which is the same as a config map, but in a more secret way. And then you are going to take care of persistent volumes and much more as well. Now, the nice thing about all these API resources is that these API resources make sure that you can run your application in a cloud-native environment. Because don't forget, in a cloud-native environment, your application is no longer bound to one specific server. Your application is getting its information from cloud. So you need a solution to store all that information in cloud. And this is going to be it. Much more about that in the upcoming lessons. So in this video, I want to tell you about the different options for deploying Kubernetes. So what are the options? Well, the thing is, you can run Kubernetes basically in any environment that you can imagine. You can run it in public cloud, either as virtual machines or as one of the managed solutions that is provided by basically every major cloud provider. You can also run it on-premise in a data center, which means that you are going to run it on your own servers by installing your own Kubernetes cluster using kubeadm. That is a skill that you will learn about in Certified Kubernetes Administrator, by the way, not in this course. You can also use Minikube or any other compact Kubernetes distribution for testing and developing. In this course, because Minikube is such a rich and easy to use platform, you are recommended to install Minikube for this course. You will also notice that many of the labs are really written to be used in a Minikube environment. And even if it is possible to run components of this class in another platform, it's not recommended because some components may not be available. Like ingress and service class, for instance. The benefit of Minikube is that Minikube contains some components that otherwise are kind of hard to get up and running. And in Minikube, it's just an affair of enabling a simple add-on. So please make sure that by the end of this lesson, you have Minikube up and running on your favorite operating system. Before we continue and I tell you more about Minikube and its installation, I just want to make a drawing to explain all about these different deployment options. And now, even if they look very different, it all comes down to the same. So let me visualize the appearances of Kubernetes. In the end, it's always this. It's a couple of computers, which you call nodes. And these nodes are your Kubernetes cluster. So there's a controller node, there's a worker node, there's a worker 2 node, and you can have multiple controller nodes as well if you want to provide for some redundancy. And typically you will have multiple worker nodes as well. It can be as complex as you want. Now if we go for this scenario, we call that on-premise. Now what is this thing if you are using managed Kubernetes in a cloud environment? Well, you draw a cloud, and in the cloud provider is going to do what for you? They are going to run a controller node, and they are going to run a couple of worker nodes. The only difference is that you don't directly work with these controller and worker nodes anymore. It's a cloud provider taking care of it for you. And as you are running a managed Kubernetes environment in cloud, the controller and worker nodes are more or less hidden for you. But in the end, it's the same option. So it doesn't really matter if you are running hosted Kubernetes in a cloud environment or on-premise Kubernetes in a distribution or built by yourself. It comes down to the same. And you can also condense all of this into one node, and that is what we call Minikube. So what is Minikube? Well, Minikube is basically taking care of controller and worker node functionality. And the nice thing is, originally Minikube was designed to be an all-in-one solution. We call that AIO, all-in-one. But nowadays, Minikube can even be extended with multiple nodes. That's not something that we are going to do in this course. But you need to realize that no matter if you are using Minikube or on-premise or in cloud, it all comes down to the same. And even if you go for other solutions like Kind, which is Kubernetes in Docker, or the Docker desktop solution, you end up with this specific module, running your own all-in-one Kubernetes. What is essential is that this controller node is running your API server, your etcd, and your kubelet is everywhere to run your pods as well. And that is what makes your Kubernetes cluster. Before we are actually going to install Minikube, I want to make sure that you understand what it's all about. So let's go check it out. What exactly is Minikube? Well, Minikube, as I just explained in the previous drawing, is an all-in-one Kubernetes solution. That means that typically controller and worker functionality are offered in one virtual machine. You should know that recent versions of Minikube allow the addition of additional nodes. That's not something that we are going to do in this class. Nice that you can do it, not really required for what we want to learn. To run Minikube in a virtual machine, you need a virtualization layer to be present as well as configured. And configuration of the virtualization layer is not discussed in this course, just because there are so many different options that it really doesn't make sense. I mean, you need to talk to the hypervisor layer, which is hardware related. Then every operating system has its own hypervisor. You can use generic hypervisors as well, such as Oracle VirtualBox and VMware Workstation or VMware Fusion. That just doesn't make sense to try to discuss all of it right here. As an easy alternative, Minikube can also be started in a container. And the recommended method in this course will show you how to install Minikube as a container in a dedicated Ubuntu virtual machine. So if you know how to install an Ubuntu virtual machine, and if at least you have 3 GB of RAM available for that virtual machine, that is what you should be doing and nothing else, because that is going to offer you the exact same experience as what I'm using. Minikube on Windows, Minikube on macOS is possible, is okay as well, but the dedicated virtual machine is better. Also, because if things turn out not to be working very well, you don't mess up your main operating system. You just throw away the virtual machine and install a new virtual machine, and that makes it so much easier for you. Before we continue, let me make a drawing to explain the concept of Minikube as a container in a virtual machine. So we are going to work with Minikube, and I want to make sure that you understand what Minikube is all about. Especially if you go for the scenario where you are using Minikube in an Ubuntu virtual machine. So what would that look like? Well, if I look at my solution, I am on my host operating system, okay? So the host OS, that is going to be Mac or Linux or Windows. Doesn't really matter which host operating system you are using. If you want to run Minikube, you can run Minikube directly on top of your host operating system. But directly on top of your host operating system, that basically means that Minikube is using host native virtualization. Most host operating systems are offering some virtualization options. I am going to do it in a different way because I want to use VMware as the virtualization option of my choice. Why? For the simple reason because VMware makes nice virtualization software. And in VMware, I have features that I need to do whatever I want to do. So what am I going to do? Well, on top of VMware, I am going to install an Ubuntu virtual machine. So there we go. And the reason I'm using the Ubuntu virtual machine is quite easy because, well, let me draw in Minikube in here before I go explain. So how are we going to use Minikube? Well, there are two options. You can use Minikube. Minikube needs an additional layer, and that is either a container layer or a virtualization layer. So yes, that means that you have a virtualization in virtualization. We call that nested virtualization. And on top of that container layer or virtualization layer, you will end up using Minikube. Now, the reason that I'm going for this relatively complex structure is as follows. If you install Minikube on your host operating system, then Minikube is going to make changes right here. And sometimes these changes might not work out the way you want them to work out. For example, if you are into containers and stuff, you might be running Docker Desktop. You might be running OpenShift as well, all on your same operating system. And that might bite each other with the result that you have problems on your host operating system. And yes, it has happened to me that I needed to get back to the factory settings on my Mac to make sure that I restored my host operating system. That's not cool. And that's why I'm going for the Minikube on containers and virtualization here. So if anything is messed up, then it's the Ubuntu virtual machine that is messed up. And you know what you are going to do in that case? You are just going to delete it and recreate it again, but you are not in trouble. So that's a little bit of background in the configuration that I am going to use. Now in this course you have so much flexibility, but if you want flexibility in a manageable way, I would recommend you go for this solution. Alright, now that we understand what it's all about, let's talk about configuration requirements. So Minikube offers a complete test environment that runs on Linux, OS X or Windows. And in this course, Minikube is our preferred setup because it's easy to set up, it has no further dependencies, and it's offering everything that you need to know about for becoming cKAD certified. For the best possible flexibility, as I just mentioned, it's a good idea to install Minikube in a virtual machine. And alternatively, you may run it on top of any operating system. To use Minikube, you should have at least 2 GB of RAM. I really recommend 4 GB and also 2 vCPUs. I'm not going to show you how to install it in this video. The next 3 videos are dedicated to installing Minikube in an Ubuntu virtual machine. Next, Minikube on Windows, and then you will learn about installation of Minikube on macOS. I already told you, I would recommend you create yourself an Ubuntu virtual machine, install it in there. If for any reason that's not possible, watch the appropriate lesson about either the installation in Windows or macOS. So in this video I will show you how to install a lab environment based on an Ubuntu virtual machine. I am providing an easy setup of Minikube on top of Ubuntu using a lab setup script. And that is for the simple reason that for cKAD, nobody is going to ask you to install your own environment, even if you are more than welcome to do so. And you will need to provide an Ubuntu virtual or even a physical machine to use the lab setup script according to the specifications we've talked about before. Then you clone my Git repository and you run the Minikube docker setup.sh script. And that will install Minikube as well as the kubectl client. Obviously, you are more than welcome to follow the manual procedure described for macOS and Windows. That is in the next videos as well. But now, let me show you how to get started with Minikube in Ubuntu using my automated lab setup. So here we are on the brand new Ubuntu virtual machine. Let me start with LS-CPU. Just to verify a couple of things, we have 2 CPUs available, that's good. Then df-h is showing us that we have 13 GB in root, that's also good. And 3-m is showing us that we have 4 GB of RAM. Ignore the 1683, that's not really true. 4 GB of RAM, that is what we need. So let's start with sudo apt install of git and vim. I'm using Vim because that's my favorite editor. If you want to work with any other editors like Nano or Notepad, please go ahead. Haha, that was a joke. Notepad is not available, not even on Ubuntu. Use gedit if you're looking for a graphical editor. But really, using a graphical editor doesn't make sense. Better learn about at least Nano or better VI, because later on, while working with Kubernetes, it really helps if you have good editor skills. So I have installed my software. That means that I can next use git clone https://github.com/sandervanvugt/cKAD. This cKAD Git repository is the directory where we want to be. And in this Git repo contents, there's a lot of scripts. Please ignore the ones I'm not talking about, because this Git repo also provides access to resources required for previous versions of my video course. The only one that we are going to use here is minikube docker setup.sh. And if you want to use other Linux distributions, bad luck. My script doesn't support any other Linux distributions, just minikube docker setup.sh. So let's run it. And then it will prompt you whenever it needs input. The only thing it might be prompting you for is the sudo password, because there's a couple of tasks in the script that work with sudo privileges. But for the remainder of it, everything is a completely automated procedure. Again, I have written this script because being a cKAD is not about installing software on Linux. That is also one of the nice things about cKAD. The Cloud Native Computing Foundation really has made a huge effort to make sure that cKAD is about Kubernetes, not about Linux. And with minimal Linux knowledge, you should be able to pass your cKAD. I'm not going to tell you that I recommend doing it without Linux knowledge. I think you should have some minimal Linux knowledge because you are going to work in a Linux virtual machine from the command line anyway. And you don't want to get lost in between your Linux commands. And hey, if you want to work on your Linux fundamentals, I have this awesome video course with the title Linux Fundamentals. All right, as you can see, that took me about 3 minutes, and now it's saying the script is ready and we need to run this command. And in case you are wondering, couldn't you do that from the script? Well, I'm sorry, no, I couldn't do that from the script. So here we go, I need to run it manually. So, whoop. And now we need to wait for a little bit again. It all depends on your internet speed, because it needs to download half a gigabyte. And you can see that on my system, it is fast enough and should be there within a minute or so. Also notice the Kubernetes version. No worries about new versions. My script will always give you the latest version that is available. And the latest version that is available is also what you need to learn about for your exam. And I will make sure you get access to the information that is required to do so. As of now, the latest version is version 1.22. I'm pretty sure that by the time you're watching this, you might be on 1.23 or even 1.24, because we do have a new release every 3 months. All right, we can see it's already creating the Docker container. Alternatively, if you're installing in a virtual machine, it will be doing a virtual machine. As I'm running on Ubuntu in Docker, I have a memory setting of 2.2 gigabytes, and that's the only thing that it can do. It does need CPU sys2, so it won't work if you only have one CPU available. And there we go, it is pulling the images. So here it's telling us preparing Kubernetes on Docker 20.10.8. And in order to do so, it's running a couple of container images that need to be fetched from the internet. And now it's already there. Look at that. kubectl is now configured to use Minikube cluster and default namespace by default. 2 tests, Minikube status is the first thing. And in Minikube status, I want to see that the control plane is the type. The host is running, the kubelet is running, everything is running. kubeconfig is the part that allows me to work with Kubernetes, and that's what kubectl is interfacing. So kubectl get all is showing me, yay, I have one service. This is what you are expected to see. One service, nothing else, because everything else still needs to be configured. And that's what you will learn in the next lesson. In this video, I will show you how to install Minikube on Windows. Let's start from the Kubernetes documentation, because in the Kubernetes documentation, you will always find the latest and greatest information. So Minikube Windows is giving us a Minikube start. So let's go check that out. So what are we going to do? Well, Windows x86-64 stable installer type exec download. So we are going to download the latest release. Then we are going to open the file. Yes, I do want to run it. And we even get a Windows installation wizard. That's fine. Let's run it. I agree. And that's okay. And there we go. And the installation is completed. So Minikube has been installed on my computer. So is there anything else? Well, we need to start a terminal. And from a terminal, Minikube start. So term on the command prompt. Minikube start. There we go, and here we can see it's starting the Minikube on the Windows environment. A new image file needs to be fetched. That always takes a minute. And there you can see that it is creating a Hyper-V virtual machine. And the virtual hard disk creation is going on. So the fact that we can see that it's creating a Hyper-V virtual machine already shows that it is capable of using the Hyper-V virtualization layer. In case this is giving an error, you might not have a Hyper-V virtualization layer, then you can always check the drivers page for setting up an additional container or virtualization layer. I'll show you that once this installation is done. So here we go, and it's telling us that we can use this Minikube kubectl command. So Minikube kubectl -- get all. And that is running the kubectl executable, and there we can see that it is working. So this is how you run Minikube in a Windows environment. A few more details from the web page. Here you can see the driver space. This is where you go if you are having trouble. This is giving you links. So as you can see, Hyper-V and Docker are the preferred options. Minikube in Docker actually is pretty common. It's also telling you how to work with kubectl. That might be a next step to install kubectl on Windows as well. So let's have a look at install kubectl Windows. So how are we going to do that? Install kubectl binary with curl on Windows. That sounds cool enough. So download the latest version. Yeah, let's do that. So now we have downloaded the file. We need to verify it. So we do that in a command prompt. So command prompt. And we need to go to the downloads folder. So in the downloads folder, there it doesn't work, but there we get kubectl.exe, and we need to run this cert util. So cert util. So let me copy that and paste it. And there we go, hashful command completed successfully. So that is looking good. Ignore this. This is just a copy-paste error. So at this point, kubectl is verified, and we can use kubectl get all, for instance, which is showing me the services in the Kubernetes cluster. So kubectl create deploy winner dash image is nginx. Does that work? Deployment winner created. And kubectl get all. And there we go. It even works on Windows. So that's how you can use Minikube in a Windows environment. In this video I will show you how to install Minikube on macOS. So let's start with the documentation. You can find the documentation on minikube.6.kubernetes.io. Look for Minikube start, where there's an installation section. And in this installation section you can find your operating system, so you can conveniently click the operating system that you are going to use. macOS in this case. So as you can see right here, it's a two-command procedure. You are going to do the binary download, and then you are going to do the sudo install of the Minikube package inside the user local bin directory. Once you've done that, you can use your Minikube start. So that sounds easy. Let's figure out if it really is that easy. So here we are in a shell on macOS, and well, we basically need to run these commands. So this curl command is how we download the package. Make sure that you use curl minus uppercase LO, it's an O, not a 0. And the result is that the Minikube Darwin package is locally installed. So once you've got it locally, let's have a look at the package itself. There we go. Once you have it locally, 70 megabytes of packets in total, you can use sudo install Minikube Darwin, etc. And you need a target path. The target path is supposed to be user local bin Minikube. So far so good. At this point the package is available in the path. And now we need to give it a Minikube start. Now Minikube start, that sounds easy, but it needs a driver. And the driver is interfacing the virtual machine manager. So let's figure out and see how we are doing regarding the driver. Otherwise, if you are getting in trouble because of the drivers, have a look at the documentation. In the documentation there is a drivers page, and in this drivers page you can read what else you can do to make sure it works out all right. So as you can see, that seems to be working out all right. The only thing that it's complaining about is about kubectl. It's a little bit confusing. Here we see try minikube kubectl -- get pods -a. And now we also see kubectl is now configured to use Minikube cluster and default namespace. So let's test kubectl get all. And yeah, we don't see kubectl. And in order to make that a little bit easier, we can use Minikube kubectl -- get pods, for instance, or get all, or whatever, which is using the Minikube version of kubectl. But you don't want to be using the Minikube version of kubectl. You want to be using the kubectl command. So you can accomplish that by putting the following in your shell configuration. So alias kubectl equals minikube kubectl -- and then if you use kubectl get all, then you get your service in Kubernetes that is ready for business. So at this point, Minikube is up and running on macOS. That's all. So no matter which platform you are on, at this point, you should have a working Minikube environment. Let's go over how you can check that everything is doing all right. So in order to test Minikube, you can use Minikube status. That will show you current status. Minikube get all kubectl get all will verify the kubectl client operation. Then you can use Minikube start and stop to start and stop it, SSH, to log into the Minikube host. And there you can use docker ps to show all the Docker processes on the Minikube host. And then there's a couple of other management commands as well, like Minikube dashboard, which will open the Kubernetes dashboard in a local browser, or Minikube delete, which deletes a cluster, which sometimes is necessary if you want to build a new cluster, or Minikube IP, which shows the current IP address. We talked about start, stop, and status. There's a version as well. There's an SSH as well. And you know what? Let me just walk you through the use of the most important options that allow you to verify everything is going all right. Okay, so after installing Minikube, Minikube status is definitely the first thing that you want to do. And here we can see that everything is running and configured, so that's all good. So kubectl get all should be working right now. Now what else is interesting? Well, Minikube version can be useful to show you version information. That's the version of Minikube, not the version of Kubernetes. Because for the version of Kubernetes, you would use kubectl version, which is telling me that this is 1.22 version 3. Now, the next thing that might be interesting is Minikube dashboard. Okay, about the dashboard. I told you before, the Kubernetes dashboard is not what you should be focusing on for your exam. If you only know how to work with Kubernetes dashboard, you are so dramatically going to fail your exam. But I do want to show you that there is this dashboard anyway. And you know what? Let's run one application in the dashboard. If you want to do that, you click the plus. And in the plus, you can select how you want to create your application. Well, the nice thing about the dashboard is that you have a form that makes it easy. My easy app, for instance. Then you need to specify a container image. Like I told you, Nginx is one of my favorite container images right here. And you need to specify the number of pods. It's all about your application. I'm going to use 3 pods. You can specify a service as well. Service is about exposing your application. Don't select external, select internal and set the port to 80. The port is the port that you want your application to be running on, and the target port is the port that your application is running inside its container. There's a couple of advanced options as well. We shouldn't be talking about the advanced options right now, no matter if even they are interesting. You should just start and click deploy, because that will run your application for you. Then you can see an overview of the different workloads. And in this overview right now, I can see yellow balls. And the yellow balls means that this is pending. And hey, look at that. It's turning green. And that means that actually my application has been started. And yes, in the Kubernetes dashboard, you do have all these other options as well, but it's not enough to get you through the exam. And also you won't find dashboard on other Kubernetes distributions. So best thing to do, get out of here and get back to the environment where you want to be, which is the command line, kubectl get all. That's what you want to see. Where we can see that my easy app has successfully been deployed. We'll talk about that later. For now, I also wanted to show you Minikube SSH, which is kind of cool. It opens a secure shell session inside the Minikube virtual machine or container, depending on how you install it. And in this Minikube environment, if you type docker ps, you can see all the Kubernetes core processes actually running as Docker container. Is that important information? Not at all, but it is cool that you know that these Kubernetes services, like the dashboard, like the API server, like the etcd, and all these other fancy things are running as Docker containers. But hey, if you're interested in more information about that, please watch my Certified Kubernetes Administrator course. I think for now we have seen enough to allow you to verify correct operation of Minikube. Happy Minikubing! So now that everything is up and running, let's talk about how to run your first application. So kubectl get all is always what you want to do to get started. And in order to run applications, don't do it from the dashboard. So let's get rid of that. kubectl delete pod. And which pod? Well, I want to delete this pod and I want to show you if this is going to be successful or not. So this is the kubectl delete command. I'm deleting my pod and there it goes away. Let's verify kubectl get all, and oh no, what happened? I deleted the pod, the cluster didn't like it, it recreated the pod. That is because the pod is managed by the replica set and the replica set is managed by the deployment. So if there's anything you want to delete, you want to use kubectl delete deploy my easy app. And that will delete the deployment. And now if we use kubectl get all, what do we see? We only see the services. That's not really nice. I don't like it that the service still exists. kubectl delete svc, which is short for service my easy app, will delete the service as well. And now at least we have a clean sheet. So in order to run your first application, we are going to use kubectl. I would like to tell you about kubectl completion before we are continuing. kubectl completion -h is what I'm going to do here. So kubectl completion is about Kubernetes kubectl completion. Again, on the exam you will be on Linux, so it will be very easy. kubectl completion is command line completion, and command line completion works for Bash, it works for Linux, and it works in a very limited way for Windows as well. So for the Windows users, go check out this link. For the Linux users, what it comes down to is this, this command. As long as you run this command, then you are okay. So, here we go. And then we can also see write kubectl the bash completion code to a file and source it from bash completion. So what is that doing? kubectl completion bash. This is generating a file. And this file is what you need to do to enable your kubectl completion. Because you know, running this command from the command line is cool, but at the moment you log out and log in again, then you need to run it again. So that is not really what you want to do. So what are we going to do next? Well, we are going to run all of this. Just copy paste it. What it is doing, printf, it's running the source command, source home.kube completion bash.inc. That's a file you just created, and it's putting that in .bash profile. And .bash profile is a file that you are using when you are starting. Let's check if that really worked out all right. So I am using vim on .bash_profile, and look, that appears to have happened all right. Now I'm not even going to show you completion right now. I'm going to exit and exit again, and then we do that later. I am going to open a new terminal, and in my new terminal, there we go, I am going to use kubectl tab. Oops. So now I need to log out because bash profile, that's a login file. So I'm logging out. Then I can log in again. And after logging in again, I'm opening a new terminal, and that should have made that my bash profile has been processed. If that's the case, kubectl tab should show me what I can do. And it does not. Well, why doesn't it? Well, apparently we have an Ubuntu issue. You know what? Let's fix this, and let's put this source command somewhere else. First, let's run it from the command line. There we go. And now kubectl tab. This is what we are expecting to see. And now I'm going to put it in .bashrc. So .bashrc, and in the .bashrc all the way to the end, I am going to run this source command again, and that is going to make sure that after logout or after closing a terminal and opening a new terminal, kubectl tab is going to work. So hey, what did we discover here? We discovered that the kubectl documentation is cool, but it's not perfect. It's not perfect because the kubectl completion information that we have just seen, let's get back there, kubectl completion, that is this information appears not to be working on Ubuntu. Replace .bash underscore profile with .bash rc and you will be all right. Good. Now we need to run our first application. kubectl run -h. I like this -h because the -h is showing you so well what you can do. And I'm just going to run this command. kubectl run nginx --image is nginx. You know this -h is so incredibly useful on your exam. Use it and use it a lot because it has awesome examples that help you to get things done in an easy way. kubectl get all, and kubectl get all is showing me, yay, pod nginx is now running. And what happens if I use kubectl delete pod nginx? There we go. Well, what do you think is happening? The pod has just been deleted. kubectl get all. But hey, isn't Kubernetes supposed to be automatically creating my pod again? Nope, it's not. And that's why you should not be running individual pods. You should be running your pods through a deployment. And that is what we are going to learn in the next couple of lessons. So in this lesson we are going to talk about pods. Pods is where it's all starting. So what is a pod? Well, a pod is an abstraction of a server. That means where in old IT you would have a server providing everything that you need to run your application. Now you have a pod providing everything you need to run your application. In a pod you can run multiple containers within a single namespace exposed by a single IP address. So the pod is the entity that carries the IP address. That's important to remember. Also, pods are always running containers in the same namespace, in the same isolated environment. The pod is a minimal entity that is managed by Kubernetes. That means that Kubernetes doesn't manage containers directly, it manages containers through pods. And the reason that Kubernetes is doing that is that the pod resource in the Kubernetes API is adding features that allow you to run your container in a cloud-native environment. So from a container perspective, a pod is an entity that runs typically one or more containers by using container images. Normally, you would only start pods through a deployment because so-called naked pods are not rescheduled in the case of a node failure, and there are other reasons why running naked pods is not a good idea. For instance, zero downtime application update is also not possible on a naked pod. So deployment is where you want to go to in real life, but for cKAD you really need to be familiar with pod features, and there will be assignments where you are just going to run individual pods. And that's why in this lesson we are focusing on the pods. So what exactly are these naked pods disadvantages? Well, first, naked pods are not rescheduled in case of failure. Rolling updates don't apply to naked pods. You can only bring it down and bring it up again with the new settings. One example, if a new version of your application comes up, if the application is running in a deployment, then you tell your deployment, hey deployment, there's a new version using kubectl set image, and the deployment will update the pods one by one, and the result is that your users won't lose any connectivity. That's just not possible when you are running pods. When you are running a naked pod, you bring it down so that the user loses connectivity, then you bring up the pod again, and then connectivity is back. Also, naked pods cannot be scaled. Scalability is a big thing in Kubernetes, where you want to make sure that sufficient number of pods is always available to deal with the requested workload. You cannot do that with naked pods. And they also cannot be replaced automatically. If you run a managed pod through a deployment, something goes wrong and it crashes, stops or whatever, the deployment will start it again. If you run a naked pod and it crashes or whatever, nobody cares. So all of these are hopefully enough reasons to run deployments and not pods in real life. But I repeat, in cKAD you need to be very familiar with pods and individual pod management as well. And that's why in this lesson, as well as in the next lesson, we are talking about pods exclusively. Now, how do we run a pod? Well, with kubectl, of course. kubectl run is the command that you want to use to run a pod that is based on the default image. For instance, you use kubectl run my nginx -- image is nginx. The -- image is a required argument, because otherwise your pod doesn't know what it needs to run. And then you can use kubectl get pods for an overview of everything that is running. You might also appreciate the option -o YAML. -o YAML will show you the YAML code behind the pod, and that can be very insightful because it shows you all the different parameters that this pod is using. We will talk about these parameters. The Kubernetes API defines a lot of parameters that you can specify while running pods. Another way to have a look at these parameters is by using kubectl describe. That will show you all the details about the currently running pod, including information about containers running within. And you know what? Let me just show you these commands. All right, I'm going to start with kubectl run. It's always a good idea to use your kubectl commands with -h to discover a little bit about what they are offering. And you are certainly going to like all the different examples that you can see right here. Right now I'm starting the pod in quite a simple way, but here we can see in the different examples that you can do it in more advanced ways as well. Right now, I'm not going to cover all these advanced options because really it doesn't make sense as long as we haven't discussed what they are all about. Also, -h is showing a list of all the different options that can be used. So if you are wondering, hey, can I set a timeout for my pod? Well, -- timeout, you can find it right here. The examples don't normally list all the different options. So if you are looking for anything special, have a look at the complete output. For this one, we are keeping it quite simple. kubectl run my first nginx. We need a name, and my first nginx is kind of okay. -- image is nginx. The image doesn't need anything else. I'm using -- image is nginx, and the result is that the image will be fetched from the Docker registry. And there we go, pod my first nginx is created. Can we verify that? Of course, kubectl get pods will show you all the pods currently running, and there we can see my first nginx is running. The ready is indicating 1 out of 1. That means that the pod is expecting one container to be available, and it does have one container. The status is running, it has not been restarted, and it has been running for 7 seconds. Now, if you want more insight, you can do the same. Optionally, you can append the name of the pod if there's multiple pods, and then append -o YAML to the command. If you have 20 different pods up and running, I wouldn't recommend using kubectl get pods without specifying a name, because otherwise you get the YAML code for all the pods currently running. Also, it might be a good idea to pipe it through less so that you can filter the output. And what do we see? Well, we see information about the API. This comes from Kubernetes API version 1. The kind, that's the resource kind, that's a pod. The metadata, which includes name, and the spec which really includes the specification. In the specification, you will find your containers, but you will also find special scheduling options. And these special options, in particular, everything that you see right here, these are the reasons why Kubernetes is running pods, not containers. This is what Kubernetes is adding to the container. These are options that are not available in containers themselves. Also, you can see status. Status is current management information. So that will tell you about what exactly the cluster has done. This was not intended to be human readable. If you look for more human readable description, I would advise you have a look at kubectl describe. So kubectl describe pods my first nginx. Let's also pipe that through less. And there we can see in a more human readable format everything you want to know about. So this pod has no specific priority. It is running on this specific node. In Minikube, of course, which node it is running on is not relevant because it will always be the Minikube node. But in a multi-node cluster, this might be good information. Skipping a little bit, here we have the IP address. We have the container with all the different container properties right here. We can see how often it was restarted. We can even see the volumes. I'm not going to try to explain these volumes now, because what you see are some administrative volumes that make sure that the pod can communicate with the cluster. The important thing is that right here you see that these pods have been started with lots of additional properties. In the last couple of lines we see the events. The events is a summary of everything the cluster has done to make sure your pod is available. And we can see that everything has worked out all right. If it hasn't worked out all right, you will find it in the events as well. And if that is the case, then you are going to investigate the state, because probably you will find some failure message here. No worries, we are going to do that in a later lesson. For now, this is enough to know about getting your pods started. In this lesson we are going to talk about YAML. So what is YAML? Well, YAML is a human readable data serialization language, according to Wikipedia. It's perfect for DevOps to create input files to manage objects into different systems, and you will find it in solutions like Kubernetes, but also like Ansible, for instance. And it uses indentation to identify relations. So in YAML you identify a couple of parent resources. These parent resources get their properties, and the properties are clearly identified using indentation. And the advantage of using YAML is that you have something clearly defined. And if you use it in combination with GitHub, it's an excellent way to manage and update configurations in a structured way, and to make sure that everybody is using your Kubernetes resources in the same way, which is perfect for bigger environments and if DevOps is important for you. Now you can write YAML yourself. If you want to work with YAML in Vim and make it a little bit easier, create a file with the name .vimrc in your home directory and include this line. You will also notice that many distributions already have something in place to make working with YAML a bit easier for you. Now in a YAML file you will find the definition of Kubernetes resources. And what exactly is in the YAML file is defined in the API. It always starts with an API version, a kind, a metadata and a spec, where the API version refers to the Kubernetes API and its version, to make sure that what you have defined matches the current API in Kubernetes. The kind indicates the type of resource, like a deployment or a pod or whatever. The metadata contains information, administrative information about the resource, like the name and the namespace and more. And then there's the spec. The spec is the most important thing because it contains the specifics for this object. If you want to know more, you can always use kubectl explain to get information about these basic properties. I will show you kubectl explain shortly. Now in a YAML file, when we are talking about pods, one of the important things that is happening is the container definition. And if you are using container definition, there are different parts in the YAML file as well, like name, which is the name of the container. Notice that the pod name is not the same as the container name. That is because one pod can run multiple containers, and if it runs multiple containers, every container needs its own identification. The image, that's the container image that you are going to use. The command, that is the command that the container should run in case the image doesn't come with a usable entry point by itself. The arguments is for arguments used by the command, and env can be used to specify environment variables. And all of these are a part of the pod spec container spec, and you can use kubectl explain to figure out what it is all about. Let's first have a look at an example YAML file. So what do we see in this example YAML file? Well, we see API version v1. That means that it's coming from the core Kubernetes API version 1. Kind is pod. That's a resource that we are trying to define. In the metadata, we need to give it a name and we need to define the namespace. Namespace default. Notice that if you don't specify the namespace, that's okay. It will run in the default namespace by default. And then we have a spec, and in the spec we can see containers. Now containers, there's multiple of them, and for that reason every single container starts with a hyphen. This is a so-called list argument, where really an array is specified of containers and their properties. So we have a busybox container using image busybox. Image busybox will always use the latest version of the image. If you want to use a specific version, use busybox colon 1.23 for instance. And then we have the command. And the command, like we have seen before when we were talking about Dockerfile, is noted in array notation. So sleep 3600 is a command that has this busybox container sleep for an hour. And you know why that is happening? Because that might seem surprising. Well, if you don't specify a command, busybox has a shell as its entry point. And that means that the busybox container comes up, immediately goes down again. And Kubernetes can't deal with that. Kubernetes is thinking, oh no, the busybox container is down and it's going to start it and it's going down again. It's going to start and going down again. And it looks as if it is failing, whereas a container image is just doing what it's supposed to do. So for that reason, if you are using a generic system image like busybox, it's a wise idea to specify a command like this. You can also see a second container with the name Nginx and the image Nginx. No command, because Nginx starts the Nginx service. That's a service. It won't immediately go down. One final comment: in this example YAML file you see multiple containers. That's because I wanted to show you that you can include multiple containers in a YAML file. I'll tell you more about multiple containers later, but it's definitely not common to run multiple containers in one pod. Single container pod is the standard. Now let me show you a little bit about this. So to start with, I would like to show you kubectl explain. kubectl explain is so awesome because it allows you to figure out what you can define in the YAML code of any resource. For most resources, it starts with the API version, the kind, the metadata, and the spec, and you will see a status as well. You are not going to configure status yourself. This is done by the cluster, so don't try to change it. Then, if you want more details about spec, for instance, kubectl explain pod.spec. Let me pipe it through less because I know that a lot is coming. This is showing a list of all these properties that make that you want to run pods in a Kubernetes environment to work with your containers. And why is that? Well, because you can include information about how this pod should be used in the cluster. Like pod affinity, which are rules to bring pods together or to do the opposite. Like host network, which is requesting the pod to access the host network. Like node selector, which allows you to state a preference about the node where the pod is going to run in the cluster. Like restart policy, which allows you to define what should happen if anything goes wrong with your restart policy. And for all of these, you can also see that the options are listed. Do mind the case, because these options are all case sensitive. If you don't respect the case, you will find a failing pod specification. Now another command that I definitely want to show you is kubectl explain --recursive. Because the recursive option will show you all the different parameters that you can use while working with these resources. And it also nicely shows, nicely indented in the way that you expect it to happen in YAML, the relation between parent and child resources. I'm not even going to attempt to give you an explanation of all of these right now. If they are important, we will talk about them later. But I just need you to understand that this ---- recursive can be a very nice option to look up specific options. Now in the course GitHub repository, you will find busybox.yaml. Busybox.yaml is just a simple way to demonstrate what such a YAML file is looking like. Now, do we see anything we haven't seen in the slide? I don't think so. We have the API version, the kind, the metadata, the spec, and a command. And the only thing that remains to be done is where we are going to run this resource from the YAML file. So kubectl create -f busybox .yaml will do that for us. And look at that, busybox is now created. So kubectl get pods is giving me what? It's giving me busybox running for 6 seconds. Note that you can also use other commands to manage these YAML files. For instance, kubectl delete -f busybox.yaml. That doesn't need any explanation, does it? And last, there is also kubectl apply. Now, what is the difference between kubectl apply -f and kubectl create -f? Well, create is for creation, and creation only. If you run kubectl create to create a resource that already exists, you will get an error message. Apply will create the resource if it doesn't exist yet, and if it already exists, it will see if you can update it. Let's just check what's happening. There we go. It's telling us unchanged, so there's nothing to be changed here. But kubectl apply, if you have modifiable properties, and there's not a lot of them, but if you have modifiable properties, then kubectl apply may come in handy. Notice that in order to use kubectl apply, application update mechanisms come in place. And application update mechanisms are only present for deployments, not for pods. But I wanted to tell you about kubectl apply already anyway. That's all for now. In the next video, I am going to show you that you don't have to worry about writing YAML files. You can generate them. In this video, I want to talk about generating YAML files. We have just seen how YAML files are really what's happening behind Kubernetes. And if you can automatically generate them, that makes life a lot easier. So generating YAML files is important for using Kubernetes the declarative way. The imperative way of working with Kubernetes is where you create everything from the command line. The command line is quite powerful and quite good, but if everybody in your company is using the imperative way, it's very difficult to get a standard way of working. And that is why there is the declarative way. The declarative way is key in a DevOps strategy. It is where you are going to create YAML files, store them in a Git repository, which ensures that everybody is using the same approach. The declarative approach is nice, as it allows you to create multiple resources from a single YAML file as well. So you can build entire microservices in one single YAML file and use that one single YAML file to work with Kubernetes. But then you first need to make sure that this YAML file exists. And the easiest way is to generate them. Of course, you can write them, but you shouldn't do that, especially not on your cKAD exam. Because writing YAML files, well, it's so easy to make an error. So focus on generating YAML files. In many cases, you can perfectly generate a YAML file. In some cases, it's not possible. And if that's happening, well, then the best thing to do is to go to the Kubernetes documentation, find yourself a good example, copy-paste that example. If you want to generate a YAML file, you use --dryrun is client -o YAML and redirect that to a YAML file. You can do that as an argument to kubectl run and kubectl create commands. We have already seen kubectl run. We will talk about kubectl create later. So for instance, kubectl run my nginx -images nginx -dryrun is client -o YAML, redirect it to my nginx.yaml, and you have created a perfectly working YAML file. And that allows you to use Kubernetes the declarative way. So what are your options again? You can use kubectl create -f to create resources from YAML. You can use kubectl apply -f to create a resource if it doesn't exist and modify it if it already does exist and it has been created with kubectl apply earlier. You can use kubectl replace -f to replace a resource with new configuration in the YAML file. Notice that this last option sounds cool. It's not that cool because there are not so many options that can be changed on your resources. Last option is kubectl delete -f, which will remove everything that is specified in the YAML file. Now let me show you how to automatically generate these YAML files. So here we go, kubectl run my nginx dash dash image is nginx minus o YAML. That's one option, and that will print everything on the screen. It allows you to analyze what is happening, and as you can see, many options are added. But if you want to generate your YAML file, then you must use dash dash dry run is client as well. Dash dash dry run is client will make sure that you don't actually create the resource, but you just generate the code. So in my previous command, I actually created a resource. Now I need to remove it again. But if you use dash dash dry run is client, it only generates the code. Let me use minus o YAML and redirect that to my nginx.yaml, and there we go. Now I have my nginx.yaml containing what I need. Hey, did you see that? Because of the dry run option, there is not so much that is written to the YAML file. It's only the minimal amount of parameters, in which there's only one parameter that needs a little bit more attention: restart policy always. Restart policy always is telling your cluster what it should do if the main container in this application is failing. Well, I think that speaks for itself. It will restart it. Let me also show you something else that's a potential source of confusion. And I want to tell you about everything that can be confusing. Here we can see in this last line, we can see that there is this option to specify a command. So what is this? Minus minus command allows you to specify different command. Dash dash with all the different command options. Okay, so if we use kubectl run my busy box dash dash image is busybox minus sleep 3600. That's a legal command. Let me delete kubectl delete pod my busybox again. And now let me show you where the confusion can be. You do notice, by the way, that sometimes it takes a while until Kubernetes cleans out the resources. There are a couple of options to speed that up, but these options are potentially dangerous. I wouldn't go for them as a standard. If you are trying to force resources off of your system and it doesn't work out all right, then troubleshooting these ghost resources remaining in your cluster can be pretty hard. And that's why I would recommend, even on the exam, don't use minus minus force, just sit it out. It will go away. Now what I wanted to show you is this. Dash dash dry run is client minus o YAML. And then what do we get? We get pod, my busybox created. Is that so? kubectl get pods. And kubectl get pods is, oh no, it's giving me an error. This error is because if you use dash dash followed by anything, in this case, you run a command, these double hyphens followed by a space are telling your kubectl command that you are done with your kubectl components, and everything after this is going to be interpreted as a command that will run in your container. And that's what's going wrong, because sleep 3600, that is what you want to run in your container, but then you tell your container also dash dash dry run is client minus o YAML. That doesn't work. So you need to change your ordering. Let me first use kubectl delete my delete pod my busybox to delete it again. And now let's try it again, but putting this dash dash dry run is client and minus o YAML in front of the minus minus sleep 3600. And now the redirect, and in that redirect my busy.yaml, and then we can investigate the my busy.yaml, and we can see how exactly it is composed. Now the nice thing about this is that the way to specify arguments in your pods can be quite complicated. And as it is complicated, well, you might try to struggle with the right format of your command, but if you generate it, it automatically turns out all right. You don't have to think about it anymore. Kubernetes will automatically do it for you. And the only thing you need to do is run it. There's one more thing that I want to show you, and that's for the exam. On the exam, you can also use the Kubernetes documentation. So you go to kubernetes.io/docs. You are allowed to open one browser page. This browser page can go to kubernetes.io/docs and nothing else. And if you search in this documentation, then here you get your pods, and in the documentation, look at that, you find sample YAML code. The thing I want to show you here is that if you cannot generate it, you can probably also copy it. So on the exam, you go to the Kubernetes documentation, look for your example, copy paste, and then you've got your YAML file. That is definitely something you need to focus on, because some resources cannot easily be generated. If you can't generate it, look it up in the documentation, copy it. That's a perfectly legal way of creating your code as well. So I told you before, using one container in a pod is a standard. But there are some cases in which you want to go for the multi-container pod anyway. Let's talk about these cases. So again, the one container pod is a standard. Don't ever forget that. Single container pods are easier to build and maintain. And specific settings can be used that are good for a specific workload in a single container pod. If you want to create applications that consist of multiple containers, normally microservices should be defined. And Kubernetes is doing very well in defining microservices, because Kubernetes is offering lots of resources that allow you to connect the different applications in a microservice. But that is not what we are going to do here. What we are going to do is understand the use case for a multi-container pod. First, I want to show you a simple example of a multi-container pod, which you can find in the course Git repository. Let's go explore it so that we know what's going on. So I created this YAML file, multicontainer.yaml, just so that we have something to talk about. The reason I created the YAML file is easy. You cannot automatically generate a YAML file for multi-container pods, so you need to create it for yourself, which fortunately is not too complicated. So we can see API version kind, metadata, that's all pretty obvious. So metadata is giving a name to this multi-container pod. And then we have a spec, and in the spec there is only one property that is defined, and that is the list of containers. So there's two of them. Every single container starting with a hyphen. So containers is a multi-valued key. And if you are using a multi-valued key, every value, even if there's only one value, should start with a hyphen. That's because it's an array, and arrays need to start with a hyphen. So first we have BusyBox, based on the BusyBox image, and which is running a command sleep 3600. Then we have Nginx, which is running the Nginx image. And that is all. And in case you are wondering, yeah, but why? What do they have to do with one another? Well, nothing. And that is typically the point that I want to make. You shouldn't run a multi-container pod unless there's a very good reason to do so. But even if you shouldn't, it makes sense to understand how they behave and what you will see if you do. So here we can see multicontainer.yaml has been created. So I'm using kubectl getpods, and kubectl getpods is giving me status of container creating. I was too fast, that's okay. We will wait for it, and I will talk you through a little bit. The most important thing here is 0/2. The 0/2 is indicating that this pod is expecting 2 containers, and nothing is available right yet. It's still in a state of container creating. That's the part where it needs to go fetch the image from the internet, and that can take a while. And now we can see that the multi-container pod is running. Now again, it doesn't make much sense, but at least you know what it's all about. You can use kubectl describe on the pod to figure out what is going on, and in the kubectl describe you can see an entry for all these different containers. So here is the busybox container, here is the nginx container. But you know what the biggest problem is in a multi-container pod, or even the deployment, if you want to do it the right way? Just imagine that nginx needs an update and busybox doesn't. Then you need to bring them down both anyway. Because the pod is a minimal management entity, and that's just how it works. Now let's continue and talk about some scenarios where you might want to use multi-container pods anyway. Alright, now what are the valid use cases for multi-container pods? Well, there are some well-defined cases where it does make sense to run multiple containers in a pod. The first one is a sidecar container. A sidecar container is a container that enhances the primary application, for instance for logging or for monitoring. You may have heard of Istio Service Mesh. Istio Service Mesh is a product that is often used in combination with Kubernetes to monitor and shape traffic in a Kubernetes environment. In order to do so, Istio needs to be able to fetch traffic statistics about the real applications. And Istio injects a sidecar in the real application. And the sidecar is just telling Istio, hey, this is what he's doing. And in that scenario, the sidecar container and the main container really belong together. So that's a valid exception. Then there is the ambassador container. The ambassador container is a container that represents the primary container to the outside world. That is what you want to do if you don't want your primary container to be directly reachable. So you have the ambassador container and everybody's talking to the ambassador, not to your real container. Also, there's the adapter container, which is used to adopt the traffic or data pattern to match the traffic or data pattern in other applications in the cluster. That is what you can use if you have a foreign data pattern that is generated and you want to transcribe the data pattern into something that matches your processing utilities. You should notice that sidecar containers, adapter containers, and ambassador containers are not defined by pod properties. From the Kubernetes API resource, it is just a multi-container pod. So you won't find anything if you look in kubectl explain pod for sidecar. It's just something that exists in the literature. And if you are thinking about creating a multi-container pod, then you should wonder, hey, does this match the sidecar or the ambassador or the adapter traffic pattern? And if it does, then probably, maybe you have a valid case using it as a multi-container pod. And if it does not, then you should really, really wonder, can I run them apart as well? And if that is the case, you should run them apart. Good. Let's talk a bit more about the sidecar scenario. So the sidecar scenario is providing additional functionality to the main container, where it makes no sense running this functionality in a separate pod. That's what I just told you about Istio. In order to manage traffic going on in a pod, you really need to inject an additional container inside that pod. That's what you typically will see in logging, in monitoring, in syncing. And the essence is that the main container and the sidecar container have access to shared resources to exchange information. In order to exchange that information, you will see in this scenario that there is very often a shared volume as well. We will see a shared volume in the upcoming example also. Yeah, I already mentioned that Istio Service Mesh injects sidecar containers in pods to enable traffic management, and the shared volumes are used for this purpose. Much more about the shared volumes later. For now, let's just go check out a sidecar example. For your convenience, I have written the steps on the slide. That makes it easy to reproduce what I'm doing right here. Let's go check out what's going on. So to start with, I want to show you the sidecar.yaml example. Oops, sidecar YAML. So what do we have? We have a container, sidecar YAML. This container is using a volume. So here you can see the volume. The volume has the name logs, and it is of the volume type empty-dir. Now what is this? Empty-dir is a directory that will be created on the host that is running the pods. And this directory is bind mounted inside the containers to make it available. So you can see the volume mounts right here. Our first container, which has the name app, which is using the image busybox, has a volume mount, and the volume mount is using logs on mountpad var log. So the name logs that you see here refers to the volume that is defined here. And as this volume is pointing you to empty dir, that is what is going to be mounted on var log. We can see the sidecar container has the same volume mount of this logs volume, but this time it's mounted on the mountpad var www.html. Then we get to the essence, where the busybox container is representing our fancy main application. Now what it is doing here is not so fancy. It's just using a loop where every 10 seconds it writes the output of the date command to var log date.txt. And the thing is that var log date.txt, well, var log is on the mounted volume. So if you write to var log, you really write to the volume logs. And this volume logs by the web server is presented in var www.html. And that means that the var www.html will have access to this date.txt. So this is the use case where an application is generating data and a web server is used to present that data and make the data accessible. And well, let's just go run it and see how that works out. So kubectl create -f sidecar.yaml, and then kubectl exec. I want to run a command -it in an interactive terminal. I want to do that in sidecar pod. In a container -c sidecar. kubectl exec normally can run on a pod directly, but if you have a multi-container pod, you need to tell Kubernetes which pod you want to address. So let's run bin bash. Oh, haha, I did this on purpose. I wanted you to know about this. This is telling us kubectl exec command is deprecated, will be removed in a future version. Use kubectl exec pod ---- command. You really should use the double hyphen. You have them on the slides as well, so that kubectl clearly knows what is a part of kubectl and what should be interpreted by the container image. But deprecated, that means that it's still working, as you can see. Now I'm going to use yum install -y curl to install the curl utility, because we are in the sidecar container. The sidecar container is the web server. Normally, of course, you are going to access a web server from the outside. But in order to access your web server from the outside, we need to understand Kubernetes networking. And at this point, we don't. And for that reason, I'm going for the kind of silly solution to install curl inside the web server and to use curl on http://localhost/date.txt, which is giving me what? Which is giving me access to the data that was produced by our main application in busybox. And this is giving you kind of a simplified idea of how a sidecar container can be injected, where it really has a very direct relation with the main application. Main application generating data, sidecar container representing the data. And even in this case, you should wonder if you cannot split it into several pods and run it as a microservice where the pods are connected in a different way instead. But that will be the topic of a different discussion. So for now, let's just keep it as it is and continue. In this video, I want to talk about a special case of a multi-container pod, the init container. So what is an init container? Well, an init container is an additional container in a pod that completes a task before the regular container is started. So init containers can be a perfect solution to fetch something, for instance, if the main container needs something to be available. Because the regular container will only be started once the init container has done its work. And if the init container has not run to completion, the main container isn't started. Let's go check this out. So the init container is one of these elements that cannot easily be generated from an imperative command. So in order to work with init containers, you need to rely upon the Kubernetes documentation. So in the Kubernetes documentation, you look for init container. And there you go, you can see init containers as well as configure pod initialization. Configure pod initialization actually has the nicest example. And that's what I'm going to show you in my demo. But first, I want to show you init containers as well. This is the complete explanation, and in this complete explanation, we have a nice example. Here is the example. So what do we see in the example? We have a container, and a container is just running a dummy command in BusyBox. The thing that matters here is that there are two init containers. And the init containers are going to check using until nslookup my service. They are going to check and verify that the specific service is available. This relates to services, Kubernetes services, which is the way how applications are exposed on the network. And we will talk about that later. But you can use this as a dependency relation. Dependency relation as in do not start this application before these other applications are up and running. So you can also see that init containers as a list argument. So you can have one of them, you can have multiple of them. In here, it's two of them. And because it's two of them, well, the main application will only be started once both of the init containers have started successfully. So this is one example. There's another nice example as well. If we get back and we follow the other link, configure pod initialization, that is actually a bit more readable. And this is what I want to run for real. So I copied this over to one of the example files. And I would like to show you this example file, init example1. So what do we see? Well, we have a container. And this container is running Nginx. The container is mounting a volume. And the volume has the name workdir. So workdir is again emptydir. So that is this shared environment that can be accessed from multiple containers. I mentioned that in the multi-container scenario, and that goes for the init container scenario as well. If the main container and the init container have something to share, a shared volume is the convenient way of doing so. So user share Nginx HTML is what it's going to look at. And what is this init container doing? Well, this init container is running BusyBox. In BusyBox, it is running wget, and wget creates the file index.html in workdir. Now, what is workdir? Workdir, as you can see here, corresponds to this volume. This volume, which by the main container is mounted on user share Nginx HTML. So we have BusyBox, and BusyBox is using wget to fetch a file. And after fetching the file, it will be presented by the main container. So let's see how that is working out. kubectl apply -f on init example1.yaml and kubectl get pods. As I was fast enough, we can still see the init container in its state of init container. So we have init 0 out of 1, which means that we are still waiting for completion on the init container. And hopefully that is done right now. And as you can see, it is. And that means that the main container at this point is available and has its web content. Now, in case you think this is a difficult example, I created another one, which is init example2.yaml. And this is really the minimal example. So what do we see? We have a container, and the container has a name Nginx and an image Nginx, and it has an init container. And the init container is running a ridiculous sleep 3600 command. I did that on purpose because I want us to be able to analyze what is going on if the init container doesn't come up immediately. So let's run it. kubectl create -f init example2.yaml. And now kubectl get pods. Shouldn't be a surprise that it's getting stuck on init 0 out of 1. And it will be stuck on init 0 out of 1 for a long time. Now, if you get into a situation like this, then you might be interested in figuring out what is going on. So how are we going to do that? Well, kubectl describe. kubectl describe is such an important command. You use it in all occasions where you are trying to do something and you are wondering, hey Kubernetes cluster, what is going on? Why don't I get my workload? Well, kubectl describe will tell you all about it. First, go-to location is the events. So in the events, we can see that 41 seconds ago it was scheduled and it has created a container and it has started a container. And we don't see anything specific about the init container, but if we go up, then we can see the containers, and this container nginx is in a state of waiting. And why is the state waiting? Well, reason is pod initialization. So it's waiting for the init container. And this is what it looks like in kubectl describe if the init container has not yet done its work. And if you want to know what's going on, scroll up a little bit further where you can see the init container and the command that this init container is running. Now the command, as you can see, is sleep 3600. And the thing is that the init container will always run till completion. So as long as this command is not done, this pod will not get out of this state. And that's exactly what I wanted you to be aware of. So once more, kubectl get pods, not a chance. We will need to wait for another 58 minutes or so. Let's not do that now. You get the idea. Let's just use kubectl delete -f on init example number 2 because we don't really need it anymore. In this video, I will tell you about namespaces. So what is a Kubernetes namespace? Well, a Kubernetes namespace is based on a Linux kernel namespace. Namespaces were invented in the Linux kernel, and as Kubernetes typically runs on top of Linux hosts, Kubernetes can work with these namespaces across different hosts as well. And what it's all about is resource isolation. Resource isolation in such a way that you get real security. So Kubernetes leverages Linux kernel namespaces to provide the same functionality. And in Kubernetes, the namespaces are used to strictly separate between customer resources. You can also think of namespaces like directories. Directories which are used to organize different applications and make sure that components belonging to the same application are found in the same namespace. And that's also important, Kubernetes namespaces are also applied as security principles. For instance, role-based access control. That's not a topic that we are going to do in cKAD. You will learn about it in cKA. But the purpose with role-based access control is that you create a user and this user has specific rights inside a namespace. So you can have a namespace defined administrator or quota, in which you can set the limits to a namespace so that resources running within a namespace never get beyond a certain number of CPUs and a certain amount of RAM. Working with namespaces is not too complicated. There are 3 main commands that are involved. kubectl create namespace, that is how you create a namespace. kubectl whatever -n namespace, which allows you to work in a specific namespace. And kubectl get -- all namespaces. Feel free to use -A, by the way, to see resources in all the different namespaces. Now in Kubernetes, there is not a convenient way to set your namespace to something else. And I will tell you about it eventually, but not now, because honestly, I don't want you to use it. And that's an important exam tip. If you are going to use namespaces as a permanent setting on the exam, then I'm pretty sure that you are going to forget that you're in the wrong namespace and your resources will end up in the wrong namespaces. And the risk of you failing the exam because of that is just too high. So I would advise, if you need to work with resources in a specific namespace, use -n followed by the namespace, just the way that I'm going to demonstrate it right now. For your convenience, the slide lists the steps that I'm going to demonstrate. Let me just demonstrate. So to start with, I'm using kubectl get ns. kubectl get ns is showing the default namespaces that are available. So you can see there's a default namespace, there's a couple of system namespaces as well. And that's interesting. Well, we have used Minikube dashboard to start the Kubernetes dashboard. Minikube has created the dashboard resources in a dedicated namespace as well. If you want to get an overview of everything, kubectl get all minus uppercase A. Or minus all namespaces, but why would you type the long option if you can go for the short option as well? And there you can see organized by namespace the different resources. So what is it that we see? Well, mainly kube system. And in kube system, we have all the Kubernetes core components. The components that you see right here are the pods that make Kubernetes for what it is, including the API server, which is providing API access, including the etcd, which is the pod that stores the Kubernetes information in the database, including the kube scheduler, which is making sure that your pods are scheduled on an eligible node. So it's quite interesting to see what's going on in these other namespaces. At the same time, you probably understand why it makes no sense showing these pods in the default namespace. So by default, there's a nice distinction between user workloads and Kubernetes administrative functions. You'll also notice that when additional applications are started, like here the Kubernetes dashboard, or like we are going to discuss much later in this course, operators, they create a dedicated namespace as well. Just to make it easier to manage everything, keep it together, and if necessary, set your permissions. Now, how are we going to create a namespace? Simple. kubectl create ns secret. That would create a namespace with the name secret. There's not much going on if you create a specific namespace. It's just kubectl create ns followed by the name of the namespace, and that's it. And then you can put your workloads in there. So you can do that in the declarative way as well as in the imperative way. So if I use kubectl run secret nginx dash image is nginx minus n secret, then we get our secret nginx. But here it comes. If next you use kubectl get pods, you don't see the secret nginx. That is because kubectl get pods by default gets into your default namespace. Because the default namespace in the Kubernetes settings is set as the default. I can show you using kubectl config view, something we will talk about later, where we can see that we have this context, and this context is the Minikube cluster in which the default namespace is set. There are so many options in the output of kubectl config view that we shouldn't talk about right now, and I'm not going to do that, but I just want you to be aware where this default namespace is coming from. So we are just going to leave the default for what it is, and I'm using kubectl get pods minus n secret. The minus n option is what allows you to get into a specific namespace, and there we can see that secret nginx is running. Now, if you want to use the declarative way, you can also do that by creating a YAML file. I have created that YAML file for you, and oh, what do we see? We see pod with the name busybox will be created. Well, we do need namespace secret in addition. Hey everybody, you can see this is one of the first times where we are actually editing the YAML file. Before you do that, I would advise always check your upper and lowercase. kubectl explain on pod.metadata will show you everything that you can put in the metadata section, and here you can see namespace is all lowercase, singular. There's also owner references, and this is what I want to show you so that you are aware that you really need to take care of this. This owner references has uppercase R in owner references. So it's not always obvious if you need uppercase or lowercase. Likewise, it's not always obvious if you need singular or plural. Here we have namespace secret, so that should be doing all right. So kubectl create -f on busybox ns.yaml will create it for us. And next kubectl get pods -n secret will show all the workloads currently running in the secret namespace. And that's how you can use namespaces. Oh, one more thing, kubectl describe. kubectl describe ns secret. I told you that namespaces can be used to set quota. Namespaces can be used to define role-based access control. And if any such settings apply to a namespace, kubectl describe will show you. And this might be something interesting. Because if you run into trouble because of quota or whatever, just go check kubectl describe and make sure there is nothing special going on your namespace. In this video, we are going to talk about kubectl describe. kubectl describe is an awesome command that allows you to explore any resource created in Kubernetes. With regards to pods, when deploying a pod, many parameters are set to a default value. And you can use kubectl describe on your pod to see all of these parameters and their current settings as they are currently in the etcd. In fact, kubectl describe is a human-readable way of presenting the information that is stored in the etcd. In the etcd, it's all stored in JSON format. Most people don't consider JSON very readable. That's why Kubernetes is also offering YAML format to make it a little bit more readable. And even more readable, you have kubectl describe. So you will find many settings about it. And if ever you are wondering what does it mean, well, you can always have a look at the documentation, of course. And once more, as a tip, you should use this documentation on the exam as well. It's very valuable. Now, if you want to figure out in much more detail what's going on, you can also connect to a pod for further inspection. So connecting to a pod, that means that you are actually going to run commands on the pod to analyze what is going on. kubectl exec -it is what you do on a running pod. So kubectl exec is followed by the name of the pod. Then we have a dash and then in most cases sh. sh allows you to open a shell. Use sh because sh is available in most containers. Containers are minimized environments, so you won't always have a bash shell. And once you're in the container, run any commands to investigate and type exit to disconnect from your kubectl exec session. Now let me show you how all of this information can be used to explore what's going on in your pods. So whenever you want to analyze what is going on, you should always start with kubectl get pods. And kubectl get pods is showing me that a couple of pods are currently running. I want to work with my nginx. My nginx is good enough. So kubectl get pods my nginx -o JSON. Hey, I want to start all the way in the beginning. -o JSON is presenting the information pretty much as it is stored in the etcd database. And as you can see, it's not the most readable way to get access to the information, but you can get it all out. If you want it to be a little bit more readable, use -o YAML. We like -o YAML because -o YAML comes much closer to the YAML manifest files, which are so common in a Kubernetes environment. And in this -o YAML, you'll find all the different options that are used, including options that you might think, hey, what is this? Like enable service links. Do you know what enable service links is? Well, me neither. And you know what? I'm just going to copy it so that I'm not going to make a mistake because of the uppercase S and the uppercase L. And we are going to execute in a minute. The kubectl YAML output is also showing status. The status is the current cluster information. Before moving forward, let's do a kubectl explain on pods.spec. And what was it? It was enable service links. And there we go. We can see enable service links is a boolean, which indicates whether information about services should be injected in pod environment variables. Okay, that sounds pretty cool. If you still need additional information, go to the documentation. Just to make clear, it's not my intention here to explain enable service links. It's just my intention to show you how you can get beyond if you need more information. So the next tier of getting information about your application is kubectl describe pod on my Nginx. And in case you are wondering, hey Sander, you just type pods and now you type pod. Does that make a difference? No, it does not. Kubernetes is quite tolerant and you can use either of them. So here we can see the kubectl describe output. It almost fits on the screen, summarizing the most important information about the pod, including the events, where the events typically relate to what has happened with this pod in the cluster. That can be convenient for troubleshooting. Now, also convenient for troubleshooting is kubectl exec. So kubectl exec -it my nginx --sh allows me to really open a shell in my pod. As I was telling you, sh is your best chance because most containers don't have bash installed because it's bigger. Now, what are we going to do once inside? Well, you can investigate what is going on. So type ps aux only to find out that ps is not found. You know, it's nice that you can use a shell to execute commands inside your pod, but be aware that most of these pods are running pretty minimal containers. And in the pretty minimal containers, commands like ps and ipa, all of those are not found. You want to run containers that do contain these commands, you need to use a Docker file and make sure that you install it. Or in the running container, use the specific container package installation solution to install the packages. In most cases, that's not recommended though. Now, I do want to show you about these processes, because you will typically find yourself doing a kubectl exec to figure out what is going on. And we can see some important commands not being available. Fortunately, the mount command is available. At least we've got something telling us what is going on. But if you want to know more about processes, well, in Linux, there is this proc file system. And in this proc file system, if you type ls, you get an overview about everything that this container currently is doing. In the leftmost column, you can see these numbers, 1, 33, 34, 35, 45. These are the PIDs. PIDs as in process IDs. Every process that is running within this namespaced environment that is offered by this container has its own PID. And PID1 is just the entry point command that was used to start this container. And if you want to know what is going on, you can use cat on the process number cmd line. All of these process numbers are directories, and in the directories you find more information about what is going on. And here we can see the cmd line, which happens to be an Nginx master process. And if we do a cat on 33 cmd line, then we can see this is an Nginx worker process. So this proc file system really helps you in exploring information that you don't see at first sight. And once you are done, you can disconnect using exit. Between Ctrl-P, Ctrl-Q and exit, in this time we have opened a shell which is not PID1. If you are in a shell which is PID1, then you use Ctrl-P, Ctrl-Q if you don't want to shut down the container. In this case, it's safe to use exit to make sure that the container is, well, exited. And that is what I wanted to tell you about using kubectl describe and kubectl exec to figure out what is going on inside your containers. In this video, I will show you how you can use pod logs for application troubleshooting. So what's going on with these pod logs? Well, the thing is that the pod main application, also the entry point application, does not connect to any standard out. If you run an application on your computer, it generates output, you can read it. If you run an application in cloud native, it doesn't have an output. So you need something else. And the something else is where the application output is sent to the Kubernetes cluster, and you can use kubectl logs to connect to this output to figure out what is going on while running the application. kubectl logs is helpful in troubleshooting. So let's talk a bit about troubleshooting of failing applications. You can start by using kubectl get pods if anything is going on, and check the status of your application. That should always be the first thing that you are doing, because kubectl get pods will tell you if the pod is running or pending or failing or whatever. If you see anything that is not running, you can use kubectl describe on the pod to get more information about the pod. Even if you are going to run your applications in deployments, which we are going to talk about later, it is good to do a kubectl describe on the pod, because in the end it's the pod and nothing else that is actually starting the container running the application. So in kubectl describe, you should look for the current state and the last state. And if you find in kubectl describe that the pod main application generates a non-zero exit code, then you can use kubectl logs to figure out what is going wrong. I'm going to demonstrate how we can use these skills in order to troubleshoot a failing application. So let me use kubectl run mydb -- image is MariaDB. Now let's observe using kubectl get pods, and we can see it's currently in a status of container creating. That makes sense, because before you can run your container you need to fetch the image, and it happens to be that MariaDB and MySQL and other databases are pretty big. So give it at least half a minute, and then you check again. Oh wow, 28 seconds later, it's still in a status of container creating. Well, you know what? I'm already going to use kubectl describe pod mydb. You can also do that if the status of container creating is staying for too long, because sometimes there might be something going on in the cluster that prevents your image from being fetched properly. And kubectl describe is going to tell you about it. But now we are a little bit later, and we can see that in the flow of events 54 seconds ago, the container was successfully scheduled. Then 1 second ago, and 3 times over 53 seconds and 3 times over 21 seconds, it's telling us created container, but the fact that we can see age 3 times over, that's not good. So already based on this, we should further investigate. But first, let's see what is going on right now if you use kubectl get pods. And we can see the pod in a state of error. And if you do it again, you will see that this state is changing. You can see that right now it's crash loop back off. So back to kubectl describe. Let's scroll up a little bit and let's figure out what this container is doing. So we have a state waiting, and the reason is crash loop back off. Crash loop back off means that the primary application could not be started successfully. And as in Kubernetes, restart policy by default is set to always, Kubernetes will try again and again and again. The important information right now is the last state terminated, where we have a reason error and an exit code 1. So what is this exit code? Well, the exit code is generated by the primary application. The primary application is telling Kubernetes if it was successful or not. If you see an exit code 0, then from the application perspective, nothing is wrong. If you see an exit code 1, then from the application perspective, something is wrong. And you should use kubectl logs to investigate what exactly that is. So let's do that. Kubectl logs mydb is telling me what? Oh no, it is telling me that the database is uninitialized and password option is not specified. You need to specify one of. So we need at least one of the following environment variables. MariaDB root password. I'm going to use MariaDB root password. That doesn't give us a running database, but at least it gives you the tools to log into the database and create your own database if you want to. Now it happens to be that what we have right here is a pod, and there is no way you can update the pod. So the only thing that we can do is kubectl delete pods mydb. And now I'm going to use kubectl run --help pipe less, because I want to show you that right here we can see, and this is the example that I'm looking for, we can see the options that allow us to specify the environment variables. -env is what we need. So I can get back to the original kubectl run command and -env mysql root password is password. Hey, before we move on, if you think that this is really the way how you are going to provide variables to applications in Kubernetes, forget it. It's not going to happen. In real life, you are going to use ConfigMaps and secrets about which you will learn later in this course. For now, it's acceptable. But later, I will tell you that this is a pretty poor way of providing environment variables and other site-specific information to your application. Let's check again, kubectl get pods, and oh, look at that, we are already running. So as it is already running, there is no need for further investigation, but I do want to show you kubectl logs on my DB again. And what is that telling us? Well, it's telling us in a lot of detail that this database has been initialized successfully. And that's all that we need to know about. So from this point on, well, you might want to investigate what exactly the database is doing so that you can connect as the root user to the database to add further configuration. But that is beyond the scope of what we need to do for cKAD. For now, we know enough about using the pod logs as well as kubectl describe for doing some basic pod troubleshooting. Do it over and over again. These skills are pretty important on the exam. You have just learned about pod troubleshooting. Part of pod troubleshooting can also be to verify access to pods using port forwarding. So what is pod forwarding? Well, pod forwarding is one way to access pods. Pod forwarding is for troubleshooting only. Do not consider it a regular way to access workloads in your pod. The very simple way to access your pods is by using port forwarding, which exposes a pod port on the kubectl host. That's your local computer. That's a computer where you are using kubectl regularly. And that port forwards to the pod. So kubectl port forward fw nginx 8080:80 exposes a local port 80 that uses Kubernetes networking to connect to the pod. Pod forwarding is useful for testing pod accessibility, not to expose it to external users. And regular user access to applications is provided through services and ingress. I'll tell you about that later. For now, let me do a demo. So here you can see all the steps I'm going to run. For your convenience, I've provided them on the slide. Let me just demonstrate it for you. So I'm starting with kubectl run fw nginx --images nginx and kubectl get pods, but this time with the -o wide. So what do we see? We see that the pod is listening on the pod IP address 172.17.0.15. Hey, can't we access that? Well, honestly, no, you can't, because it's a pod IP address, and this pod IP address is accessible locally from the cluster only. You can't access it from the outside. You will learn more about it when we are going to explore networking in Kubernetes. For now, if you want to test accessibility to your pod, then the thing is kubectl port forward on fw nginx 8080:80. That starts the process in the foreground. That is why I'm using an ampersand to make it a background process. You see, it looks as if it's still running in the foreground, but if you press enter, then it goes away, and you can use curl on localhost :8080 to test accessibility to the pod. And as you can see, it's telling me welcome to Nginx, so that means that it is working. Now I am going to bring back the kubectl port forward to the foreground, and I'm terminating it using Ctrl+C. Because port forwarding is nice, but it's only for troubleshooting. It's not a permanent solution for accessing your pod workload. In this video, I will tell you about security context. Security context is used to define privilege and access control settings for a pod or a container, and it includes multiple settings, like discretionary access control, which is about permissions that are used to access an object, or security enhanced Linux settings, which is where security labels can be applied. Or you can use it to specify if a container should be running as a privileged or an unprivileged user. Also, you can use it to set Linux capabilities or define AppArmor settings and allow privilege escalation controls if a process can gain more privileges than its parent process. For a complete overview, it's always a wise idea to check kubectl explain on your pod specs. So how do we use it? Well, notice that security context can be applied to pods as well as containers. So you can use it to manage all of the properties of all of your containers or just a pod. When security context prevents a pod from running successfully, you can use kubectl describe to get additional information from the events. That's a skill that you might require on the exam because it allows you to figure out what is going on. And in some cases, you will need to analyze in more depth and use additional information, like the information that's provided by using kubectl logs on the failing pod. Now, I have two demos for you. Here is demo number one. Let's have a look. All right, so in the course Git repository, you will find security context demo 2.yaml. What do we find? Well, in the pod specification, as you can see here, there is security context, run as user, run as group, and fs group. What is that? It specifies the user as which this pod should be running, the group as which it should be running, and fs group, the file system group, the group that should be set as owner of any files that are created. Now, this security context is on the pod specification. We can see also there is a security context on the container spec. So we have a busy box, and in this busy box we have allow privilege escalation, which is set to false. Let's run this pod and let's figure out what it is doing. So kubectl apply -f security context demo 2.yaml. And kubectl get all to verify that indeed this security context demo pod is running. All right, now that my pod is running, let's use kubectl exec -it on this pod. To investigate how the security context is behaving. So first we can see that PS is showing that all processes are running with user ID 1000. That is because of the security context. Then if we go into the data directory and we use ls-l, we can see there's a subdirectory demo. And this subdirectory demo has file system group 2000. So if I try to touch anything in here, I'm getting a permission denied. But if I'm getting into the demo directory using echo hello greater than test file, then I can create my test file. And as you can see, the user ID and the fs group are set accordingly. The ID command, which is revealing Linux ID information, is showing that I'm user ID 1000. Primary group is set to 3000, but fs group, according to the security context, makes that the file I just created is owned by group 2000. I have a second demo. In this second demo, we work with the file security context demo.yaml. It's a little bit simpler, and you can see the security context is set right here. Run as non-root is set to true. So what is going to happen if we run it? Well, kubectl apply -f on security context demo.yaml is showing this. We need to give it a little bit of time. kubectl get all, is it already showing something? Too soon, still in the status of container creating. Let's try it again. And we get a create container config error. Now what is going on? If you get any errors in the status in kubectl get all, I would always advise you use kubectl describe on your pods nginx secure. And what do we see? Well, we see that kubectl describe is pretty well explaining what is going wrong. Container is run as non-root and image will run as root. So what is going on here? Well, what is going on is that the security context is preventing this container from running successfully. What does that mean? That means that security context is pretty cool, but you need to be careful that it does not create any conflicts with hard-coded settings in your container image. Sometimes what you want to do in your security context is just not compatible with the configuration of your container image, as we can see right here. This video is about jobs. So what is a job? To understand a job, you should understand a pod and the nature of a pod. Pods are created to run forever. Pods are the essence of Kubernetes. If your pod goes down, then Kubernetes is going to try to start it again. But in some cases, that's not really needed. If you want to create a pod that runs up to completion, you should use a job. So jobs are useful for one-shot tasks. Think about backup jobs, calculation, batch processing, and more. While working with the job, you can use spec.ttl seconds after finish to clean up the completed jobs automatically. The thing is that the job will run in the cluster, the job will create a pod, and the pod will run till completion. And then it will be marked as completed. Now, the question is if you want these jobs and completed pods to be around forever. The answer probably is no. And that is what the job spec TTL seconds after finished is all about. That allows you to clean up your job automatically and prevent you from drowning in information about completed jobs. While working with jobs, you should understand that there are different job types. 3 different job types to be precise. And you can use the completions and parallelism parameters in the job spec to define how you want your job to behave. To start with, there is the non-parallel job. In a non-parallel job, one pod is started unless the pod fails. That's kind of the default behavior, one job, one pod. That's it. In order to do that, you get completions is 1 and parallelism is 1, and these are the default values. Then there is a parallel job with a fixed completion count, in which the job is complete after successfully running as many times as specified in jobs.spec.completions. So in this case, you need to specify completions equals whatever and parallelism equals whatever else. Next, there is the parallel job with a work queue. So multiple jobs are started, and when one of them completes successfully, the job is complete. That makes sense to spread out your pods over different nodes, and you don't care who is going to finish first as long as one of them is going to finish first. In order to do that, you need completions is 1, because after all, you need one of these pods to be completed, and you need parallelism equals whatever. Very frequently, parallelism would be set to the number of nodes on which you want this job to run. Now let me demonstrate. Here on the slide you can find the demo for your convenience. If you want to run it yourself, this is what you can do. Let me run the demo for you. So I'm using kubectl create. Hey, this is the first time that really we investigate kubectl create. -h pipeless. And that will show you everything that you can create with kubectl create. This is really so convenient to know that you can create a lot of things with kubectl create, including a job and the cron job, which is going to be next. So what are we going to do? Well, we are going to use kubectl create job one job dash image is busybox dash date. So that is running a job. Oh, there's a typo here. Name of the job is one job. It runs the image busybox, and within busybox it runs the date command. That's typically a one-shot command, isn't it? Now I'm going to use kubectl get jobs, which is showing me what? It's showing me that we have one job, completion 0 out of 1. And kubectl get jobs, comma, pods will show me the jobs, which now shows completions 1 out of 1. And one pod, this is the pod that has been scheduled by the job that shows completed. This is also interesting. In order to understand what a job is doing, the job contains a specification that runs the actual pod. Let me show you what that means. If we use kubectl get jobs -o YAML pipeless, then we can see we have the job, the kind, which is set to job. We have the spec, which is the job specification. Here we have all these parameters that apply to the job itself. And here we have the template. And in the template, again, we have metadata and spec. If you see template, and that is something that you are going to see in a job, in a cron job, in a deployment, template typically refers to the pod specification. And everything that you see right here in job spec, template spec, is a specification that corresponds to the pod. So these are the pod properties, making sure that your pod is started the right way. So you could say that by running a job, you run a pod. Pods are managed by job if you run them through a job. There is one thing that we should figure out, and we can do that in the YAML on the jobs. We should look at the restart policy. And there we see restart policy is set to never. It's a little bit unreadable. Let's do a B5 to see the 5 lines before. And there you can see, and maybe you need a little bit more context, that's up to you. You can see this is a part of the pod specification. Now, if we use kubectl get jobs, we see that the job is still there. I don't want it to be there anymore. So kubectl delete jobs on one job will delete it for me. That will delete not only the job, but also the pods. So if I use get jobs and pods, then we can see that this one job pod is now gone. Now let's do it again, but this time in a slightly different way. I'm using kubectl create jobs, create jobs, my new job, -- image is busybox, -- dry run is client -o YAML -- sleep 5, and we put that to new my new job.yaml. Oh, there we go, my new job.yaml. And haha, did you see it? kubectl create jobs? No, my friends, kubectl create job. There we go, that is working better. So vim on my new job.yaml is showing me what? It's showing me the job specification. In the job spec, we immediately have the template and we don't have anything specific to the job. So I am going to modify that a little bit, and in the job spec, I'm going to add completions 3 and also TTL seconds after finished 60. And for the rest of it, we can keep everything as it is. Everything else is looking good. So kubectl create -f my new job.yaml. There we go. And TTL seconds after finish. Yeah, that's obvious. Do you see that? That's a typo. TTLS seconds after finish. That is not a thing. So let me edit this and make sure that we remove the 1s, that we have too many. And there we go, new job was created. kubectl get jobs, pods is showing me we have my new job, and my new job, well, 0 completions out of 3 for a duration of 6. And we can see my new job, the first pod instance is currently running. That needs some time, obviously. Now we can see that the last pod instance is running, and we already have 2 of them completed. And now, well, we need to wait. All of the jobs are completed. We still have the my new job available right here. So we need to wait for 60 seconds. All right, let's do another check. kubectl get jobs pods. where we can see that, yay, the job has been removed. And that is because of this TTL seconds after finished. TTL seconds after finished is a relatively new addition to the job specification. It has been in alpha and beta up to Kubernetes version 1.22, I believe. So if you're on an older version of Kubernetes, you might have trouble running this, but on a recent Minikube, this should work smoothly. In this video, we'll talk about cron jobs. You have just learned about jobs. Jobs are used to run a task a specific number of times. Cron jobs are used for tasks that need to run on a regular basis. When running a cron job, a job will be scheduled, and this job on its turn will start a pod. And to test a cron job, you can use kubectl create job my job dash from is cron job / my cron job. That's a very convenient way to make sure that your cron job is doing whatever it needs to be doing. Because without this option, you would only have one option, and that is to wait until it's time for your cron job to run again. Here I have prepared a demo. Let me run this demo for you, and let's try to understand what is going on. So let me start by using kubectl create cron job -h pipe less. Because kubectl so often is providing the information that you need if you just run -h. And here you can see some pretty nice examples. This is giving insight in how the base configuration is working. Next, I'm going to use kubectl create cron job run me -- image is busybox -- schedule is, and now we specify the schedule, *2, which is for every second minute, on every hour, every day of the month, every day of the week. And what are we going to run? Well, -- echo greetings from the cluster, or whatever you want. Do notice if you run a cron job, you need to specify the command that you want to run inside the cron job using the normal syntax, where -- is closing the kubectl command, is adding the arguments on the command line. And here we can see that the cron job has now been created. So kubectl get all should show that. And there we go, we have the cron job. The cron job has been created, so it's just waiting for the next schedule. And now it is doable to wait, but if you want to trigger it, you can use kubectl create job run me -- from is cron job / run me. That is triggering the job to run right now. And that's perfect for testing. So what do we see? We see the cron job, we see the cron job has started a job, and we see the job has started a pod. So you can also filter it down a little bit easier. kubectl get cron jobs, pods. That is showing you in a more specific way just the resources that you want to know about. So at this point we can see that it has even been started twice already. That is normal, because this is going to happen every 2 minutes. You want to make sure that it worked out the right way. Use kubectl logs on run me what was the name of the pod again? There we can see the 277 pod. And that is connecting us to the standard output of the main application, and that is showing that the message has been displayed the right way. Now that we are happy with this cron job, kubectl delete cron job run me. We don't need it anymore. That's all. In this video, we'll talk about resource limitations and quota. So let's first try to understand what this is about. Resource requests and limits can be set as an application property. By default, the pod will use as much CPU and memory as necessary to do its work. And you can limit it. by using the memory and CPU requests and limits that can be set in pod.spec.containers.resources. So in the end, it's a limitation that you apply to a container. In the terminology, you should understand that a request is an initial request for resources. So if you know that your application requires 10 megabyte, you can set a request of 10 megabyte. Requests are useful because if your application needs a lot of memory, the request can be matched to a cluster node that is capable of offering everything that is requested. A limit is an upper threshold of resources that a pod can use. So if you want to make sure your pod never goes beyond 1 gigabyte, just limit it to 1 gigabyte. And even if you have a zettabyte of memory available, it will never be able to go beyond 1 gigabyte. So memory as well as CPU limits can be used. CPU limits are expressed in millicore or milli-CPU, which is 1,000th of a CPU core. So 500 millicore is 0.5 CPU. And when being scheduled, the kube scheduler ensures that the node that is running the pod has all requested resources available. And if a pod with resource limits cannot be scheduled, it will show a status of pending. The status of pending is pretty important in your troubleshooting of workloads. If ever you see a status of pending, then it means that the Kubernetes scheduler could not find a node that is offering the requested resources. You can use kubectl set resources to apply resource limits to running applications if they are running in deployments. We haven't really talked about deployments yet. We've glimpsed upon it, so I will show you anyway, but more details about the deployments are in the next lesson. Also related to all of this is a quota. So what is a quota? Quota is a restriction that is applied to namespaces. And if quota are set on a namespace, applications that are started in that namespace must have resource requests and limits set. And you can use kubectl create quota -n my namespace to apply quota. If you want to set quota, use kubectl create quota -h because this kubectl create quota has some awesome help available. So I would like to demonstrate resource requests and limitations. The first demo is pretty simple. Here you can see what it's all about. The second demo, which will be after this one, will be a little bit more advanced, but you need to know that stuff on the cKAD exam as well. So here we go, demo number 1. So for this demo, I created a YAML file, front-end resources.yaml. And this YAML file allows you to check how it works. So you can see the container has a resources attribute. And in the resources attribute, we have requests and we have limits. So the request is set to 64 megabytes and CPU 250 M, 250 millicore, 1/4 of a CPU. And the limit is set to 128 megabytes. So we have this front end, which is running 2 containers, a DB and a WP, database and WordPress. And WordPress has requests and limits as well. Just one note, this is really not how you want to create an application that runs WordPress and database. Normally you want to run separate pods, but I wanted to include it in one YAML file so that we can investigate these resources that are used here. Now let me use kubectl apply -f on front-end resources. And then we need to wait a little bit. That is because WordPress as well as the database take a little bit of time to fetch the image. Let's see if they're already here. And oh boy, what do we get? We get a very special one. Front end is OOM killed. What does that mean? Well, we can figure out kubectl describe pod front end. And what do we see? Well, in the events, we don't really see anything that is relevant. But if we scroll up, then we can see last state terminated, OOM killed, exit code 137 on the database. Now, what is this OOM killed? OOM is out of memory. This is Linux telling the application, hey, sorry dude, we are out of memory. Why is Linux telling it that? Well, because the resource limits is too strict. Only 128 megabytes of memory. You can't run this application with just 128 megabytes of memory. So you know what? There's one solution only, and that's kubectl delete -f frontend dash resources.yaml. All right, now that we have deleted it, let's edit this front-end resources a little bit. So now I want to do the opposite. I am going to request 64 gigabyte. I want to show you what's happening if we make a request for 64 gigabyte. And the limit, 128 gigabyte. The limit doesn't really matter, it's the request that matters. And I hope you realize I don't have a Minikube server with 64 gigabytes available. So again, kubectl apply -f on frontend resources.yaml. The images at this point are already fetched, so it should be a lot faster. And kubectl get pods is showing me pending. Pending means that it is waiting for the scheduler to find a node that meets the required conditions. kubectl describe will tell us what's going on. So kubectl describe pod frontend. Right here is telling us, warning, can't find a node. 0 out of 1 nodes are available. And that is because of insufficient memory. Of course, because the memory request was ridiculously high. Let's delete it again and let's run it one more time, but this time in a way that it will make a chance. So 64 gigabytes, no, we are not going to request 64 gigabytes. Let's request 256 megabyte and let's limit to 2 gigabytes. That's reasonable. That should be doing it. So once again, let's do the kubectl apply and kubectl get pods. And now we can see, oh, I was too fast. 3 seconds is too optimistic. But within 8 seconds, we can see it's in the status of running. I do advise after running this demo, please delete it because this MariaDB and WordPress are heavy applications. They consume too many resources. You don't want to be running out of resources. Now this was demo number 1. Let's have a look at demo number 2. So as mentioned, this demo is a little bit more complicated. And we are going to have a look at deployments as well, but that shouldn't matter too much. This is about resources and how these resource restrictions relate to quota that are set on namespaces. Here are the steps from the demo. Let me show you. So let me start by creating a namespace. kubectl create ns restricted. And next I'm going to use kubectl create quota. -h, by the way, is showing awesome help for the creation of quota. So if ever you need to do this on the exam, use kubectl create quota -h. So let's set quota for this namespace. kubectl create quota my limits -n restricted. Dash hard is CPU is 2, comma, memory is 1Z, comma, pods is 3. And there we can see the quota is created. And we should be able to see that if we use kubectl describe ns restricted. As you can see, the resource quotas, the settings, including the use is right here. Now we are going to try to run a pod. kubectl run pod, restricted pod, dash image is nginx -n restricted. And is that going to work? That is not working because you must specify CPU and memory limits for the pod. So here is how it works. If you have a namespace that uses quota, all resources need to have quota as well. Now, in order to set quota on pods, that's a bit complicated, and that is why I'm going to create a deployment. We'll talk much more about deployments in the next lesson, But hey, the deployment is just a number of pods, and I am creating the deployment using kubectl create deploy restricted deploy dash images nginx minus n restricted. And of course, that is not going to be successful immediately. kubectl get all minus n restricted is showing us what? Is showing that nothing is happening here, 0 out of 1. We know why. That is because I don't have any resource limitation set. Now, the nice thing about deployments is that you can use kubectl set resources on a deploy. So again, use -h for an overview, and here you can see what it looks like on the command line. So I use kubectl set resources deploy restricted deploy dash limits is CPU is 200 M and memory is 2G minus N restricted. And there we can see that the deployment requirements are updated. And if we do the get all again, it well, probably was just a little bit too soon. It will be there in just a minute. Okay, now that I've set resources, let's do a kubectl get all minus n restricted to figure out what is going on. And oh no, I have deployment apps restricted deploy ready 0 of 1. Can we investigate why? Well, kubectl describe minus n restricted of the deployment is showing what? It's scaling, it's trying to scale it up. And it is telling a replica failure, failed create, a minimum replicas unavailable. That doesn't look good. Can we get more information in the replica set? The replica set is the restricted deploy 7cc. So we need to describe the replica set as well. Replica set on restricted deploy, and specifically the 7cc, because that's the last one. And what do we see? Error creating pods is forbidden. Exceed quota, my limits. Requested memory is 2 gigabytes. Limited memory is 1 gigabyte. So the limitation is wrong. And that is kind of funny. I'm setting a limit of 2 gigabytes. That's a limit, it's not a request, but this limitation is higher than the limit that is available on the namespace. So we need to set the resources again. And let's do that. kubectl set resources minus n restricted on the deploy restricted deploy dash limits is CPU is 200 M and memory is 128 M, and dash requests is CPU is 100 M and memory is 64 M. The essence here is that all of this is within the boundaries that are set. So kubectl describe is telling me now that the resources are used, and if we use kubectl get all again, now we can see that the pod is running. Now, what have we learned here? We have learned that using these quota on the namespace together with the restrictions and the limitations on your workloads can be quite confusing. I would advise run through this demo again. You have all the steps on the slide. Analyze what is going on. Try to understand what is going on. And above all, try to understand why this demo can be problematic. In this video, I would like to talk about a small, fun topic, cleaning up resources. So why would you want to clean up resources? Well, in most cases, resources are not automatically cleaned up. That means that you might want to create maybe a cron job to clean up your resources. There's only a limited number of resources, like the job, that have options for automatic cleanup if they are no longer used. And for everything else, periodic manual cleanup may be required. So why am I thinking about cleanup right now? Well, because it's getting busy in our cluster. We've been trying a couple of things, and as a result, there are many pods running in the Minikube environment. At some point, if you don't clean up, memory may get saturated and you might get in trouble because of that. So we are going to talk about cleanup. Now there's one thing to know. If your pod is managed by something else, like a deployment, then the deployment must be removed, not the pod. And try not to force resource to deletion because it may bring them in an unmanageable state. Normally, when you use a kubectl delete command, the kubectl delete command is passed to the node that is currently running the resource, and the node will remove it. If you will force it off, then it will be forced off, but it might not be properly removed from the database. And if that is happening, troubleshooting improperly removed resources from the Kubernetes database might be very complicated. And on the exam, might bring you trouble. So I'm going to show you the force option and the grace period option, but on the exam, be extremely careful with them. Here's what I'm going to run, only not the last step. Let me just show you. So to start with, I'm using kubectl get pods -a, and you can see there's quite a few of them. I am going to use kubectl delete all. And what is kubectl delete all? A resource were provided but no name was specified. If you are going to use kubectl delete, let's try to understand what this command is doing. So kubectl delete is allowing you to delete resources. But if you delete resources, you need to specify a name. If you don't specify a name, you need to specify -all. So kubectl delete all -all means delete all resources with all names. And that is basically what we want, isn't it? So kubectl delete all all resources, all names. And there they go. And that is doing nice little cleanup. Oh, do you see that? It's also deleting the service Kubernetes. The service Kubernetes is a part of the Kubernetes cluster itself. Is that a good idea? Probably not. But the good thing is that this is a managed resource. You delete it, it will automatically be created again. We just need to be a little bit patient here. All right, that took too long, wasn't it? No, it was not. Because of the fact that it took a little bit of time, the resources were cleaned up nicely. And that's exactly what you want. From the current namespace. As you can see, the resources in the other namespaces still exist. Now let's first talk about this nicely removing. So kubectl delete all -all. If you don't want to wait, you can add -force. Grace period is -1, which means force don't wait and let's go for everything. This is a very powerful command, very dangerous. You shouldn't use it. Even more powerful and probably the stupidest thing that anyone can ever do in a cluster is this command with the -a option at the end. The -a option is for all namespaces. Don't try it. Because bad things will happen to your cluster and you are most likely going to end up in a dysfunctional state. The command that you see right here is the equivalent to rm-rf/ in a Linux system. So let's just remove this command and continue with the end of lesson lab. So we have talked a lot about pods. Let's talk about deployments, because deployments are how you really want to run your applications. So the deployment is a standard for running applications in Kubernetes. I told you before, do not run naked pods. You do want to run deployments because deployments offer features that add scalability as well as reliability of the application. Scalability is about scaling the number of application instances. And that allows you to make sure that you have enough workload available if demand for your application is scaling up. There's also updates and update strategy, which is all about zero downtime application upgrade. When we talk about updates, we talk about changing parameters, changing variables, changing images and more. So that's pretty important. Also, the deployment will protect your pod and it will automatically restart them if anything goes wrong. In order to create a deployment, you use kubectl create deploy. Let's go check it out. So kubectl create is how you create a deployment. kubectl create deployment or deploy, which is also allowed. Then you need a name for your deployment. Mandatory argument is the image. So image is nginx. It will automatically pick the latest version of the nginx image. And -- replicas is 3. That's so convenient. Recently, in version 1.18, the option to add the -- replica option while creating the deployment has been added. Before, you couldn't do that. So if you are on an old version of Kubernetes, you might see that -- replicas is not supported. And you need to scale up the deployment manually. But right here, we are going to do it with 3 replicas. Right, if we check the deployment, kubectl describe deploy on my web, then we see what is going on. So what do we see? Well, a namespace. That's a default namespace, obviously, because we have not used -n to work with any other namespace. Then there is a label. This label is pretty important. We will talk about that separately, but already I want you to be aware. If you use kubectl create to create a deployment, then automatically the label app is name of the deployment is set. And this label is used as a selector. And this selector is what you need to connect to the same label that is set at the pod level. I will show you that once we investigate what the deployment looks like in YAML format. Then we see the information about the replicas. Apparently I've been too fast because 3 desired and there were 2 available only. The update type, we'll talk about it later. And then we have the pod template. Oh, look here, in the pod template we can see the label app is my web already. So this selector makes sure that the deployment automatically picks up all the pods that are running this specific label. You can see what the container is doing, including the essential parameters for the container. And we can see some more information, or some status information, including the events. Now it's interesting to see that immediately after creating the deployment, it has already scaled it up. So it doesn't run one instance first and then scale it up. No, that happens automatically. Now if we use kubectl get all, then what do we get? We get our deployment. The deployment has started a replica set. Next, the deployment has started these different pods. So it's the deployment managing all of them. Pods are managed entities, so you cannot manage pods independently if they are a part of the deployment. And that is something that I'm going to show you. Look, I'm going to use kubectl delete pod my web, followed by no matter which one, the sr2qs. Then I'm using kubectl get all again. And what do we see? Well, look at that. The sr2qs is gone. And now a new pod has been started. Because that is what a deployment is doing. The deployment is helped by the replica set. The replica set is taking care of the replication. And the replica set makes sure that if the desired number of pods is not present, well, the replica set will kick in and it will start a new pod instance. Right, this is pretty important behavior in a deployment. And this by itself should already be the reason why you want to run nothing but deployments. But I do want to show you, if you run a naked pod, kubectl run pod mypod -- image is nginx, and then kubectl get pods, we do see the new pod in a status of container creating. Shouldn't take too long. And oh, what do we get? We are getting an error. That's unexpected behavior, but I'm going to investigate what's going on anyway. Often, while errors are occurring, it may happen that they fix themselves. Apparently, that's not happening. So kubectl describe on the pod. Oh, look at that. I already see what's going on. kubectl describe pod. What is the name of my pod? The name of my pod is pod. Come on. So what do we see? Back of restarting failed container. And this restarting failed container, it's giving me an error state on exit with an exit code 127. So I think kubectl run. Yeah, there we go. kubectl run pod my pod. My pod is not a valid argument. So this was my mistake. Let's do it again. And now kubectl get pods. Hey everybody, by the way, I'm not trying to avoid errors that I'm making by accident, because on your exam, these errors and knowing what to do if an error occurs, even if it's because of a silly typo, that is such an important skill. Now we can see that my pod is running, as well as pod. Let me start cleaning up. kubectl delete pod. We don't need this pod anyway. But then what this is all about, kubectl delete pod my pod. Now we have just seen that if you delete a pod which is a part of a deployment, the deployment doesn't like that, and the deployment is going to start it automatically again. And what do you think is going to happen if we delete a naked pod? That's right, nothing is going to happen. And that is because nobody's taking care of the naked pod presence. And hey, if you think, didn't we have a restart policy in the pod? Then I would say, smart question. We do have a restart policy, but this restart policy is for the container in the pod, not for the pod itself. So if you delete the pod, it's gone. And that is why you should always use deployments. In this video, we are going to explore deployment scalability. So let's try to understand it. I want to start with a little bit of history. In the original Kubernetes API, the deployment did not exist. And to manage scalability, the replica set resource was used. Well, in fact, replication configuration was the name of the resource in old versions like 1.8 and before. In Kubernetes, that's a long time ago, at least 4 years ago. With the introduction of the apps API extension, the deployment was introduced. And from that moment, the scalability was managed in the deployment and no longer in the replica set. Well, that is not entirely true, because to manage scalability, the deployment creates a replica set. And this replica set was fully compatible with the replication configuration that existed before. But this replica set is a managed resource. You should not manage replica sets directly. You manage it through the deployments only. And that is why I'm not separately explaining the replica set, because you don't care. You care about deployments. Deployments is all that you are going to work with. Now in Kubernetes, you can manage scalability in two ways. You can manually do it to start with. And in order to do so, you would use kubectl scale followed by the name of the deployment and followed by the number of replicas that you want to run. That is, if you want to change the currently running number of pod instances. It's also possible to use the horizontal pod autoscaler. That's not a part of cKAD, but at the end of this lesson I'm going to show you anyway, just because it's cool. Alternatively, you can also use kubectl edit deployment on a deployment to edit the number of replicas manually. You should notice that kubectl edit, it looks so awesome. It's not, because with kubectl edit you can only modify a limited number of options, and these options can also be changed using kubectl set. If you want to start a deployment with a specific number of replicas, as we have seen before, you can use kubectl create deploy -- replicas is 3. So let me show you how to manage scalability manually. Alright, I would like to start with kubectl API resources, just to show you what we were just talking about. So here on the top couple of lines, this is the original Kubernetes API. That is what it all started with. And in the original Kubernetes API, there's a replication controller. So in very old versions of Kubernetes, there was no deployment, you would use the replication controller instead to determine the number of pods that you want to be running. Then the apps API extension was added. And in the apps API extension, as you can see, the deployment has been added, the replica set has been added. Where replica set is giving you full compatibility with the previously used replication controller, but really deployments is what you should be using. Right, I would like to create some deployment. This time we are not going to use kubectl create deploy, but we are going to use redis deploy, which is one of the YAML files that is in the course Git repository. So here we can see API version, kind is set to deployment. We see the metadata, including the label, where it's pretty important that this label right here matches this part where we have the selector, match label, app redis. And then we have the pod template, and in the pod template we see this label again. And for the rest of it, nothing specific is happening. As you can see, the replicas is not set. And if replicas is not set, you will get one replica only. So let's run it. And let's see if we're up for a surprise. kubectl create -f on redis deploy. And oh no, what do we get? Well, we are getting unable to recognize redis deploy.yaml, no matches for kind deployment in version apps v1 beta 1. Now, what is that? Well, we can use kubectl API versions. And if you use kubectl API versions, then we will see that there is the apps API, and the apps API is in v1. Some APIs like batchwrite here still have v1 and v1 beta 1, but Kubernetes being a rapidly evolving platform, old API versions are becoming deprecated and at some point will disappear. So there are many good things to say about using YAML files, but one thing that you should take care of is that if old versions of the API disappear, you update your YAML file. And that has never happened to this redis deploy YAML. So what do we need to do? Well, very simple. We are addressing an API that doesn't exist. So let's change that to apps v1 and try again. The error message is not very clear about it. No matches for kind deployment in version apps v1 beta 1. They could also have mentioned wrong API version or something like that, but they don't do that. So you need to take care of it. Now we can run it again, and now we can see that the deployment apps redis is created. If we use kubectl get all, we can see the redis deployment has been created. There is a replica set and there is one pod inside. Now I would like to use kubectl edit in order to edit the deployment redis. Not because I like the kubectl editor, but we need to have seen it at least once. So in kubectl edit, I'm going to use to change the number of replicas, and I'm going to set it to 3. Now that looks very convenient, but please be aware that you cannot change everything in kubectl edit. Let's try, for instance, to change the namespace as well and set the namespace to secret. And then I'm getting out of there, and oh no, there we go, and we see that this is not working out all right. That is what I need you to be aware of in kubectl edit. It looks so cool, but you can't change everything. We do see that the replicas change has been processed, so that is okay. And if we use kubectl get all again, we can see the redis deployment. Now here we already have something that is kind of annoying, which is too much information, which is why I'm using kubectl get all -- selector app is redis. I'm using the label here. I will separately talk about the label, but I want to show you how you can use the label to only see resources that match that specific label, so that you are not getting overloaded with information. Right, now I'm going to use kubectl delete rs on redis whatever, and I'm using kubectl get all again, and look what's happening. I deleted the replica set, but the replica set is a managed resource. We see two things here. We see that because of deleting the replica set, All the pods belonging to the replica set are deleted as well. We also see that the new replica set has already been created and new containers are already being created in there. And that is a nice example of Kubernetes taking care of its scalability. This video is about application updates, which go through deployments as well. So how does that work? Well, deployments allow for zero downtime application updates. And this zero downtime application update is applied to different parts of the deployment. It happens when you change the image version, any parameter that can be used with kubectl set as well. And when an update is applied, a new replica set is created, while the old replica set is still kept around. In this procedure, pods with the new properties are started in the new replica set. And after successful update, the old replica set is no longer used and it may be deleted. But you can also keep it in case it doesn't work out well. That allows you to revert to the previous version. I will show you later how we can do that. In the deployment spec revision history limit, there's a parameter which is set to 10, and that will make sure that you keep the last 10 versions of your replica set. So you can even get back multiple steps in case you didn't like the update. While working with updates, there is the update strategy. That's a deployment property which defines how to handle updates. And you have two choices. You can go for the rolling update, which is a standard, and you can go for a replace. Now, what is a replace? Replace means that you are going to stop your entire application and you are going to start a new application. That is what you are going to use in case your application doesn't support running multiple versions at the same time. The rolling update is what you need if you want zero downtime application updates. Let's say you have 3 pods currently running. In a rolling update, the deployment is going to replace them one by one. So it brings down an old pod instance and it brings up a new pod instance with the new properties in the new replica set. Then it brings down another one, it brings up another one, thus ensuring that at all times you have full application functionality. Let me show you how this works. So let me start by creating a new deployment. kubectl create deploy nginx up -- image is nginx 1.14. So if you use kubectl describe on the deploy nginx up, then we can see in the container property that the image is set to 1.14. And if you use kubectl get all -- selector app is nginx up, then we can see the deployment and the replica set as well as the container. The container is still in a state of container creating. Still after 25 seconds. That is because we are using a rather old version of the nginx image, which needs to be fetched first. Let's verify that it's already there. Yeah, it's there. Now we are going to use kubectl set. kubectl set is such an awesome command. You can use it to set a new image version or environment variables or resources and some other resources as well. The resources, by the way, that is about quotas. So if you want to make sure that your deployment can't use beyond 4 megabytes of data, this is how you do it. But for now, kubectl set image deploy nginx. Nginx is nginx colon 1.17 or whatever you want to do. Oops, making a mistake. That is nginx up because that was the name of my deployment. So if I use my kubectl get all again, then what do we see? We see that there is still this old pod that is running. Now, if you look closely at the name of the pod, then you can see that there is this 9874, etc. in the pod name. This 9874 matches the suffix in the replica set name. So that allows you to identify where the pod is coming from. So right now we are still in the old replica set and we are still on 1.14. But we can also see that the new pod is being started, and that is being started in the new replica set. That was only 4 seconds ago, but if you look again at this moment, then we can see that there's only one pod available. And this one pod is in replica set 76B5, and that means that the rolling update at this moment is completed. And again, we still have the empty old replica set. The empty old replica set contains all the properties of the previously running application, which means that if in testing you find out that it didn't work the way you expect it to work, well, then you can easily revert. And that is why rolling updates are cool. You will learn about reverting to the previous version of the application later in this lesson. So we have seen labels on a few occasions already. Now let's talk about labels, as well as selectors and annotations. So labels are a key value pair that provides additional information about Kubernetes resources. You can set it manually. They are automatically set as well, but they are used a lot because they are used to keep resources together. In order to do so, the label is set in a resource like a deployment and a service, and it uses a selector to connect to related resources. In most cases, that would be pods. The deployment, for instance, finds its pods using a selector. The service, for instance, finds its endpoints using a selector. We have not talked about services yet. We'll do that shortly. Administrators can also manually set labels to facilitate resource management and selection. So labels allow you to group specific applications, and these labels can be used in network policy, for instance, to determine whether or not applications are getting access to specific resources. If you want to find all resources that match a specific label, you can use --selector key is value. We have already seen that because in the automatically created labels, which are created when you run a deployment, you automatically get a label with the name app equals app name. And if you are using kubectl run to run a pod, then you also automatically get a label with the name run equals pod name. But this app equals app name is very important because it allows the deployment to keep track of its pods. The run equals pod name is not so very important. It's just an identifier label because naked pods are not related to anything normally, unless you manually create a relation, of course. Then there is also the annotation. Now, what is an annotation? The original idea was to provide detailed metadata in an object. And annotations cannot be used in any queries, and also originally they didn't even have a real function. Think about information about licenses, maintainer, and more stuff that doesn't really matter. But recently introduced resources in Kubernetes may use annotations to provide additional functional information about the resources as well. Annotations are not so very important. You are not manually going to manage them a lot, but labels are. Let's go check out how to work with these labels. So let me start. kubectl create deploy blue label. This image is nginx. Now let me also use kubectl label deployment blue label. State is demo. kubectl label is a command that you can use to set labels manually. And now kubectl get deployments -- show labels. So this is showing that all the previously created deployments have app equals name of the deployment, and my blue label deployment also has state is demo. Now we can use that if you use kubectl get deployments -- selector state is demo. -- selector can be used with key equals value on all labels that you want. Now it's becoming a little bit more interesting. Now let me do kubectl get all -- show labels. Show labels, as we've seen before, is showing the labels. And in these labels, oh, that's a lot of information, but we need to deal with this lot of information. We can see the deployment. App is blue label, state is demo. we can see the pod it has created as well. And now the thing I need you to realize is that if at any time after creating you set a label on a deployment, this label is not inherited by the resources created by the deployment. So the deployment has a status demo, the pod has not. So if you use kubectl get all -- show labels -- selector state is demo, then we will see one resource only. That's something to keep in mind. Now let's have a look at these auto-created labels a little bit. First, I'd like to show you kubectl describe deployment blue label. Because we can see that there is this label, app is blue label. This label is applied in the deployment metadata as a selector. Then we can see that this label returns in the pod as well. The selector is monitoring for pods containing this specific label. So what does that mean? Well, that means that if we use kubectl label pod blue label app minus, what is that doing? Well, that's removing the label. If ever you want to remove a label, just use kubectl label key minus, and that will remove it. And now if we use kubectl get all, now what are we going to see? Then we are seeing, oh, that's interesting, an error image pool. Let's check out what that is doing in just a little bit. But the thing that I want you to be aware of is that because of removing this label, the deployment can't find a sufficient number of pods anymore. So it's trying to run a new pod. And there we go, and we have this error image pool we need to investigate. So once more, kubectl get all. And oh, the error image pool is already over. Some errors are just temporary and go away all by themselves. Now we do need the show labels once more. In the show labels, we can see this one doesn't have app is blue label anymore. And that is why the replica set couldn't find a sufficient number of pods anymore. And it started a new pod.
In this video, you will learn what you can do to manage the deployment update strategy. So when a deployment changes, the pods are immediately updated according to the update strategy. You have two options. Recreate means that all pods are killed and new pods are created. The result is temporary unavailability, but this is useful if you cannot simultaneously run different versions of an application. In databases, for instance, this scenario is frequently required. A rolling update is what updates pods one at a time to guarantee the availability of the application. And that's a preferred approach, and you can further tune its behavior. So how do rolling updates work? Well, it's the task of the deployment to ensure that enough pods are running at all times. So when making a change, this change is applied as a rolling update, and the changed version is deployed in a new replica set. After the update has been confirmed as successful, the old version replica set is scaled to 0 to deactivate. Scaling to 0 is interesting because it allows you to roll back in an easy way. You can use kubectl rollout history command to get details about recent transactions, and kubectl rollout undo to undo a previous change. Undoing the previous change just means that you are scaling the new replica set to 0 and you scale back the old replica set to whatever number of pods you needed. Now, when working with rolling updates, there's a couple of options that can be used. These options are used to guarantee a certain minimal and maximum number of pods to be always available. Max unavailable determines the maximum number of pods that are upgraded at the same time. And max surge is the number of pods that can run beyond the desired number of pods as specified in a replica to guarantee minimal availability. Here we have the demo. Let me run it for you. So this demo assumes that you have a deployment with the name blue label. Let me use kubectl create deploy blue label -- image is nginx. Now we can investigate it. So kubectl get deploy blue label -o YAML pipeless. Because we want this strategy. So what do we see? In the strategy, we have the different settings that apply. A rolling update, max search is set to 25% and max unavailable is set to 25%. These are the default options. Now, if I would use kubectl edit deploy blue label, then we can edit it. And we need to look up these options, and I'm going to set max unavailable to 2 and max search to 4. This of course is only going to work if we have a sufficient number of replicas. So let's start by scaling. kubectl scale deploy blue label / replicas is 4. And let's check it out. kubectl get all -- selector app is blue label. And there we can see 4 replicas currently are running. All right, now let's trigger an update by using kubectl set env deploy blue label. Type is blended. The thing is that updates can happen at different items. kubectl set is an awesome interface to apply the updates. Here I'm just updating an environment variable. You might as well update the image, whatever you want to update, that's up to you. So we need to check what is going on. And do you see what is happening? We see the max unavailable. So 2 currently are unavailable. And we also see the max search. 4 containers are being created. And that is because of this max search. And this max search temporarily goes beyond the number of replicas. You must make sure that your cluster nodes have sufficient resources in order to manage that, but it will make sure that the process is done with as fast as you can imagine. And there we go. As you can see, all of the new replicas are now running. And the old replica set is still here, scaled down to 0. And you can unroll that if you want to. In the next lesson, we'll discuss how that is working. All right, we have just talked about rolling updates and its features. Now let's investigate how we can use it to work with deployment history. So in deployment updates, the deployment creates a new replica set that uses the new properties. And the old replica set is kept, but the number of pods will be set to 0. And the purpose is that it is very easy in this way to undo a change. The kubectl rollout history command will show the rollout history of a specific deployment, and it allows you to easily revert back to a previous version as well. Use kubectl rollout history deployment my nginx -- revision is 1 to observe changes, and use kubectl rollout history undo if you want to get back to a previous version. Let's go check out how this works. So for this one I have a YAML file, rolling.yaml. What is in rolling.yaml? Well, we can see the rolling update with a max search of 2 and a max unavailable of 1. Just wanted to show you that you can easily change these parameters in your YAML code as well. And then we are using a very old version of nginx, version 1.8. So let's do a kubectl create -f rolling.yaml and kubectl get deploy. So rolling nginx is here, as well as the other deployments that we've used so far. Now if you use kubectl rollout history deploy, then what do we see? We see the rollout history for all of the deployments. This is a nice list view that allows us to see what exactly has happened. Let's work on the rolling nginx. You can see there are no changes for rolling nginx yet. We are going to change that. So kubectl edit deploy rolling nginx is one way of doing that. So I need to change the image version. Notice that you can alternatively also use kubectl set image to do exactly the same. So here is the image, and I am going to set that to 115. Now let's use kubectl rollout history deployment rolling nginx, and there we can see that we have a revision 1 and we have a revision 2. We don't see any change scores, and that is because we have not used the record option. There's a record option, but this record option is has gone to a state of deprecated, and that's why I'm not showing it. But if you would use kubectl edit with the record option, it would actually have shown you what the change involves. Now I am going to use kubectl describe on the deployment rolling nginx. And what do we see in kubectl describe? Well, we don't see the old nginx version anymore. We do see the new nginx image version, and we do see the process of the rolling update here as well. And in this process, you can see it's all about scaling up and down. So it was removing a replica, adding a replica, removing a replica, adding a replica within the constraints of the rolling update settings that we have used. Now, of course, the interesting thing, if you are using kubectl rollout history on a deployment, the interesting thing is where you want to know what exactly has happened. And to figure that out, you use kubectl rollout history deployment rolling nginx -- revision is 2. And what do we see? Well, we get an overview of the different settings that have changed. Notice that this is also a very nice way of monitoring the settings that can change. So if we look at a revision is 1, there we go, and we can see this is the nginx version 1.8. And in case you want to get back, well, kubectl rollout undo. Let's do kubectl rollout -h just to investigate, so that we can see that you can do an undo, you can check the history, you can restart, pause, resume, and show the status as well. Of all of these, the most useful option is the rollout undo. So let's use kubectl rollout undo on the deployment rolling nginx -- revision. Revision is 1. And now kubectl get all. We always need to be a little bit fast. It's getting quite busy, so it's difficult to see, but here we can see the process in action. 1 container being terminated, 3 still up and running, and 3 in the process of being created as well. We do it again, and there we can see that the process is completed. Now I do want to clean up a little bit, so let me show you something that you can do as well. kubectl skill deploy blue label -- replicas is 0. Why would you want to do that? Well, if you delete it, it's gone, and it's difficult to get it back. If you scale back to replicas is 0, well, kubectl get all is showing that the application is still here, and we can see the deployment has already 0 out of 0, up to date 0 and 0, and there are no pods belonging to that application anymore. But don't be confused, this one doesn't belong. And let me prove that. kubectl delete pod blue label. You remember this blue label pod is from the demo where I removed app equals blue label. So this one is not really a part of the blue label deployment anymore. At this point, you can see blue label, the deployment still exists, but it doesn't have any pods anymore. Do we show that in the rollout history? Well, kubectl rollout history deployment blue label is showing a version 1 and a version 2, but this version 2, that is not because of the change of the number of replicas. That was because of the change of another property. Which one was that? Well, kubectl rollout history deployment blue label -- revision is 2, and there we can see
This was because we have added the environment variable, type is blended. So that was completely different business. Keep that in mind, that the change in the number of replicas is not reflected in the rollout history. Because it's not really a change to the application, it's a change to the way how Kubernetes is dealing with the application. And that's just happening at a different level. So most of the times when running applications, you will be using deployments. There are two special kind of deployments as well, which are the daemon set and the stateful set. At this point we will talk about the daemon set. Stateful set will come later because it integrates to networking and storage as well, and it doesn't make sense to talk about it without understanding what these are all about. So let's talk about daemon set. A daemon set is a deployment that starts one pod instance on every node in the cluster. So you can understand that in our Minikube environment, daemon set is not going to be spectacular. But the use of the daemon set is in a multi-node cluster where you need specific software to be running on all of the cluster nodes, like a network agent, for instance. When nodes are added or removed, the daemon set automatically changes the number of pods accordingly. And that is cool because in this way the daemon set ensures that you will always have at least one pod instance on all of the nodes. There is no way to use kubectl create. For creating daemon sets, you need to use YAML code to create your daemon sets. Let's go check out a simple example of a daemon set. To show you how to work with daemon sets, I created a file in the course Git repository. The name is daemon.yaml. So what do we see? We see it is defined in the API apps v1. It has a kind, and the kind is daemon set. In the metadata we have a label, and the label is set to Kubernetes app nginx daemon. And then in the spec we see a match label. The match label is name nginx daemon, and that matches to the label that is in the template. And what else is it doing? Well, in case you are wondering, wow, this really looks like a deployment, then you are right. This does look like a deployment. You can even consider a daemon set like kind of a deployment. There's just a difference in 2 or 3 properties. A deployment has a number of replicas, daemon set has not, because you would use a pod instance on every single node in the cluster. And of course, daemon set is daemon set instead of a deployment. So if we run it, kubectl create -f daemon.yaml, it will be created, and we can use kubectl get ds, pods. And we can verify using kubectl get ds, pods, in which we see the daemon set and we see the pod as well. In the pod naming, you can see that the naming doesn't have 2 suffixes, only one. That's because it's a daemon set. Maybe also interesting is to use kubectl get ds and pods in the kube system namespace, because in the kube system namespace we also have daemon sets. That is because daemon sets are an excellent way to make sure that important system components are available on all of the nodes in the cluster. Of course, the spectacular example of daemon sets will only show if we are going to add nodes in the cluster. That is something that we will do in Certified Kubernetes Administrator, not in cKAD. In this video, we will discuss a bonus topic. That's about the horizontal pod autoscaler, a very convenient resource that you can use to automatically scale the number of replicas. Just to make sure you understand, for cKAD you need to know how to manually scale pods using kubectl scale. In real clusters, pods are often automatically scaled based on resource metrics that have been collected by the metrics server. And the horizontal pod autoscaler is a dedicated API resource that observes usage statistics, and after passing a threshold, it will add additional replicas when that is required. Once again, setting up autoscaling is not required in cKAD,
But as it is so important in real clusters, I would like to include a demo about it. This demo does require the use of metric server. Good thing is that metric server is so easily set up in Minikube. And setting up metric server in other clusters is covered in more detail in cKAD, because that is really a cluster administrator-like task. So I'm going to run a demo. The demo is very much based on what you will find in the Kubernetes documentation as well. But I thought, hey, maybe it makes sense to run the demo and tell you a little bit about everything that is happening. To make it a bit easier to follow along, have a look at the Git repo where there's a directory autoscaling. This directory autoscaling contains a Docker file as well as an index.php. We don't really have to run it, but I need you to understand that this index.php is starting a heavy calculation job, and the Docker file is using this index.php as a custom index.php for a web server. So if you want to run it, then you can use docker build -t on PHP, PHP Apache on dot, and that will build the container image for you. Or you can go the easy way and just use the image that is also available online. So to run this application, I have provided hpa.yaml, and hpa.yaml runs the deployment. There we go. In the deployment, we have the PHP Apache. It runs the image from the online repository, which is totally fine. And then it runs a service. We haven't really talked about services, but the service makes sure that the application is accessible under the name PHP Apache. On port 80, and when we address PHP Apache on port 80, then really what we are doing is we use this deployment. So let's do a kubectl apply -f on hpa.yaml to apply this. And then we need to take care of the autoscaler. So there's kubectl autoscale, which is a dedicated command. Run it through -h to get an example, and here you can see what the example looks like. So this is basically what we are doing. So we need to tell the autoscaler what it needs to do and which deployment it needs to autoscale. So let's use kubectl autoscale on the deployment PHP Apache with CPU% is 50, and then minimum is 1 and max is 10. So what does that mean? Well, that means that if the deployment hits a threshold of 50%, then it will make sure that it will automatically scale up the number of pods up to a maximum that is defined as 10 right here. So here we can see that the horizontal pod autoscaler has been working. If you use kubectl API resources grep auto, then you can see that this is actually an API resource all by itself. So horizontal pod autoscaler HPA comes from the autoscaling v1 API, and that resource has been started by using the kubectl autoscale command. So there you can see that it is working for PHP Apache, and if you want, use a kubectl describe for a bit more details about what it is doing. All right, the next part is where we need to put this application to work. Before demonstrating, let me show you what I'm going to do by pushing the slide. All right, now that we have the autoscaler up and running, we need to create some work. kubectl run -it load generator. So we create a pod with the name load generator. -rm because we want it to be removed once it is done. Image is busybox. So we are using the generic busybox image. It doesn't have to restart if anything is going wrong.
what it does have to do, it has to run a command. So bin sh -c while sleep 0.01 do wget -q -o minus on http://php apache done. Give it a minute, and if we don't see anything weird, we see okay. So that is good. That is showing that it is working out all right. Now, if we use kubectl get hpa, what is going to happen? Well, nothing so far. And why is that? Well, that might be because the horizontal pod autoscaler needs a little bit of work, but it might also be because we need to deploy the metric server. You can see that the targets are already at 71% instead of 50%, and you will see that value slowly increasing. And there we go, it's already up and running. Hey, you know why that is? That is because Minikube add-ons list is showing us that this Minikube is already running the metrics server. If you do not yet run the metrics server, it's easy to run it. Minikube add-ons enable metrics server. I'm going to type it anyway so that you can see the command. So add-ons enable metrics server. The thing is, without the metric server, you cannot actually collect data that is required by the horizontal pod autoscaler. Here we can see that it's doing quite all right. It already has 5 different replicas up and running. Of course, we can also see that from the deployment perspective. So if you use kubectl get deploy php apache, you see the number of replicas currently being set to 5. And back to the HPA, and eventually it will probably climb up a little bit more. So that is how horizontal pod autoscaler is working. Now we need to clean it up. So kubectl delete pod load generator. It is going to delete the load generator, and we can verify that in the other screen once it is done. Of course, the pod is busy, so it takes a little bit of time to get out of the way. So it is deleted. We can see that in the other terminal. And right now, it's interesting to see what the HPA is doing. So the HPA is currently set to 6 replicas. So now that the workload has decreased, horizontal pod autoscaler will eventually bring down the number of pods again. We're not going to wait for that. I think this is enough for a basic understanding of what horizontal pod autoscaler is all about. So before we are getting started, I want to give you an overview of what networking in Kubernetes is all about. So in networking in Kubernetes, it's all about the pods, okay? So let's say we have 2 different applications where we have pod 1 and pod 2 and pod 3 belonging to one application. But there's another application as well running pod 4 as well as pod 5 and pod 6. I like to see this as a typical microservice solution where we have a front end and a back end. Let's say pod 1, 2, 3 are the front end, pod 4, 5, 6 are the back end. In order to communicate, all of these pods are connected to a network. And this network is the pod network. And this pod network is an internal network. And on this internal network, the pods have their own IP addresses. So these IP addresses really depend on what you've got. That can be 10.10.0.1. And let's give all of them an IP address so that it's clear what we are talking about. Now these pods are all instances of the same application, and that means that you are not going to access these pods directly. In order to understand accessing applications in a cluster environment, you should know that there is a second network, and this second network is the cluster network. This cluster network still is an internal network, but this cluster network provides access to the outside, and the outside is where we have our nodes. So your node 1 and your node 2 and your node 3, which are the nodes that are actually running your pods. These nodes are connected to the cluster network. And hey, to make the picture complete, these nodes are also connected to a network. So you need to understand that there is a node network as well. And this node network, that is your external network. So that is where your users are coming in. So if you have a user right here, the user is capable of directly accessing anything that is running on the nodes. Now that we know about these three different networks that you will find in a Kubernetes environment, we need to talk about services and how do these services fit in. Well, services are used as an API-based internal Kubernetes load balancer. So that means that we can have a service for this front-end application, and we can have a service for this back-end application. And the service is doing load balancing, and it means that incoming requests are load balanced to the pods that the service is exposing. Now, in order to do its work, and that is what is important here, the service can use multiple types. In cKAD, there are two types that are mainly important, and that's what I want to talk about here. We have the cluster IP type, and we have the node port type. Now, what is a cluster IP? The cluster IP is a service that is only available on the cluster net. So we have an IP address like 10.96.11.12, and even if you have node port, you are still on the same cluster net, so you need an IP address on that cluster net as well. But what exactly is the difference between cluster IP and node port? Well, node port is exposing a high port on the nodes, and that means that on your cluster nodes you will get a high level port. I am going to use port 32,000 in my demos, and this node port is actually a port forwarder. So all of these node ports are redirecting to the node port service type. That means that if we are accessing the cluster, you could make a configuration where the user is accessing one of these node ports. Is that what you want? Of course not, because your user in a cloud-native environment shouldn't have to worry about node IP addresses or even DNS names. Your user wants something else. So even if this is a valid configuration, and I'm going to demonstrate this configuration all over in this lesson, even if this is valid, there is another resource that is involved, and that is the ingress resource. Ingress is in the next lesson, so I will tell you how ingress is connecting to services and making sure that users can connect to ingress to get access to your actual application. But let's forget about ingress for now. I do want to spend a few more words on node port and cluster IP, because it seems so useless that cluster IP is a service type that is only accessible on the local cluster IP address. Well, it is not, because if this is your front end, this is your back end, your front end like a WordPress website, your back end like a database, then this WordPress website needs one way to get to the backend database. You don't want to expose your database on the internet. You do want it to be available locally. So by using node port and cluster IP, you have a perfectly secure way to connect a front end and a back end to one another. And this is basically what Kubernetes networking looks all about. Keep this in mind while we investigate the different parts of Kubernetes, because as long as you see this big picture, it's not that difficult to understand. In this video, I want to explain Kubernetes services. Let me start with the most important. A Kubernetes service is not the same as a systemd service. The terminology is confusing here. In systemd on Linux, a service is a process like your web server or your database. The equivalent in a Kubernetes service of the systemd service would be your pod. The service in Kubernetes is for exposing your application in the network. So let's go check it out. Stated otherwise, a service is an API resource that is used to expose a logical set of pods. And services are applying around robin load balancing to forward traffic to specific pods. This is load balancing that is happening at the Kubernetes level. So there is no physical load balancer involved. It is just the Kubernetes load balancer that's working internally, making sure that an end user connects to a specific pod. The pods that are targeted by a service are determined by a selector. And the selector is a label. That is like we have seen in deployments and pods as well. You already know that the deployment is reaching out to its endpoint pods by using a selector. And if the selector disappears, then the deployment thinks there's one pod missing. In services, that is not different. The kube controller manager is a process in Kubernetes that is running on the Kubernetes controller node, and it will continuously scan for pods that match the selector, and if it finds a pod that matches the selector, it includes these in the service. And if pods are added or removed, they will immediately show up in the service. Well, immediately, that means at the next run of this kube controller manager. Now, services implement decoupling. That means that they exist independently from the applications they provide access to. So you are going to learn how a service is using a deployment to expose pods, but don't think that upon deletion of the deployment, the service is deleted as well, because that is not the case. The service is an independent resource and it survives the deployment if that goes away. The only thing that the service is doing is that it watches for pods that have a specific label set matching the selector that is specified in that service. Well, basically it's a kube controller manager doing that and making sure that these pods are showing up as service endpoints. This flexibility also means that one service can provide access to pods in multiple deployments, and while doing so, Kubernetes will automatically load balance between these pods. That is actually a strategy that is used in the canary deployment, which we will discover in a later lesson. Now, while using services, kubeproxy plays a role as well. Kubeproxy is an agent that runs on the nodes and it watches the Kubernetes API for new services as well as endpoints. When we talk about endpoints, we are talking about connected pods, by the way. After creation, the kubeproxy opens a random ports and listens for traffic to the service port on the cluster IP address, and next it redirects traffic to a pod that is specified as an endpoint. And the kubeproxy works in the background and it doesn't require any configuration normally. Alright, now that we know a little bit about how the service integrates in the networking, let's talk about service types. Kubernetes provides different service types. To start with, cluster IP. Cluster IP is the default service type. It exposes the service on an internal cluster IP address. Internal, that means it's not accessible by external users. Then there is node port. In node port, port forwarding is added. So on the host that runs the actual application, a high-level port is dynamically allocated, and that port is accessible by external users. And when external users should access this external port, their traffic is forwarded to the service cluster IP address, and from there the traffic will be forwarded to the actual end nodes. Then there is load balancer. Load balancer is currently only implemented in public cloud. And external name works on DNS names where redirection is happening at the DNS level. This is useful in migration. For your cKAD, you should focus on cluster IP and node port. And in the next lesson, I will show you how to create services of both of these types. Now that we know about the different types of services, let me show you how to create services. So first, a quick overview. You can use kubectl expose to create services, to provide access to deployments, replica sets, pods, or even other services. In most cases, kubectl expose is used to expose a deployment, which allocates its pods as the service endpoints. And that's kind of funny. You use the deployment to expose the pods. And if you analyze what's going on in the service actually doesn't connect to the deployment. It connects to the pods directly by using this selector label. As an alternative solution, you can use kubectl create service. That's just bringing you the same. While creating a service, no matter how you do it, you must use the -- port argument to specify the port that the service should use. Now, ports in services are slightly confusing. So let's talk about the ports. There are different ports that are in use. There is the target port. The target port is the port on the application or the container that the service addresses. So if your container is running your web server on port 8080, your target port should be set to 8080. Then there's the port. The port is the port on which the service itself is available. It's a property of the service, and in many cases it's the same as the target port. Also, there is no need to do anything difficult regarding the port, because the service is running a dedicated IP address, and on this dedicated IP address, well, this port will be the only one. It's not as if you are taking care of ports that are exposed on the node that is actually running the service. Then there's the node port, and the node port is the port that is exposed externally while using the node port service type. So you will only see it if you use the node port service type, and it's normally dynamically generated around the 32,000s. Let me make a quick drawing to make sure you understand these ports before we are moving forward. In this drawing, I would like to visualize what all the ports are all about when working with services. So in the center of the picture, we have the service. And the service is providing access to some pod. Now on the pod we have an application, and the service wants to address the application. And in order to be able to address the application, the service has a port specification. And the service points to the target port. Now, what is a little bit confusing is when you are creating your services, you need to specify the port, not the target port. And if you specify the port, then by default, the same target port is used. And if you want to use a different target port, then you can specify that as well. Now, there is also this thing called node port. Now, what is the thing with the node port? Well, the node port is all about the node. And that is the physical node in the cluster, which might be one node or multiple nodes as well. And if you use the node port service type, then you need to specify this node port property. So the result can be that you have a node port which is 32,000. And by addressing this node port, you can address the service with its port. And if your pod is an Nginx pod, for instance, running on port 80, this would be port 80 as well. But there's nothing preventing you from using a port 8080 if you want something different on the service. At the same time, there is no reason to specify a different port address on the service, because every service is using its own IP address anyway. So there's no risk of any conflicts from happening. Here on the node port, you need uniqueness. And that is why node ports normally are generated dynamically. Here on the service as well as on the pod, you don't need uniqueness because these ports bind to a separate IP address. So that's how these ports are used. Now that we understand what these services are doing, let me show you how it works. So in my demo, I am going to walk you through a procedure which you can find on this slide and the next slide. Again, the slides is for your convenience to make it easier to follow along with the demo. Good, to start with, we are going to create a deployment. kubectl create deploy nginx svc -- image is nginx. And I'm going to scale it up. kubectl scale deploy nginx svc -- replicas is 3. Of course, I could have done that in one command as well, but hey, it doesn't hurt reminding you of kubectl scale again. Now kubectl get all is showing us deployment with the 3 different pod instances. And now we are going to expose it. So kubectl expose deploy nginx svc. As always, -h is providing excellent help here. In case during the exam you can't remember what exactly you can do, look right here for all the different examples. Now, we are going to keep it quite simple. So I'm using kubectl expose deploy nginx svc -- port is 80. So -- port is 80, that is the port that is going to be used in the service, which will forward to the port in the actual application as well. Now let's do a kubectl get all, and in kubectl get all we can see that there is this nginx service. It has obtained its own IP address. That's a cluster IP address. And as we have seen in the beginning of this lesson, the cluster IP address is not externally reachable. And we can see the port, and the port is set to port 80. Now, more interesting is to use kubectl describe svc on nginx svc, because kubectl describe is also showing us the endpoints. And the endpoints are the actual connecting pods. And this is what is dynamically adjusted by the kube controller manager if any pods are added or removed from the deployment. You can see that in different ways as well, like kubectl get svc nginx svc -o YAML. There we go, we have the YAML output, but the YAML output is only showing the service itself. It's giving a little bit more details like the type, which you can see here, but it's not showing the endpoints. That is because the endpoint is really dynamically fetched by the kube controller manager, and for that reason you need to use kubectl describe, or if you want to, kubectl get endpoints for a flat list of endpoints. Now we need to do something with it. And what are we going to do with it? Well, I need back to kubectl get svc because I need the service IP address. What do you think is going to happen if I'm using curl against 10.97.14.2.33? Well, nothing is happening. And does that make sense? Of course that makes sense, because our service is of the type cluster IP. And cluster IP means not reachable. If we want to reach out to this service, we need to go into one of the cluster nodes. In Minikube, you can do that easily by using Minikube SSH. So here I am on the Minikube host, and if on the Minikube host I'm using curl HTTP against the 10.97.14.2.33 again. Oops. And let's do that without typos. There you go. Welcome to Nginx. So that works. That is cluster IP. Cluster IP is for internal access only. Nice to see. Let's change that and let's make that we can access it externally as well. So I'm using kubectl edit svc on nginx svc to edit some properties. So what are we going to edit? Well, I am, to start with, changing the type. The type needs to be node port. That is with an uppercase N and an uppercase P. And I'm going to add a port as well. So we have port 80, target port 80, and I am going to add a node port as well. Hey, isn't that confusing? Here in the property we have node port with a lowercase n, and then in the type we have node port with an uppercase n. That's just the way it is. Get used to it. Good, I'm going out of my editor, and kubectl get svc should immediately reflect the change. As you can see, nginx svc is now of the type node port, and we see the port forwarding configured. So port 80, that's the service port, accessible through node port 32,000. And that means that if I'm going to use curl on http //minikube IP, minikube IP 32,000, then I am getting access to the nginx service. So this is how node port is working. And now, in case you are wondering, what is this thing with this $minikube IP? Well, let me briefly show you. Minikube IP is showing the IP address of the Minikube, right? If I use echo $minikube IP, this is what we call command substitution. That's a bash shelving. It's a Linux shelving, and it's going to work with the result of the command minikube IP. So when I use this $minikube IP in my curl command, really curl was reaching out to the result of the minikube IP command. So that would make it equivalent to using curl on HTTP 192.168.49.2. So this is how you use services. All right, services are the way to make sure that you can access your applications in Kubernetes. Services can be used in a special way in microservices as well. And I briefly want to talk about that before continuing and exploring some more about networking. So what is there to know? Well, in a microservices architecture, different front-end and back-end pods are used to provide the application. So the classical microservice example is a front-end WordPress and a back-end database. And if you want to do that, you are not going to run these containers in the same pod. No, you are going to run a front-end deployment with WordPress and a back-end deployment with database, which allows you to be very flexible at both levels. In that scenario, the backend, which is the database, can be exposed internally only. Using the cluster IP service type. And front-end, which is your web servers or your WordPress, can be exposed for external access using the node port service type. And I want you to be aware of that, because you might think that cluster IP, that sounds so useless. Well, it's not really useless. It is indeed very useful if you only want to provide access to specific applications, to internal processes, and not to external users. Let me make a quick drawing to make sure you understand what that would look like. So let me visualize how these different service types can be used in microservices. So in microservices, we have the pod network as always. And on the pod network, we have the pink application. All of the different components of the application have their own IP address. And we have the green application. Then in the networking, we also have the cluster network. And on the cluster network, we have the different nodes. And these are the nodes that are providing access to the external users. So right here, we have the external network. So this is external cluster pod network. So what are we going to do in this microservice environment? Well, that's pretty easy. We are going to run one service, and this service is going to be of the type node port, working as a load balancer for the front-end application. Now, node port means that the service is available on the cluster IP with the cluster IP address, but it also means that there is this specific port that is exposed on the nodes in the cluster. And that means that these ports, which are normally dynamically generated, these ports are going to be accessible. That is what the purpose of node port is. So if you have a user right here, the user can access this node port. And by accessing the node port, actually access the microservice application. Now, how about the backend application? Well, in the backend application, you have the cluster IP. and cluster IP service type that is just not exposed. Cluster IP is only available within the cluster. And the nice thing about it is that this doesn't even have to be an IP-based connection. There's also the so-called headless service. And in the headless service, you are running a cluster IP, and the cluster IP doesn't even have an IP address to totally secure it. The nice thing is that your front-end application doesn't need it, because the front-end application, it's all happening in the API. And as everything is in the API, the name of this cluster IP service is enough, and you can do it without an IP address. We will see that later in this course as well, an example of this headless application. Now do realize, even if this does provide for an access model, in the next lesson you are going to learn about ingress, and ingress is going to make the picture even more complete and make it easier for the user to access your applications. But this is what it would typically look like in a microservices environment. In this video, I would like to explain how services relate to DNS. So in Kubernetes, there is an internal DNS server available. It has the name core DNS and it runs in the kube system namespace. And when you create a service, the service automatically registers with the Kubernetes internal DNS. So with services that expose themselves on dynamic ports, resolving service name otherwise could be challenging, but the solution is provided by this core DNS server. And the nice thing is that not only does the service register itself with core DNS, but also the pods are using this core DNS service as a DNS resolver by default. And that means that from a pod you can always access the services by name without having to do anything in addition. Let me show you. So let me start by running a test pod, kubectl run test pod. Image is busybox and sleep 3600, and let's use kubectl get svc. So we can see there is nginx svc, right? Now if we use kubectl get svc pods -n kubesystem, now what do we see? We see there is a kubedns service at 10.96.0.10, and there is core DNS. And these two are working together to make sure that you get access to any service that has registered itself. So let's do a quick test first. kubectl exec -it testpod --cat etc resolve.conf to show you that the resolve.conf is set to the kubedns Kubernetes name service. So that means that if we are going to run a command like nslookup on nginx svc, then the nslookup is telling us nginx svc.default.svc.cluster.local is in the address 10.97.14.23, which happens to be corresponding to the nginx svc IP address that we can see right here. Now about the service name. The service name is constructed as follows. We have cluster.local, which is the name of the cluster. Then we have svc, which is for the services, default, which is the namespace in which the service exists, and nginx svc, which is the name of this namespace. And as you can see right here in the search order, the pod has a search order, so it will automatically look up names, even if these are not FQDNs in any of the domains listed here. And that is how services work perfectly together with Kubernetes DNS. In this lesson, I'll tell you about network policy. So by default, there are no restrictions to network traffic in Kubernetes. Even if the pods are running in different namespaces, they are all on the same IP subnet. If you don't like that, you can consider using network policies. There's one big restriction, and that is that network policies need to be supported by the network plugin. If you use a Calico network plugin, then you should be good.
And you will be good, because that is exactly what we did while setting up Minikube earlier in this course. The Weave plugin does not support network policies. So if the upcoming demo is not going to work in your environment, you should suspect that it's because of the network plugin. Now, if there is a network policy, and if the network policy applies to your pods and there is no match, traffic will be denied. If no network policy is used, all traffic is allowed, and that is the default configuration. Now, while working with network policy, it's very important to understand the network policy identifiers. And 3 different identifiers can be used. There's the pod, used as pod selector in the network policy. There is namespaces. Use namespace selector to grant access to specific namespaces. And there's IP blocks. IP block is how you use it. And traffic to and from the node where a pod is running will always be allowed, regardless of what you are doing with IP block. When you are defining a pod or namespace-based network policy, a selector label is used to specify what traffic is allowed to and from the pods that match the selector. So applying the appropriate selector label is extremely important in network policy. Last thing, network policies do not conflict, they are additive. Here we have the demo about network policy. Let me run it for you. So this network policy example is in a YAML file in the course repository. What is it doing? Well, we can see it defines the network policy. And this network policy is using a pod selector with a match label app-nginx. That means that this network policy applies to pods that have app set to nginx. To this pods we define ingress. Ingress from pod selector match labels access true. What does that mean? That means that only on pods that have this label app is nginx, we are only going to allow incoming traffic from pods that have the label access is true. So next, you can see that here an nginx pod is defined with the label app is nginx set. Then there's the busybox pod. And this busybox pod has app set to sleepy. And in case you are wondering, hey, that is not access is true, that is exactly what I want to demonstrate here. So let's run kubectl apply -f nw policy complete example.yaml. And let's do a kubectl expose pod nginx -- port is 80. Why do we need that? Well, that's for the accessibility. We want the pod to be accessible, so we do need a service on top of it. So now that we have the network policy, we can inspect it using kubectl describe network policy, just to figure out what it has. And there we can see we have pod selector app is nginx, which applies it to the nginx pod. And to-port is allowing traffic to all ports. And pod selector access is true. That is the ingress that is defining where traffic is allowed from. So if this is working all right, then kubectl exec -it busybox -wget -spider timeout is 1 on nginx is going to fail. This is expected behavior. Now, you should know that all of this depends on the configuration of your network agent. If you are using the Calico network plugin, this should normally be working all right. But the combination of different network plugins with different platforms can give you surprises. So it is possible that in some specific environments, you will be able to download anyway. Network policy is too heavily dependent on the network plugin, and for that reason may give failure. Don't worry about it too much if that is happening, because sometimes it's just the way it is. Let me use kubectl label pod busybox access is true. Why is that? Well, because we allow traffic from pod selector access is true. And now if we repeat the previous command, we can see that the remote file exists. And that is what network policy is supposed to do. In this video I'm going to explain ingress. Let's start with the drawing. In the previous lesson we have talked about services. Now we need to talk about ingress. So in order to do that, let's draw in the service. And that can be a cluster IP service. That can also be a node port service. For this picture, we don't really care about the pods. The services are exposing access to the pods, and the services know about these pod endpoints. We already know about that. Then there is the border between the Kubernetes cluster and the world. So the world, this is where your users are coming in. Now, how are your users going to get in to your Kubernetes cluster? Well, in order for your users to get in, we need ingress. And ingress is running a controller. And this ingress controller really is a load balancer. That's also what makes ingress interesting. Ingress can work with different kinds of load balancers, and you will notice that these ingress controllers are provided by the community to make sure that different load balancers are available. So there is no default ingress, there are multiple ingress solutions, and these ingresses are a load balancer. This load balancer connects you to the Kubernetes cluster nodes, and in order to get access, well, we have a straight connection from the load balancer to the cluster. But ingress is also an ingress API resource. An API resource, that means that ingress has a life inside the world of Kubernetes. And that makes it possible for ingress to make a direct connection to no matter which service. That goes for cluster IP as well as node port, because cluster IP and node port, well, as long as you're in the API, it's just a matter of one API resource accessing another API resource. Now, how does the flow of an incoming application request work in the context of ingress? Well, right here we have our user. Our user is going to request access to an application, myapp.com. So what is going to happen? Well, the user will connect to DNS. This is just internet DNS, so this is normal name resolving. Now, the DNS name resolver needs to be configured to forward the packet to the ingress load balancer. And once the ingress load balancer is hit, well, the load balancer will forward the packet to the API. And once we are in the API, we're in the cluster, and ingress is going to use the services to connect to the backend pods. To make it a little bit easier, you will notice that ingress isn't really forwarding the packet to the service. That wouldn't make sense, because the service is living in the API, and there's no IP traffic here. You will notice that ingress at an API level knows about all the backend pods. So as a 4-step procedure where the user is going to issue a name, will be resolved by DNS, will be connected to the ingress controller. Once you're in the ingress controller, you're in the cluster and you are ready to go. And that's how ingress works. So what is ingress all about? Well, ingress is used to provide external access to internal Kubernetes cluster resources. It is to make sure that external users can get access to your applications. To do so, ingress uses a load balancer. And this load balancer is a physical load balancer that is present on the external cluster. It can be HA proxy, it can be hardware load balancing, it can be Nginx. There's many choices. This load balancer itself is implemented by the ingress controller. And this ingress controller is additional software that you need to run in your cluster. So ingress has two phases. It has a phase as an ingress controller load balancer, but also as an API resource. As an API resource, ingress uses selector labels to connect to pods that are used as a service endpoint. And to access resources in the cluster, DNS must be configured to resolve to the ingress load balancer IP. In the drawing you have seen how ingress controller, the API resource and DNS are all connected together and working together to get your users access to the applications.
So ingress exposes HTTP as well as HTTPS routes from outside the cluster to services within the cluster. And traffic routing is controlled by rules that are defined in the ingress resource. That is something that you can perfectly do in ingress to make sure that you define which URL redirects to which service in the cluster. So if you want to give it an overview, ingress can be used to do the following. It can give services externally reachable URLs. Of course, in cooperation with DNS, because if you don't configure your internet connected DNS to resolve these URLs, it's not going to work. Ingress can load balance traffic. It can terminate SSL as well as TLS, and it can offer name-based virtual hosting. Let's talk a bit more about these ingress controllers, because ingress controllers are what makes ingress a little bit challenging. If you create ingress resources without ingress controller, that has no effect, because ingress really is the package. You need the controller implementing the load balancer as well as the API components. Ingress controllers come from the Kubernetes ecosystem. That means that they are provided by the open source community, and it means that different solutions exist. Like the Nginx ingress controller. For your convenience, I have included URLs to all of these controllers. The HA proxy controller, the traffic controller, the Kong controller, the contour controller. And if ever you are going to set up ingress in a real cluster, you need to pick your ingress controller. In my video course Certified Kubernetes Administrator, I will show you how to work with the traffic controller. In this course, we are going to work with the Minikube ingress controller. Once again, we see the benefit of working with Minikube, as many features that are otherwise kind of complicated are easily integrated in the Minikube environment. You'll see how to do that in the next video. Let's configure the Minikube ingress controller. First, a few words about it. So there are specific instructions to use ingress in a full Kubernetes cluster. It really depends on the ingress controller that you are going to use, so I can't say anything generic about using ingress in a Kubernetes cluster. I can say something about Minikube. Minikube provides easy ingress access using a Minikube add-on. And hey, let me just ensure you, don't worry that you have to configure an ingress controller on the cKAD exam, because that is clearly a CKA level task. You won't see it on cKAD. In order to work with ingress on Minikube, you simply use the Minikube add-on enable ingress command, and that will enable it. And without it, there won't be any working ingress. Let me show you. So here we are on the Minikube machine, and I'm starting with Minikube add-ons list, which is showing all these different add-ons. And the add-on that we are going to use here is ingress. So it's pretty simple. Minikube add-ons enable ingress. And that is going to enable the ingress controller. I'll tell you more about controllers later in this video course, because controllers really are a thing in Kubernetes, and it makes sense understanding what they are all about. But what you can see is that some images are being used, and these images are a part of the ingress controller in Minikube. So we need to wait for a little bit, and then we can verify that it really is running. So now we can see that the ingress add-on is enabled. So to verify, let's do a kubectl get ns, which will show us namespaces. And in the namespaces, we can see that the new namespace has just been added, the ingress nginx namespace. And if you use kubectl get all -n ingress nginx, there we can see everything that has been done. So we have a service ingress controller and an ingress controller admission giving access to the deployment, and through the deployment we get access to the different ingress pods. So you can see admission has been started as a job. This is just something we're running in the background. What it really is all about is this nginx ingress controller. This is what is implementing ingress in our Minikube clustered environment. Sometimes the best way to learn things is by doing it, so let's do ingress.
So I'm going to run a demo for you. This demo continues on the demo in lesson 8.4. So make sure you have created services as instructed in lesson 8.4 and then run what is on this slide and what's on the next slide. And I'm going to demonstrate it for you right now. So let me start with kubectl get deploy. Just verifying that everything is up and running, and we can see we have nginx svc. And kubectl get svc on nginx svc is showing that the nginx svc is available. It's node port and it's exposed on node port 32,000. So let's use curl to connect to that specific port. And verify that it is indeed working. As you can see, it's working. We are getting welcome to nginx. Now I'm going to use ingress using kubectl create ingress. That's actually the easiest way to work with ingress. So if you use kubectl create ingress, then you see all the different options that you've got. Now, what does it look like? Well, it looks like you specify a rule, and this rule is writing to a specific destination. I'm not going into too much detail right now, but for the exam, it is useful to remember that kubectl create ingress -h is providing some good usage information. So I am using kubectl create ingress nginx svc-ingress. Rule equals, and there we are going to specify the rules. So first rule is slash equals nginx svc:80. So what is that? That's a rule that is defining that if in ingress traffic hits slash, which is the root of the ingress, then it will be forwarded to the nginx svc port 80, in which nginx svc is the nginx service. And through the nginx service, obviously, it will find the related pods. I'm adding another rule. There says rule equals hello is new dep 8080. That is kind of interesting. This is perfectly possible to define a rule that points to a service that doesn't exist yet. Because yet again, we will have the kube controller manager that is continuously going to scan if anything changes in the configuration. If a change occurs, it will automatically update the ingress. So let's do a kubectl describe on the ingress nginx svc ingress. And we can see right now, well, it's all about the paths that are available. We can see that the path nginx svc is using the pod endpoints, and we can see that new dep, oh no, endpoint new dep not found. I know, we are going to take care of that. Before continuing, we need to make sure that in etc host we provide resolving for the Minikube IP. So what was it again? 49.2. So sudo vim on etc hosts. And let's add this line. And we are adding this to resolve to nginx svc.info, because that is what we've got in the ingress, right? So this is the DNS replacement basically, and this DNS replacement is going to redirect incoming requests to the Minikube, and on the Minikube, well, we access the cluster, and the ingress is taking care of all the further traffic. Now we should use kubectl get ingress and verify that we see an address. And as you can see, the address, it's not very shocking. The address is localhost, but localhost, that is okay for now. Let's continue and let's use curl on nginx svc.info. And what do we get? Yay, we get a welcome to nginx. So ingress is working. Ingress is working for the root directory, which is addressed by default when we get nginx svc.info. But we created a second rule.
And the second rule is where we have a path /hello, and this path /hello is forwarding to new dep port 8080. So what is this new dep port 8080? Well, that's what we are going to take care of right now. So kubectl create deployment new dep -- image is gcr.io/Google samples hello app 2.0. This is just a simple, just another hello world kind of application. And we need to expose that application. So kubectl expose deployment new dep -- port is 8080. And now, without changing anything to ingress, it should be all right, and I should be able to use curl on nginx svc.info /hello. And there we can see hello world. It is working. And this is how you configure ingress. So you have just set up a basic ingress. Let's go a little bit more advanced and talk about ingress rules. So how does it work? Well, each ingress rules contains a couple of components. It starts with an optional host. If no host is specified, the rule applies to all inbound HTTP traffic. Then there is a list of paths, like /testpath or the /, which we have seen in the previous demo. Each path has its own backend, and paths can be exposed as a POSIX regular expression as well. Last, there is the backend, and the backend consists of either a service or a resource. Normally that would be a service. And it's common to configure a default backend in an ingress controller for incoming traffic that doesn't match a specific path. Now, how about these backends? Well, a service backend relates to a Kubernetes service. The resource backend can be used to refer to cloud-based object storage, where ingress is used to provide access to the storage resources. Because storage resources in cloud can also be exposed through a URL. You can have a look at ingress resource.yaml in the course Git repo for an example of what that looks like. Resource backends and service backends are mutually exclusive. So either you do it for services or you do it for resources. And let me be clear about it. In cKAD, service backend is what you should focus on. Resource backend is not in cKAD. You can also use a default backend, and the default backend is what you set to handle traffic that doesn't deal with any specific backend. Then there's a couple of path types, and the path type needs to be specified while you are working with ingress. It defines how to deal with path requests. There is exact path type, which indicates that an exact match should occur. That means that if the path is set to /foo and the request is /foo/, there is no match. There's also the prefix path type, which indicates that the requested path should start with. So if the path is set to /, any requested path will match. And if the path is set to /foo, then either /foo as well as /foo/ will match. So if you want to go for some additional flexibility, you better use the prefix path type. Next, we need to talk about ingress types. So there is ingress that is backed by a single service, in which there is one rule that defines access to one backend service. That's the simplest example. So in order to create such a scenario, you would use a command like kubectl create ingress single -- rule is file service :80. Which creates an ingress with the name single, which makes sure that if single /files is used, file service :80 is addressed. There's simple fanout. Simple fanout is where there are two or more rules defining different paths to refer to the different services. So in that case, it would look like kubectl create ingress single -- rule is files and -- rule is db. That means that depending on the path that is addressed, the traffic will be redirected to a specific service. And last, there is name-based virtual hosting. In name-based virtual hosting, there are two or more rules that route requests based on the host header. If you want this to work, you need to make sure there's a DNS entry for each host header. And it looks like kubectl create ingress multi-host. There's rule equals, and here it comes, my.example.com/files equals file service, and my.example.org/data equals data service. Let's go explore how these ingress types and rules are all coming together in a little bit more advanced example. For your convenience, here are the steps that I'm going to run. Let's go check it out. So let's start by creating two simple deployments. kubectl create deploy Mars. Dash image is nginx. And kubectl create deploy Saturn. Dash image is httpd. We want to have some differences, right? Not that it matters, but hey, why not? Then we need services. So kubectl expose deploy Mars dash port is 80, as well as kubectl expose deploy Saturn dash port is 80. Let's also make sure that DNS is working. Well, etc host in our case. And in order to work with the etc host, we need to send the traffic to the load balancer on the Minikube IP address 49.2. So I'm using sudo with my favorite editor on etc host. Hey everybody, if you have a hard time using Vim, use Nano instead. That's okay. This is not a class about Linux editors. This class is about Kubernetes. So what do we need to include? Well, we need to make sure, and I know it's not really required, but I like having separate lines. We need to make sure that mars.example.com, as well as, there's a typo, let me fix it, saturn.example.com, both resolve to the Minikube IP address. There we go. Now we can create the ingress. So what would that look like? Well, that would look like kubectl create ingress multi-host dash rule is mars.example.com /equals mars:80. So anything going to mars.example.com will be redirected to Mars. Dash rule is saturn.example.com /equals Saturn. Notice that I'm not specifying any path type. Ingress will take care of that automatically for me. So there we go, and we can see that the ingress has been created. But I want to check it. So kubectl edit ingress multi-host is what we are going to do now. And I want to check on the path type. And oh dear, path type is set to exact. I don't like exact because it increases chances of things not working out the way you want it to. So we are changing that to prefix. Is there anything else that is interesting? Well, I think everything else is straightforward, right? The status load balancer ingress hostname localhost, that's an important one. This is referring to the localhost host balancer that we are going to use. And now we can test. So curl to saturn.example.com is giving us what? That's giving us it works. And that is, by the way, the default web page in the HTTPD image. And curl on mars.example.com is giving us welcome to nginx. Hey, in the end, it turns out to be useful that we have used nginx as well as HTTPD anyway. So this is how you can use ingress with virtual hosting. Isn't it cool? In this short lesson, I want to tell you about ingress class. So what is ingress class? Well, ingress class is a relatively new resource. It was introduced in Kubernetes 1.22, which is only 2 versions ago at the moment we were recording this. And you can use it to set a specific ingress controller as a cluster default. And that makes working with ingress a lot easier. Each ingress resource, if there is an ingress class, should specify a class. and this class refers to the cluster default ingress class. The reason I wanted you to know about this is that by the time you are using this, you will probably see that ingress resources that have a class specification have become more common. So now you know about it. That's all. In this video, we are going to practice ingress troubleshooting a little bit. So I am supposed to be able to use this nginx svc.info. So curl nginx svc.info. And oh, I am getting service temporarily not available. So what can we do about it? Well, let's investigate. The message by itself is interesting. We have 503, and we can see that this is coming from nginx. That suggests that ingress is correctly running. So if we use kubectl get ingress, then you can see that nginx svc ingress is resolving any host to the IP address 192.168.49.2, which is a Minikube IP address. Let's investigate it a little bit more using kubectl describe ingress on this nginx svc ingress. And what do we see? Well, we don't see anything alarming right here. So you can see the path that resolves to nginx svc :80. Also, it is worth checking etc hosts where nginx svc.info, which is just any host name, resolves to the Minikube IP address. So I am curling to nginx svc.info. Minikube receives it. Minikube is running an ingress controller because I have seen this nginx message. We can verify that. kubectl get ns is showing that we have an ingress namespace, and kubectl get all -n ingress nginx is showing that we have an ingress controller that is running, and we can see it right here. It is exposed on the port 80, so everything should be all right. Now, what are we going to do next? Well, ingress is part of a chain for accessing your pod, and the next level in that chain is your service. So what did we see again? Well, we have seen that this is using the nginx svc service. So let's do a kubectl describe on nginx on service nginx svc the service. And what do we see? We see we have no endpoints. Hey, if the service has no endpoints, then it doesn't connect to anything. And how does that happen? Well, if a service has no endpoints, you should investigate the labels and the selectors. Selector app is nginx with an uppercase N. That can't be right. So kubectl get pods -- show labels is showing what? It's showing that definitely my pods have the selector label with the lowercase n. So I think we found it. kubectl edit svc nginx nginx svc. Let's look up this selector label. Let's change the selector label. There we go. Is this immediately going to run? Well, kubectl get endpoints is a nice way of troubleshooting. We can see that nginx svc at this point has backends. So at this point, we can try to run the curl command again. And curl is giving welcome to nginx. So that's how you can troubleshoot ingress. Basically, the checklist is, do we have a controller? Do we have name resolving setup? And are we using the right selector label at the service level? And that is going to help you get out of any ingress trouble. So let's explore storage. At the lowest level, we have the container. The container is where it's all starting, right? So if you look at the container from a Docker perspective, what is a container doing? Well, if you run a container, it runs a read-writable layer on the host that runs a container. And if you remove the container, the read-writable layer will be removed, and then it's gone. So if you look at the Docker level again, or at the container level, I should say, at the container level, you can add a volume. And this volume makes it a little bit more persistent. The purpose of the volume is to make sure that you have permanent storage. And in order to do so, at the container level, you can do a bind mount or point to NFS. And if you are using a fancy container solution, you can even point to external storage solutions. But these volumes that do exist at the container level in Kubernetes are a part of the pod. And that already makes it a lot better. So if you have a pod and in your pod you have a volume, you can use the volume to point to any type of storage. And if you compare that to the Docker solution, in Docker you can only use NFS or local storage. In Kubernetes you can use any type of storage. So it can be cloud storage like Azure or AWS. It can be Fiber Channel or iSCSI. It can be Ceph. It can be, well, any type of storage. So you could configure your pods with locally configured volumes. And there is nothing wrong with it, unless you're an application developer. If you are an application developer, you want to distribute a manifest file. And in your manifest file, you want your manifest file to work at your customer site. As many customers as possible. So you are not going to point any site-specific information in your manifest file. That is where the PVC comes in. So what is the PVC? The PVC is the persistent volume claim. So you are not going to point to a specific type of storage in the pod manifest. You are going to point your volume to the PVC. And this PVC is just a request for either read-writable or read-only storage and a specific amount of storage. And next, you leave it up to the administrator of the site where you are deploying the manifest file to create a persistent volume. And this persistent volume is a separate API resource that allows the site administrator to connect to any type of storage. So the site administrator knows what storage is requested on a specific site, and they will make sure that the persistent storage exists. And then at the moment that the pod as well as the PVC are deployed, the PVC will get a status of bound to any local site available storage. Now, there is only one thing that is not very cloud friendly in this environment, and that is that you need an administrator to create persistent volume. As if it would be a Linux admin creating LVM devices. That is not what you want. And that is why storage class can be used as well. Storage class is about site-specific storage. The thing is, no matter which site you are using, any site, if it's a local cluster or an AWS cluster or an Azure cluster, all of these sites have their own specific storage. And storage class is automatically provisioning the storage for you. So what does it mean? Well, it means that if the PVC comes in and the PVC requests access to a specific persistent volume and the specific persistent volume is not there, well, it can request storage class, and storage class will create a persistent volume on demand. And that is so cool because that means that you don't need a local site admin anymore. The only thing that you do need is site-specific storage being allocated by a provisioner. So storage provisioners need to be available. And you will notice that sometimes finding the right storage provisioner, that might be challenging, and there might be some missing provisioners at this moment yet. But this is the generic picture of how storage in Kubernetes is working.
All right, let me summarize what you have just seen in the drawing. So about storage options, files that are stored in a container will only live as long as the container itself. That's what we call ephemeral storage. The first level to do something about that is the pod volume. Pod volumes can be used to allocate storage that outlives the container and stays available during the pod lifetime. It's a property of the pod. Pod volumes can directly bind to a specific storage type. So if you have NFS at your site, you can create a pod volume pointing to NFS, and that will work. Pod volumes can also use persistent volume claims, or PVC,
to decouple the pod from the requested site-specific storage. And by using PVC in your pod specification, you make the pod specification more portable. Because the PVC doesn't say anything about site-specific storage. The PVC only says something about the required storage. So that's the size and whether it's read-write or read-only storage. Now the PVC goes out to the persistent volume. The persistent volume is a separate API object which defines external storage that is available in a specific cluster. So it would be up to the site administrator to make sure that persistent volumes for a specific site are available. A wide range of persistent volume types is available, and persistent volume claims are used to connect to the persistent volumes. And when a PVC is created, it will search for an available PV that matches the storage request. And if a perfect match does not exist, storage class can automatically allocate it. And in this scenario, the pod uses the PVC storage type and is completely decoupled from the site-specific storage. And that is how you want it to be in a DevOps environment, because that allows you as a developer to create generic pod manifest files, distribute your generic pod manifest files, and leave it up to the site administrator which specific storage it is binding to. In this video we will explore pod volume storage. So how does it work? To configure pod local volumes, the volume is defined in the pod specification. There's a separate entry for the volumes. And the volume points to a specific volume type. You will notice, by the way, that these volume types are also available to create as a persistent volume, which we'll talk about later. For testing purposes, empty-dir and host path are very common. Where empty-dir is a temporary directory that will dynamically be created on the host that runs the pod, and host path is a persistent directory that is defined and will outlive the lifetime of the pod. So host path is a little bit better than empty-dir. Also, a wide range of other storage types is available. That includes cloud storage as well as local storage, nearly everything that you can imagine. Then in the pod, the volume is mounted through pod.spec.containers.volumeMounts. So in the container you mount the volume, and that makes that everything is inside the pod specification to allow you to access site-specific storage. But be aware that this is a scenario that doesn't give you any portable storage. The storage type is in the pod specification, and that means that you really depend on what kind of storage is used at a specific site. Let me show you how this works. So to start with, let's have a look at kubectl explain for all these different volumes that are available in the pod specification. So here we go. You can see it includes cloud storage like AWS storage and Azure Disk and Azure File. There is Ceph storage. Ceph storage, that's the object storage that you will find in OpenStack and in Red Hat environments, likewise for Cinder. There are other types of storage. I'm not going to tell you about all of them. Empty-dir, that's the important one which we are going to use in this demo. FC is for Fiber Channel. Then we have GCE, which is Google storage. Git repo, which allows you to go directly to a Git repository. Hostpath, that's the other important one. Because for testing purposes. For testing purposes, hostpath creates a directory on the host that runs your pod. But at the same time, that makes that your pod is bound to a specific host. And if your pod moves to another host, well, it can't connect to the same storage anymore. So there's a risk involved here. We have iSCSI and NFS, and well, there is many more storage types, as you can see. There is storage for most of the environments that you may ever imagine. So I created a YAML file, morevolumes.yaml, and in morevolumes.yaml, you can see how this local storage is used. So this YAML file reads best if we start at the end. So that's volumes, names, test, empty-dir. Empty-dir, that's the temporary directory that will not outlive the pod lifetime. So the empty-dir name is set to test, and it's up to the host that runs your pod to create this empty directory. Next we can see that there are volume mounts. We have two different containers. There's a volume mount of this test thing for the first container on the mount path CentOS 1, for the second container on the mount path CentOS 2. So that makes that you have two containers and both containers are going to access the same storage. So what are these containers doing? Well, they are running a CentOS 7 image. And they do that with a sleep command so that we can test what is going on. And let's go check out what is going on. So I'm using kubectl create -f on more volumes.yaml. And now I can use kubectl and get pods more vol to verify that this thing is actually working. You can see it's still in a status of container creating. May take a little bit until the CentOS images have downloaded. In the meantime, let me do a kubectl describe pods more vol and pipe that through less so that we can investigate. So what do we see? We see that there are containers. Here is container CentOS 1, and container CentOS 1 has a mount, and this mount is on CentOS 1 from test, read write. This test, that will be the volume. We scroll down a little bit, there's another mount, and this mount is on the directory CentOS 2 from test. And here we can see the volume. So the volume is the type empty there, and the rest of its properties are not set. So that means that we can actually use this volume right now. And in order to test, I'm going to show you kubectl exec -it more vol -c CentOS 1 -- touch /CentOS 1 /test. In this command, kubectl exec runs a command inside the pod. The pod name is more vol, but we need to be specific in the container. So the container is CentOS 1. That's because this is a multi-container pod. If you don't specify the name of the container, then it would prompt us for us. And touch CentOS 1 is just creating the file. Oops, small typo, should be more vol 2. Right, and now that we have created the file on the empty.dir volume, even if it's a volume that is defined inside the pod, it's a shared volume. So from CentOS 2, we should be able to see the file. And there we go, this is a file we just created. So this is how pod local storage is working. Pod local storage can be useful, but do remember, the big disadvantage is that pod local storage is not portable. It depends on specific storage that is available on a specific site. Also remember, in this demo we have used empty.dir. Empty.dir is not something that you are going to use in production. But for cKAD, we like empty.dir and hostpath because it avoids us to dive into storage specifics and set up specific storage environments. That would go way beyond what you need to know for cKAD. We have just seen how you can create volumes locally in the pod specification. That's not how you want to do it. In a real cloud environment, for real flexibility and decoupling, you want to use persistent volumes. So let's talk about persistent volumes. A persistent volume, or PV, is an independent resource that connects to external storage. Independent resource means that it runs separately apart from any pod in your Kubernetes environment. So the PV can point to all of the storage types. It's basically the same storage types as what you see in the pod volumes. Apart from empty.dir, because persistent volume, well, it's persistent, and empty.dir by nature is not. To use a persistent volume, you use a persistent volume claim. The persistent volume claim connects to it, and next the pod is going to use the persistent volume claim. We'll investigate later how exactly that works. When you run a persistent volume claim, this talks to the available backend storage provider, and that dynamically uses volumes that are available of the specific storage type that is requested. We'll talk about that in more detail in the next video. So the PVC will bind to a PV according to the availability of the requested volume, access modes, and capacity. Let me demonstrate how this works. So let's have a look at pv.yaml. pv.yaml is a simple example that creates a persistent volume. So we see it has a name, it has a capacity, it has an access mode, and it has a host path. So the capacity defines how much storage is available. The access mode is a choice between read-write once, read-write many, and read-only. So read-write once means that one pod at the same time can have a read-write access. And the host path, that's a path that will be created on the host, and this path is set to my data. So if we run it using kubectl create -f pv.yaml, then we can use kubectl get pv to verify its creation. And now if we use kubectl describe pv volume, then we see what exactly it is doing. So we can see the different properties, including the source which points to the host path. And this host path is a directory with the name my data. So a host path, that means that it is created on the host. Minikube SSH brings us to the host. And if we do an ls / what do we see? We see that it is not created yet. Is that surprising? No, that is just because it hasn't been used yet. At the moment that you start using it, you will see that this host path is created. I'll show you that in an upcoming demo. So we have just explored persistent volumes. Persistent volumes go together with persistent volume claims. Let's talk about persistent volume claims. So the persistent volume claim, or PVC, requests access to the persistent volume according to specific properties. These are the access mode, which, as we have seen on the PV, can be set to once, read, write, many, and read only. And apart from that, the availability of resources. That relates to the amount of storage that is defined in the persistent volume, as well as the persistent volume claim. To use the storage requested by a PVC, the pod volume type specification can use the name of the PVC. So that is inside the pod. If you are using a pod, the pod connects to the PVC connects to the PV. And the result is a bind. So after connecting to a PV, the PVC will show as bound. A PVC bind is exclusive, and that means that after successfully binding to a PV, the PV cannot be used by any other PVC anymore. Even if there's a terrible mismatch. I mean, let's say you have a 100 gigabyte persistent volume. You have a PVC that requests 1 gigabyte. And if it's the only thing that can happen, then the PVC 1 gigabyte will bind to the 100 gigabyte persistent volume. And nobody else can use the remaining 99 gigabytes. So it's important to be efficient here. Now, if a perfect match is not available, storage class may kick in and dynamically create a PV that does exactly match the request. Storage class is an optional resource. You won't have it in all of the clusters that are available. We'll talk about storage class later. But first, let me demonstrate how you can create persistent volume claims and how they behave. Alright, for this demo I have created pvc.yaml. And what do we see in pvc.yaml? Well, the interesting thing is that you can see that the PVC does not connect to a specific PV at all. So the only thing that we see in the specification is an access mode, which is set to read write once. And it's a resource request, and this resource request is for 1 gigabyte of storage. So if we create it, kubectl create -f pvc.yaml. Now what is going to happen? Well, kubectl get pvc is showing us that we have a name pv claim and the status is bound. And then the surprising part, we have a pvc whatever volume. Hey, what is going on? Well, if you use kubectl get pv, then you can see that the pv volume is still available and a new persistent volume has been created. That is because of storage class. We are using Minikube. In Minikube there is a storage class, and the thing is that our persistent volume claim was requesting 1 gigabyte and we had a 2 gigabyte persistent volume. That would be a waste, and that is why the persistent volume has been created by storage class, and our PV volume is still going unused. Now, if you want to know what's going on, kubectl describe PVC on PV claim will tell you. And here you can see the details. So it is bound. You can see it has a storage class standard, more about that later. You can see the capacity, the access mode, and even the used by. Used by is going to be interesting once there is a pod using this persistent volume claim, because here you can see that a pod is actually using it. Likewise, you can use kubectl get PV and then kubectl describe of PV, PVC, followed by this large ID that has automatically been generated. And there you can see the persistent volume that has been created with the matching properties, with the source, the type host path, and the path TMP host path provider default PV claim. That is storage class kicking in, and I will tell you later in this lesson how exactly that works. For now, we have a persistent volume claim. The persistent volume claim is bound, so we are ready to continue. In this drawing, I want to visualize what is involved in connecting a pod to a PVC to a PV. So let's start with the PV. In the PV, there's a couple of parameters that is defined. There is the access mode. And this access mode is set to read-write or read-only or whatever. There is a size as well, which will be set to 2 gigabytes or whatever. And there's a type. Now, the interesting thing about the type is that the type is nobody cares. Because when a pod is requesting access to the storage specific type, that's up to the local site. Who cares about it? Now, then there is the PVC, the persistent volume claim. And in the persistent volume claim, we are going to request what? Well, persistent volume claim is going to check for a specific access mode and a specific size. And as long as the access mode and the size are available and are matching with a specific persistent volume, then you will get a bound relation, and you can actually use your specific storage. And then there is the pod, and the pod eventually is going to use the storage. So what is the pod doing? Well, the pod is defining the type, and the type is PVC. And this pod is going to be referring to the name of the PVC, and that will be my PVC. So a pod always has a one-to-one relation with a specific persistent volume claim. And that is why pods and PVCs normally are distributed together. Next, the pod will define a mount. And the mount, well, that is where this specific PVC will be mounted on some mount path. So if you see the name right here, this name refers to the name that you find right here in the volume definition. It will be mounted on here, and by this name you get to the PVC, and the PVC is just using access mode and size to connect to a specific PV, and that's how it works. So let me summarize using PVCs for pod. The purpose of configuring a pod with PVC storage is to decouple site-specific information from the generic pod specification. That is very developer-oriented. You want separation of duties, where the site administrator is taking care of the storage and the developer is just developing a pod as well as a PVC. So if you develop software, you would hand out a pod manifest and a PVC manifest, which can be used by any user and which will match the locally available storage on a specific site. In order to do that, the pod volume specification is set to persistent volume claim, and it's up to the persistent volume claim to find available persistent volume storage. So in the pod volume itself, The purpose is that you are not specific about the storage that you are going to use. That's why you use PVC as the type. And when a pod specification is distributed with a PVC specification, it will always bind to available site-specific storage without knowing anything about the site-specific storage. And that's exactly how you want it to be. Here you can see the steps in the demo that I'm going to perform for you right now. So to start with, I have this PVC pod.yaml. What do we see? We see it defines a persistent volume claim. Really, because this is how you want to distribute it. The pod and the persistent volume claim go together. So the persistent volume claim name is nginx PVC, and it has a read-write many access mode and 2 GB of storage. Then we can see the pod specification. In the pod specification, the volume is defined. The name of the volume, this is an internal name for the pod. It doesn't point to the PVC at all. The site storage. And the persistent volume claim, this is the storage type that it is using. So this comes in the place of NFS or Azure Disk or whatever kind of storage you are going to use. And the claim name is nginx PVC. And next we have this volume mount. And the volume mount is mounting site storage, which is this volume. On the mount pad, users share nginx HTML. And that is how they all come together. Right, let's run it. kubectl create -f on pvc pod.yaml. And let's do a kubectl get pvc as well as pv. So what do we see? We see this nginx pvc persistent volume claim with a status of bound, and it is bound to persistent volume that apparently has been generated dynamically. So that's a 7EB7, and in the 7EB7 right here we can see what it is doing. And in case you are wondering why did it generate it dynamically, well, the persistent volume claim is RWX, and we did not have any RWX storage, so storage class has kicked in again and has created this RWX storage for us. Now it's interesting to investigate kubectl describe pv pvc 7EB etc. Where we can see the path that is created. And this path, well, that is what I want to show you, because we are going to use kubectl exec on nginx pvc pod --touch user share nginx HTML test file. We create a file, okay? And then I'm using minikube SSH to connect to the minikube. And on the minikube I'm using ls-l on tmp host path provisioner default nginx pvc. And look, the test file ended up right here in the minikube directory. So that is how the persistent volume in the end is providing access, in this case, to a host path. But that can be any type of storage. That's up to the persistent volume, and that was not the purpose of what we wanted to demonstrate here. The goal and the thing that you should really understand is that by working with pods and persistent volume claims, you have true decoupling, and that's what you want in a Kubernetes environment. In this video we are going to explore storage class. So what is storage class? Well, the thing is that cluster environments typically have their own specific storage type. That means that on beforehand you know what type of storage needs to be used. Kubernetes storage class allows for automatic provisioning of persistent volumes when a persistent volume claim request for storage comes in. So if you have storage class in place, you don't have to create persistent volumes on beforehand. Again, so if you have storage class, you don't have to create persistent volumes on beforehand. It will happen automatically. In order to use storage class, you need a storage provisioner in the backend. This storage provisioner is taking care of actually creating the volume on the storage that is available. And Kubernetes comes with some internal provisioners, and alternatively, external provisioners can be installed using operators as well. And using these provisioners really makes the mechanism very flexible. So if no support for specific storage is provided, go have a look and see if a provisioner is available and use that provisioner so that you can provide the storage anyway. Typical lab environment storage is not backed by a provisioner, but the good news is that Minikube by default does come with a provisioner, which you don't even have to enable. Another use of storage class is as a selector. And that makes really think of labels and selectors that we have seen between deployments and pods and between services and pods. So normally PVC's binding to a PV is based on best match. While using storage class in PV as well as a PVC, the PVC will only bind to a PV with the same storage class setting available. And if such a PV is not available, the PVC will stay in a status of pending forever until it becomes available. In this slide, you can see the demo that I'm going to walk you through so that we can understand how storage class can be used as a selector label. So let me demonstrate the working of storage class. To start with, we will have a look at the pvc.yaml configuration file, where you can see that this is a very simple config file that is going to create a persistent volume claim with the name pv claim. So if I'm using kubectl create -f pvc.yaml and next kubectl get pvc, then we can see that this PV claim is created, and the PV claim is bound, and it is bound to an automatically created volume with the name PVC. So if we use kubectl get PV, then what do we see? We see all these different PVs that exist, including the PV that was created right here. So the big question is, where does this specific persistent volume come from? Well, that is what storage class is all about. So if I use kubectl get storage class, then we can see that there is a storage class with the name standard with the provisioner kubernetes.io minikube hostpath. This, by the way, is one of the things to be liked about Minikube. Minikube has a lot of functionality included that makes working with Minikube a lot easier. Like this storage class, which otherwise you would only have in SAN environments. Now, if we would use kubectl get pvc again, and we are going to investigate these persistent volumes, let's do that. We can use kubectl describe pv on the pvc whatever persistent volume. There we go. Oops, missing a p in the name. And there you can see that this is the source. The source is hostpath. The path is TMP hostpath provisioner. And this TMP hostpath provisioner is coming from the storage class standard. That's a storage class that we have just seen. So this is how you can automate the creation of storage and automatically bind your PVC to a specific storage class. But it's also something that you can manage if you want to. If you have a look at pvc pod.yaml, then what do we see? Then we see that there's a YAML file in which a persistent volume claim, and a pod are created. Now, in the persistent volume, we have storage class name set to manual. Here in the PV claim, we have storage class set to manual. There is no storage class with the name manual, and as there is no storage class with the name manual, it's used as a selector label here. So if we are going to run this YAML file using kubectl create -f on pvc pod.yaml, and next we use kubectl get pvc to see what is going on, now we can see that the local PV claim that we have just created is bound to the volume local PV volume. And you can also see the storage class is set to manual. Now why is that? Because that is exactly what we have done in this specific YAML file. And of course we can see that from the PV perspective as well, where is it? Right here we have this local PV volume that is bound, and the storage class name is set to manual. And that is how you can manually manipulate how Persistent volume claims as well as persistent volumes are bound together. In this lesson, we are going to talk about how to provide variables to Kubernetes applications, something quite important. So Kubernetes does not offer a command line option to provide variables while running a deployment with kubectl create deploy. It's kind of funny and a little bit inconsistent because you will find such an option if you create a pod using kubectl run. But if you want to provide a variable, then a procedure is where you are first going to create your deployment using kubectl create deploy mydb -- images mariadb, for instance. And then you are going to use kubectl set env deploy mydb mysql root password is password. Kubectl set env is how you set an environment variable on a running deployment. Of course, as an alternative, you are also free to work with YAML files, but you need to manually generate the YAML file. And kubectl set env with the dry run is not obvious to do on a resource that does not yet exist. So probably this is the easiest way to set variables on your deployments. So I just told you, if you are running a pod, you can easily provide environment variables, but you shouldn't run naked pods. If you want to do it anyway, this is how you do it. Kubectl run mydb -- images mysql -- env equals mysql root password is password. That would work perfectly, but the purpose here is to work on deployments. Here we have the demo that I'm going to walk you through. Let me just show you, and let me show you how we can work with variables on Kubernetes resources. So I'm starting with kubectl create deploy mydb -- image is mariadb. Well, deployment created. Kubectl get all is showing me what? Showing me status of container creating. Let's check if we can already do a kubectl describe pods mariadb. Oh, that would be mydb. And we can see it's still in the status of image putting. Okay, we need to wait for a little bit. And what do we see? We see an error. So what is going on? Well, we have an error and we need to figure out what exactly is happening. So in order to figure that out, kubectl describe on pods mydb is going to tell us what's going on. Back of restarting failed container. And if we scroll up a little bit, this is what we want to be looking at. We can see the state is terminated, reads an error, exit code 1. Last state terminated, reads an error, exit code 1. Exit code 1 means that the main application really was not happy. So we need to investigate. And how do we do that? By using kubectl logs on mydb whatever. Which is telling us database is uninitialized and password option is not specified. You need to specify one of mariadb, root password, etc. So how are we going to do that? Well, you can of course use kubectl set env deploy mydb mysql root password is password. And if we do that, kubectl get all is doing what? Well, it's doing a rolling update, and we can see it's already in the status of container creating. And if we check on that a little bit later, we can see that it is running, and that is okay. And if you want to capture this in a YAML file, then you can use kubectl get deploy mydb -o YAML. Redirect that to mydb.yaml. There we go. And now we have mydb.yaml. And we need to clean that up a little bit, because in the YAML file that is created from a running application, you will see automatically assigned stuff. We don't need in the metadata the annotation, the creation timestamp, the generation. So let's delete these 4 lines. Also, we don't need resource version and UUID. We can keep many of the stuff that is in the specification. It's very specific, but it doesn't hurt. We also don't need all the status information. So let's delete all of that. And now we have a pretty decent YAML file. And this pretty decent YAML file can be used. But hey, does that also work with dry run? Let's investigate the dry run option. So kubectl, create, deploy, new DB. I'm looking for a different name here. -- image is MariaDB. -- replicas is 3. -- dry run is client. -o YAML greater than mydb.yaml. And now I'm going to use kubectl set env deploy new DB. My SQL root password is password -- dry run is client -o YAML, and I append that to mydb.yaml. Yeah, there it is going wrong, because that is telling us the deployment app's new DB was not found. That's what I was just trying to mention. You can run anything with a dry run, but really if you do that, you need to make sure that you meet with the dependency relations. Let's see if we can fix that. kubectl create -f on mydb.yaml. Now it is created. And now we do the kubectl set env. And what exactly does that end up with? Well, that ends up with a deployment and, oh, another deployment. That is kind of interesting. And in this other deployment, we have the password that is being set. Do notice that this is running on an already running deployment. So if you want to do this, you need to clean it up like we've just done. And for that reason, you are probably better off, if you really want to generate a YAML file, to work with the already running deployment that has the environment variable. So do that manually, then use kubectl get deploy -o YAML, redirect to a YAML file, clean that up. That's a lot easier than trying to do it on beforehand. In this lesson, I want to tell you about decoupling, and I need you to understand why decoupling is important in a cloud-native computing environment. So it's a good idea to separate site-specific information from code, because that makes your code more portable. Code should be static to make it portable so that you can easily use it in other environments. Variables, on the other end, are site-specific, and for that reason, they should not be provided in the deployment configuration or anywhere else in the application. Because if you provide site-specific information inside your application, it's not portable anymore. In order to deal with this issue, Kubernetes provides ConfigMaps. So a config map is used to store site-specific information like variables, but also like local configuration files. So the idea is that you are going to create a config map, and the deployment just points to the config map. And while using config maps, site-specific information is included in a config map, which allows you to keep deployment manifest files generic. So if you would be an application vendor developing applications, you would provide a YAML file for the deployment or even a command, and you would tell your users that they need to provide their site specifics inside a config map. And that is how you can easily bring it together. Let me visualize that for you. So I would like to visualize this decoupling that config map is providing. We have a pod, because it's still the pod that is running your application. And of course, you can provide configuration files statically in the pod, but that would make it of limited use. But the thing in the pod is where else can you store this configuration? Well, the thing is that we are in cloud-native computing. So here is our big cloud. And in cloud-native computing, you cannot create any specific relation to the servers, because the servers are somewhere down here and nobody really cares about the servers. So you need to store the configuration in the cloud. And that's exactly what ConfigMap is doing. So ConfigMap is a resource. And in this resource, you are going to be able to provide variables and configuration files. And a config map internally in Kubernetes is stored in the etcd. And the etcd, as you know, is a database. You don't work directly with the etcd in many cases, but you just should know that anything that is a part of this cloud-native computing configuration is inside the etcd. So what is your pod going to do? Your pod is going to use a setting like env from to get its environment from. From what? From ConfigMap. And by using this environment from ConfigMap, you have decoupled configuration. Your site-specific information is in the config map, and you create a config map for any specific site. So you can have one application, multiple config maps to apply a strict separation of the static code and the dynamic site-specific information. And that is how decoupling in a cloud-native environment is working. All right, now that we know why you want to use a config map, let's try to understand config map. Config maps are used to provide different types of configuration to an application. 3 types to be precise. You can use them for variables, you can use them for configuration files, and you can also use them for command line arguments. Variables and configuration files are very common use of the config map. Command line arguments is not so very common. You should know that according to these 3 types of configurations, config maps are created, and they will be created in a very different way. That is really very important. So also on the exam, when there is an assignment, create a config map, you should really ask yourself, what type of config map do they want me to create? Is it for variables, for config files, or for something else? And then you follow the procedure that applies to that specific type. I will walk you through the procedures in the next couple of videos. So if an application requires a config map, then the config map should exist in the cluster before running the application. That's also important. In some cases, if an application requires something, the application will just show a status of pending until the something is available. That's not the case in the config map. If the application refers to a config map, it will just generate a failure if the config map is not present. So make sure to create your config map before the application. In the next video, we are going to explore how to use variables with config maps. In this video, I would like to explain how to use variables in config maps. So while creating a config map with kubectl create CM, variables can be provided in 2 different ways. You can use the from env file option. So that will be kubectl create CM, from env file is dbvars. In that case, the contents of dbvars is parsed, and you are supposed to define variables there in key equals value format. Also, you might want to use the from literal option. For instance, you use kubectl create VM, from literal is MySQL user equals Anna. That would also work. It's a little bit more straightforward. And you should know that you can use the from literal option as many times as you want. So you want to use it 10 times? That's okay. Notice that that is something that you can do from literal. You cannot use multiple from environment files. After creating the config map, you can use kubectl setenv to update your application. So use kubectl setenv from is config map /mycm deploy /myapp to use the config map in your deployment. If you do that on the exam, as the syntax is slightly confusing, I would advise you use kubectl setenv -h for the help overview to reduce the risk of making any typos. You can also use the dry run is client and command line redirection on kubectl create deploy and kubectl setenv to generate a YAML file using the config map. If you are going to do that, you should make sure that you create the deployment before you actually use kubectl setenv, because you cannot use kubectl setenv if the deployment doesn't exist. All right, here is the demo. Let me walk you through it. So the first thing that I'm going to need is a vars file. And in my vars file, I'm going to use MySQL root password is password, and MySQL user is Anna, or whoever you want to create. Next, I'm using kubectl create CM. Before we do, just a quick -h, just to show you how convenient the examples are. I mean, if you understand the procedure, you don't remember the syntax, you'll definitely be able to do it based on these examples. So kubectl create CM, db vars. If you create a config map, config maps are always connected to a specific application. I would advise you use kind of a reference to the name of the application in the config map. So db vars, or even better, mydb vars, because I'm going to create the mydb application. So I'm creating the config map using -- from env file is vars file. There we go. So now I need to create the deployment using kubectl create deploy mydb -- image is mariadb -- replicas is 3. As we have just seen, it's so sad, but there is no way to provide the config map immediately to the deployment while running it. So if I use kubectl get all -- selector app is mydb, we will see a failing deployment. That's okay, we are going to fix it, and we are going to fix it right now using kubectl setenv deploy mydb -- from is configmap / db vars. Notice, by the way, that the way I'm typing the command is slightly different from what you see in the help. What you see right here, the resource / resource name, that's the old Kubernetes notation. So this is old Kubernetes notation. And here, deploy space mydb, that's a new notation. It's okay to mix that. Kubernetes will understand. And it's not okay to use the wrong name. So mydb vars, that will do it in a much better way. Now we need to check and see the rolling update, and we see the rolling update in progress and already a status of container creating, and at this point already 2 containers running. And if you want to capture all of this in a YAML file, well, kubectl get deploy mydb -o YAML, pipe that through less, and you will see right here, this is the part, let me highlight it. This is the part that specifies how to use these variables. And of course you can manually type that in your YAML code, but you can see it's quite complicated. And for that reason, I would advise you don't do it this way, but you use kubectl set. kubectl setenv will automatically put it in there, and that's a lot easier. In this video, we are going to explore how to use config maps for configuration files. So configuration files are typically used to provide site-specific information to applications. And for that reason, you also don't want to have your configuration files inside the application. Again, config map is a solution to store these files in cloud. You can easily use kubectl create cm myconf -- from equals file equals name of the file to create the config map that contains your configuration file. Now, if a config map is created from a directory, all files in that directory are included in a config map. So that's also kind of useful if you have multiple configuration files to include. And to use the configuration file in the application, the config map must be mounted in the application. And that is what you need to pay attention to. We have seen that the approach for environment variables is to set them as environment variables. And if you use a config map for configuration files, it almost behaves like a volume. Well, it behaves like a volume because you mount it as if it were a volume, and even you can find the config map as a volume type. Unfortunately, there is no easy imperative way to mount config maps in applications. So how do we mount a config map in an application? Well, you probably generate the base YAML code and add the config map mount to it later. That's probably the easiest way to get it inside. I still hope that kubectl set will be changed so that you can use kubectl set volume to easily set a volume and mount the volume in a running application. It's not rocket science. Red Hat OpenShift is already doing it, but as of Kubernetes 1.23, this functionality unfortunately is not in Kubernetes yet, if it will be ever. So in the application manifest, you still need to define a volume using the ConfigMap type, and you mount the volume on a specific directory. And the configuration file will appear inside that directory. Here is a demo that I'm going to run for you. Let's also see if the documentation can help us a little bit with mounting these config maps as files. So to the documentation first. And in the documentation, if you look for config map, then you can find configure a pod to use the config maps. Looking good enough, okay? So there you can see create config maps from directories. That is kind of okay. And create config maps from files. That's also kind of okay. This is what we are going to do. So this is explaining what you can do to create a config map from a file, and then it's explaining what the output is looking like and what the YAML code is looking like. And then it continues a little bit, and it continues with creating config maps from literal values. Honestly, I think this is a little bit confusing that they are first telling you how to create the config map based on whatever, and then they tell you how to define container environment variables using config map data. No, this is not what we need. And this is still about the environment variables. And this is still about the environment variables. But fortunately here we can see something, add config map data to a volume. We're getting close, and this is what we need. So here you can see the pod specification. In the pod we have a container. The container is a volume mount of config volume, and config volume is right here. And config volume only has config map and the name of the config map. So if you keep that in mind, then hopefully you will be able to figure it out on the exam. The reason I'm walking you through it is that config maps really is a topic that you should have contemplated before going to the exam. If you have never really seen this, this documentation page, then you are going to waste so much time on it during the exam, because the different uses of the config map are not very clearly distinguished and separated in this documentation page. All right, with that in mind, let's run the demo. I'm starting with echo hello world, redirect that to index HTML. Then kubectl create cm my index dash dash from file is index HTML. That creates a config map. So now I can use kubectl describe cm my index. And what do we see? We see there is index HTML as the data section, and in index HTML we have hello world. So that is how config maps really store the values in a readable way. It is really the cloud native alternative to a configuration file, where on plain Linux you would read the config file from a directory, and here you read it from the config map. All right, next we are going to use kubectl create deploy my web dash dash image is nginx. So kubectl get deploy dash dash selector app is my web should show us that's just a deployment. We should have a look at get all. So here we have the deployment, my web successfully up and running. There's no reason why it shouldn't do that, because the config map in this case is optional. This web server, this Nginx web server, has a default page to show you, even if no specific configuration is available. But now we are going to change that. And the good thing is that you can use kubectl edit to do that. It's the most direct way of doing it.
So instead of redirecting the output to a YAML file and working on the YAML file, I'm just going to change it on the running deployment using kubectl edit on the deployment. So what do we need? Well, everything that we need is in spec template spec, which is also known as the pod specification. And I am going to use the volume first. So volumes, and this is the part where you can really rely upon what you find in the documentation. Based on the documentation, as long as you know the name of your config map and where you want to mount it, then you should be okay. So we have the volumes, which is a list key. So name cmvol, that's for internal use. And then config map and name my index. So that makes sure that the config map is available. Now that we have the config map available, we need to mount it in the container spec. So here are my containers, and I am putting it directly after the DNS policy. Location doesn't really matter. What does matter is the indentation. And as long as you know that volume mounts is a direct property of the container, then you should be good. So the mount path is going to be user share nginx HTML, and the name is set to cmvol. So now we can get out of the editor and, oh no, volume mounts, that is an unknown field. Volume mounts an unknown field. Did I make a typo? Well, we can see that. So we have containers, volume mounts, and mount path and name. So what is going wrong here? Let's get back here. Deployment spec, template spec, unknown field, volume mounts. Aha, you see what is going wrong. Unknown field volume mounts. I made a mistake. Because right now the volume mounts is a part of the spec. It's not a part of the containers. So let's delete these 3 lines and let's put them back, but this time in the container. I admit I did it by accident, but I'm happy that we see it, because right here you can see how incredibly important it is to do the appropriate indentation. So here you can see that the volume mount is at the right location. So let's get out of there, and we can see deployment has been edited. You can also see the rolling update in place right now. That shouldn't take too long. Pod is already running. It's a good idea before we move out to do a kubectl describe on the pod, my web, to investigate that everything really happened the way we want it to. So volume cmvol, yes, we can see the config map, and the name is my index, and the mount user share nginx HTML from cmvol, that is looking okay as well. So if I use kubectl exec on this volume, my web, and I do cat of user share nginx HTML index.html, then we can see hello world, which is really proof that the file ended up in the right location. So that is how you use a config map to provide access to a file. The next thing we are going to talk about is the secret. A secret is in fact a special kind of config map, which adds encoding. So what is it all about? Well, secrets were created for storage of sensitive data. Think of password, authentication tokens, TLS key material, SSH keys, stuff like that. And using secrets makes that you don't have to store this information in a clear text readable format, and that reduces the risk of accidental exposure. Some secrets are automatically created by the system as well. So it's an important part of the Kubernetes system itself. And users can also create secrets. The system-created secrets that are provided by Kubernetes are important for Kubernetes to connect resources to other cluster resources. We will later discuss service accounts, and you will see how these system-created secrets are important for the service accounts.
But do keep in mind that secrets are not encrypted, they are base64 encoded. Now, when working with secrets, it's also important to realize that there are different secret types, 3 of them in total. First, there is Docker registry. Docker registry is used for connecting to a Docker registry. So if you want to log in to any container registry that needs you to authenticate, use a Docker registry secret type, even if the registry is not directly Docker. There's TLS, which you can use to store TLS key material, and there is generic. And generic is basically the encoded equivalent to the config map. You use it for encoded local files, directories, or literal values. When defining the secret, the type must be specified. Using kubectl create secret followed by the secret type. Don't forget that, because otherwise you will get error messages and Kubernetes doesn't know what you want to do. In the next video, you are going to see how you can apply these secrets to Kubernetes. Before we are going to create our own secrets in the next couple of lessons, in this video I would like to explain how Kubernetes is using secrets internally, because secrets are very important for the functioning of Kubernetes. So how does that work? Well, to access the Kubernetes API, all Kubernetes resources need access to TLS keys, because at every single level TLS keys provide authorization between the different Kubernetes components, between your pods and the backend services, but also they allow you to work in a Kubernetes environment. These keys themselves are provided by secrets, and they are used through service accounts. We'll talk about service accounts in the next lesson. By using the service account, the application is capable of accessing its secret. So here we have a quick demo that I'm going to walk you through, which will demonstrate how service account and secret and TLS key material are all related to each other. No worries about the service account. You will find much more information about the service account in lesson 12. So let's start with kubectl get pods -n kube system. So in kube system we have core DNS pod. So let's investigate this this core DNS pod and look at the YAML format that it's using. So what do we find? Well, right here we find the service account. So there's a service account, and the service account has the name core DNS. So what is this core DNS service account? It's basically a user account that comes with credentials that allow core DNS to fetch the information that it needs to fetch from the Kubernetes cluster. You can probably imagine that core DNS needs some elevated privileges, and that is why core DNS has a dedicated service account. Now, if we are going to further investigate, we can use kubectl get SA. SA is short for service account, and we do that on kube system core DNS -o YAML again. And if we do that, what do we see? We see that this core DNS service account has a secret, the core DNS token GQBLC. So if we want to know what's going on, then we use kubectl get secret -n kube system core DNS token and so on. Let's do that in YAML as well. And there we can see the contents of the secret. So we have the CRT, we have the namespace, and we have the token. And in case you are wondering, what kind of namespace is that? Well, we can easily figure out. Let me copy that, and let me use Linux base64 -d. We need an echo, and the encoded namespace needs to be pasted before. So echo, and there we go. Oh, that is kube system. So this also proves that the secret provides access to the TLS key material that core DNS needs. But we also see that secrets are just encoded. So if you get your hands on the YAML code of the secret, all you need to do is base64 -d. But hey, don't panic, because normally people don't get easily access to the YAML code of the secret. In a real secured Kubernetes environment, not everybody is not working as kube admin, which we are doing here. I mean, we never logged in or anything. So this is not representative of a real secure Kubernetes environment. In secure Kubernetes, access to the secrets is behind administrator login. And these secrets are stored in the etcd, and you need Linux root privileges to get access to the etcd. So it looks pretty bad from a security perspective. It's not that bad, and it's organized pretty well. In this video, I want to explain how to configure applications to use secrets. So there are different use cases for using secrets in applications. And that's the first thing that you need to keep in mind, because if you don't, it will be so confusing. If you want to provide TLS keys to the application, you use kubectl create secret TLS, followed by the name of the secret, followed by --cert equals and --key equals. If you want to provide security to passwords, then it looks very much like a config map. So kubectl create secret generic. Notice that you need a generic secret type, followed by --from literal equals key equals value. And if you want to provide access to an SSH private key, then you would use kubectl create secret generic as well. My SSH key from file is SSH private key, followed by the name of the private key. Then there is also the Docker registry secret. We will separately talk about the Docker registry secret in the next video. It's also possible to use a secret to provide access to sensitive files. And the nice thing is that if it's a sensitive file within the application, it will be mounted with root access only. So you would use kubectl create secret generic again. With the -- from file is my secret file option. Alright, as a secret is basically an encoded config map. It is used in a way similar to using config maps in applications. So if you know how to use a config map, you know how to use a secret, at least a secret of the generic type. So if it contains variables, you can use kubectl set env. And if it contains files, you need to mount the secret using the manual procedure that we have seen while talking about the config map. While you are mounting the secret in a pod spec, consider using default mode to set the permission mode to default mode 0400. Because while performing a mount, you can specify permissions on your mount as well. And this is how you do it. Also notice that mounted secrets are automatically updated in the application when the secret is updated. And that is pretty important, but that is because secrets can also be used for TLS key material and stuff like that. Alright, here we have the demo. Let me walk you through this demo. So I'm starting with kubectl create secret generic. And just once more, -h, because I need you to be aware that for every single secret type that you are ever going to work with, there is excellent documentation if you use kubectl -h. Right, we are going to create a generic dbpw -- from literal is MySQL root password is password. Or you know what? Let's do it slightly different. Just root password is password. Then kubectl describe secret dbpw, and in the describe we can only see root password 8 bytes. But if we are using kubectl get secret dbpw -o YAML, then we get this. So what is this? This is the base 64 encoded string. So if I echo this string to base 64 -d, then you can see the clear text value. I wanted to repeat this and show you again because really it is something that you need to be aware of. Okay, now I'm going to use kubectl create deploy my new DB -- image is MariaDB. Just for your information, As in these demos, I'm using the same names all the time. Every now and then I'm using kubectl, delete all, minus all to avoid name conflicts and also to avoid resource saturation. We don't have to check it this time. The MariaDB deployment is going to fail. While it is failing, I am going to show you kubectl setenv -help pipe less, because there is something that I wanted to show you. There we go. This is basically what we are going to do. So we are going to use kubectl setenv to set the environment from the deployment, but we are also going to use a prefix. Prefix equals mysql underscore. You remember I created the secret with a root password instead of mysql root password. And now I'm going to mount it with the prefix, -- prefix mysql underscore. Now, in case you are wondering, why are we doing that? Well, if you do it that way, you can use the secret potentially for more than just one application. Maybe you have other applications that need a root password as well. And then you just do a root password. And if in WordPress you have WordPress root password and in MariaDB you have MySQL root password, you use this prefix to make sure that you get the right information into the application. So kubectl setenv deploy my new DB -- is secret dbpw -- prefix is mysql underscore. There we go. kubectl get all is showing me what? Is showing me container creating, rolling update in process. And is it already there? Yeah, it is already there. Now, next, I would like to show you kubectl exec on my new DB -- env. So I want to print the environment. I want to print the environment to show you two things. To show you first that the prefix has worked. So we see MySQL root password instead of root password, but also to show you that inside the pod, it's a clear text value. Because this is a variable, and this variable inside the pod needs to be a clear text value. So the secrets are protecting these values while they are stored in cloud somewhere, but once they have been used in their final destination, they are not encrypted anymore. So secrets also are not encrypted files. They are just plain readable files. Just be aware of that, and then you know the possibilities, but also the limitations of working with secrets. In this video, I would like to talk about the special use case of secrets, and that is the configuration of the Docker registry access secret. So let's talk about registry access. The thing is that to get access to container registries, additional authentication may be required. In the past, registry access often was free and anonymous. Nowadays, you will see that basically all the registries require some way of authentication, especially if you want to get to the good features. For Docker, for instance, if you go for anonymous, there's a pull rate limitation, and you might encounter pull rate limitation errors. If ever you face a pull rate limitation error, then what you need to do is you need to configure your Kubernetes with your Docker credentials. And once you have done that, you get access according to your Docker credentials. Talking about which, I would advise at least to create a free Docker account, because just in exchange for letting Docker know a little bit more about you, they double the pull rate limitation, and that might just be enough for you. There's also a free Docker Professional account. It's about $70 a year, and it's giving access to even more features. Go explore that, do whatever you want, but at least make sure you have the free account and configure the registry access secret. So why do we need a secret? Well, on a standalone container node, the credentials will be stored in a local config file. That doesn't work in Cloud Native. In Cloud Native, you need to make sure that the information is decoupled from the nodes and stored in the cloud. And that is what the Docker registry secret is for. It's a special secret, tailor-made to store authentication credentials in a secret. So here is a slide. On the slide you can see I'm using these different parameters. Notice the use of the Docker server. On the slide we have my registry colon 5000. The my registry colon 5000 is showing you how you can access any registry. So this would be for a private registry requiring authentication. If you want to use a real Docker server, then you would probably use something like docker.io. Let me show you. So I am going to use kubectl create secret docker registry -h. -h again because it allows you to check out a couple of values. So what do we see? Well, here we see the example. And this example is using uppercases, and these uppercases are a replacement of the real values that you want to use. Because using sensitive values in clear text on the command line is not the best possible thing to do. Also in the examples you can see that you can generate a Docker registry secret from an existing .docker configuration file. If ever you use Docker login, Docker login is writing config.json to the .docker directory containing your credentials. And you can import these credentials as well, and that works perfectly. Now I'm going to use kubectl create secret Docker registry, my Docker credentials, -- Docker username is Docker username. Of course, I'm not going to type my Docker credentials, so I created some variables on beforehand, containing the credentials that I'm using right here, so that at least I don't have sensitive values in my history. So -- Docker password is Docker password, and -- Docker email is Docker email, and then -- Docker server is docker.io, something like that, and that will create the Docker credentials. So kubectl get secrets is showing us what? Is showing the secret my Docker credentials, and kubectl describe secret my Docker credentials is showing all of this and nothing really readable in there. It's referring to a .docker config.json. So what is in kubectl get secret Docker credentials, my Docker credentials -o YAML? Well, we can see the Docker config.json, and this Docker config.json, well, that probably is some sensitive values. So if you don't mind, I'm not going to run that through base64 decoding. So in this video, I'm going to explain the role of the Kubernetes API and what you can do with it. So the API defines which resources exist and how to use these resources. Every time we have used kubectl explain, we really went into the API definition to explore how specific resources can be used. Kubernetes uses a core API, and this core API is extensible. That's also what you will see if you are working with other Kubernetes distributions, that other Kubernetes distributions might have a completely different set of APIs. These different APIs are added in API groups, and this flexibility is used in custom resource definition, or CRD, to add resources to Kubernetes. You'll learn about CRD in the next lesson. Some Kubernetes distributions have added many CRDs to make working with Kubernetes easier. Also, there's this thing called operators. If you are working with operators, CRDs are typically involved, and also operators for that reason are doing API extensions. So extending the API in Kubernetes is quite common. If you want to see an overview of the API and the API resources, use kubectl API resources. Let me show you this. So kubectl API resources, showing all the different API resources. We are using vanilla Kubernetes. Vanilla Kubernetes means Kubernetes straight from the sources as published by the CNCF, and not some specific distribution. If you are in a distribution, then you will get extensions to the API. Now the first column to look at is the API version, because in the API version you will see the different API groups. The core Kubernetes API group is has the version v1. It doesn't have a name, it's just v1. The first extension was apps v1, some additional applications that have been added. And apart from that, you can see different API versions. And here we can see for each of these API groups which specific resources they are adding. You can also see the difference between namespace, true and false. Some resources are namespaced, which means that they are visible within a namespace only. Some resources which have a more generic purpose are non-namespaced, like persistent volume, for instance. If you create a persistent volume, it's visible from all namespaces. Right, we can see that different API extensions have been added. That has happened in the past. That will happen if you install additional software, and it will also continue to happen in the future. Look here, for instance, crdprojectcalico.org. What is that? Well, CRD stands for Custom Resource Definition. So when we switched Minikube to use the Calico network agent, the Calico Custom Resource Definition was added. Also interesting, sometimes you have different versions of the API at the same time. Like here in policy, we have a policy v1 beta 1 and a policy v1. That is Kubernetes in transition. At a certain point in time, you may have the newer version already available, and the old version is still provided for your convenience. Now I bet if you are using this functionality and you are addressing the v1 beta 1 functionality, I bet that the deprecation message will show and tell you that this will soon be removed. So this is what the API resources looks like in vanilla Kubernetes. Try it on a Kubernetes distribution and you will see that it's quite different, but you will also see that always the same core is available. If you want to get more information out of the API, you can consult the API documentation, which is on the link that you can find on the slide. Notice that this link doesn't work with latest, so you need to change the v1.22 to match the latest version. Each API group can have its own version number, and if you want to have an overview of that, have a look at this specific link. We have already seen how you can use kubectl API resources for information about resource types. Also convenient is kubectl API version for resource and version information. Let me show you some commands that relate to versions. So to start with, I want to show you kubectl version, which is showing me that we are on Git version 1.22.3. So in not too much time, we will have the new release of 1.23. How about kubectl API version? Kubectl API version, that is with an S, will show you the different versions in just a short list. You can extract this information from kubectl API resources as well, but this is just a convenient overview of the different versions that are available. Alright, Kubernetes not only defines the API. If you work with Kubernetes, you access the API to get your resource information from the API. The core Kubernetes functionality is exposed by the kube API server. This is a core Kubernetes process that runs as a pod in the kube system namespace. Kube API server is typically started as a systemd process or as something else. It's such an important part of Kubernetes. And Kube API server allows TLS certificate-based access only. I already told you TLS certificates are very important in a Kubernetes environment, and everything needs to be secure. Kube API server makes sure that that is happening. If you are using kubectl, there's no issue because kubectl makes secured API requests by default. Now let's talk about kubeproxy, because I'm going to show you how to use curl. Curl doesn't make secure requests by default, and that's where kubeproxy comes in. So Kubernetes APIs by nature are RESTful, and that means that they can be accessed using direct HTTP traffic. Curl is the perfect utility to do so. You use it for direct API access, which is needed when kubectl is not available. And you might wonder, when is kubectl not available? Well, for instance, if you are trying to get information out of the API from inside a pod, because pods sometimes need to get information out of the API, but they definitely don't have kubectl installed. Fun fact behind the scenes, kubectl uses curl as well. If you use a command like kubectl --v is 10 get pods, you will see the underlying API request. The thing about this Kubernetes proxy is that it helps you to make curl requests secure. So when you are using curl talks to kubeproxy, and kubeproxy makes a secure request to the kube API server. Let me make a quick drawing to visualize what exactly that looks like. So let me visualize the working of kubeproxy. In fact, it's really easy to understand. This is your Kubernetes controller host. And on this Kubernetes controller host, we have the kube API server. And this API server is secured. And in order to secure, we have TLS certificates. So the normal situation is where you are going to use your kubectl. And kubectl is pointing to your kubeconfig. And this kubeconfig is a configuration that is stored in .kube/config. And guess what we have in .kube/config? We have TLS. And because you are using kubectl, well, TLS talking to TLS, kubectl and the API server is secured with TLS certificates automatically. Now, what is going to happen if you want to use curl? Well, if you want to use curl, curl by default doesn't know about your certificates. And that is why kubeproxy is coming in. So kubeproxy is something that you are running locally on your workstation, not on the remote server. Locally on your workstation, such that it can get this TLS information from your .kubeconfig. And that means that really you are going to use curl to talk to kubeproxy, which is a local connection. And then kubeproxy is taking care of the TLS secured connection to the API server. And that is how kubeproxy is working. And that is also why you are running kubeproxy locally on your administrator workstation. And you don't care too much about kubeproxy on the Kubernetes cluster nodes. All right, now I would like to talk about connecting to the API. If you want to access the API using curl, you need to start the kubeproxy on the Kubernetes user workstation. So this is something that you do on the machine where normally you are using kubectl. It does require your kubectl client to be installed and full functionality. So kubectl proxy -- port is 8001 with an ampersand. Don't forget the ampersand, because kubectl proxy by default runs in the foreground, which means that you can't do anything else on your console anymore, and that's not very convenient. Once you have done this, you can use curl HTTP on localhost 8001, and that will show all the available API paths and groups, providing access to all the exposed functions. But hey, that's not all. There is more to know about curl and API access. But before we wrap up this lesson, let me just do a quick demo so that you know how kubectl proxy and curl are working together. Alright, to start with, I want to show you kubectl --v is 10. That's the verbosity get pods. And what this is showing? This is showing in much detail what is happening. And you can even get the curl requests out of this information. So it's very verbose and giving nice insight into what you are doing. Don't use it too much because, hey, who wants to generate requests like this? Let me show you curl simplified. So kubectl proxy port is 8001. The port is kind of random. As long as the port is not used, then you're okay. And that is starting to serve. Press enter, because otherwise you don't get your console back. And now you can use curl on http://localhost 8001. And what is that giving us? Well, that is giving you the API index. And in the API index, you can see all the different resources that are provided. Look, here are the different API groups, and everything else that the API is providing is right here. In the next video, I'll tell you much more about how to use kubectl proxy and curl to get information out of the API. In the previous video, we have talked about the API and how to access it. In this video, I want to walk you through a brief demo about using curl to access API resources, so that you can get used to it. Alright, so you should start by running the kubectl proxy. I'm typing Linux command jobs, and this Linux command jobs is showing me that the proxy is already running on port 8001. It's still running from the previous demo, so I don't start it again. If you don't see anything running, start by typing kubectl proxy -- port equals something with an ampersand. Now I'm using kubectl create deploy curl nginx -- image is nginx -- replicas is 3. And now the new deployment is created. Good. Let's start by using curl on http://localhost 8001/version, which is showing me version information. This is not entirely the same as kubectl version, because kubectl version is kubectl oriented. This is Kubernetes oriented. It's the version information. And then I'm going to use curl on http://localhost 8001/API/v1/namespaces/defaults/pods. Before I'm pressing enter, what does this link look like? Well, we are addressing the API v1. v1 is the core API. In the core API namespaces, which is about namespaces, where we are going to look for the default namespace, and we want to get the pods out of the default namespace. And here you go, here are your pods. And of course, this is not readable, but this is how Kubernetes is storing it internally. So we can see right here that there is this name, for example, 8D6TT. Keep that in mind, please. So I'm going to use that name on default pods, and I am going to append the name of the pod that we just found, curl nginx whatever. And what is that doing? Well, that is giving me access to that pod only. So what's the difference? The difference is that right now I only see the information for curl nginx. In the previous command I saw all of these pods. Now the nice thing about it is that you can use the curl to get information out of the API. You can also use curl to delete information from the API. -x delete is what we are going to use. And this -x delete, well, if you use kubectl get all again, then we can see that the previously used pod is no longer available, and Kubernetes deems it necessary to be in a state of container creating. It just started a new pod because really we deleted. And in case you are wondering, hey, how come I did not authenticate? Well, you did not authenticate because we are on the kubectl workstation. And that means that you are using the same credentials as the credentials that you are using while running kubectl. And these are stored in this file. Let me do a cat on .kube/config. So this is the configuration, and this contains your credentials. And in case you are wondering, what exactly are the credentials? Well, the credentials are your certificates. The certificates allow you to do administrator tasks on your Kubernetes cluster. So let's talk a little bit about API deprecations. What is the thing? The thing is that there is a new Kubernetes version every 3 months. And with new Kubernetes releases, old API versions may get deprecated. It always happens, it will always happen, it has always happened. So live with it. Deprecation means that officially a deprecated feature will be supported for a minimum of 2 more Kubernetes releases. So let's just face it, if you are working the declarative way, you have YAML files all over, and a specific important feature gets deprecated, there's work for you to do, work in your YAML files, and you have 6 months to do it. So if you ever get a deprecation message on something that you have created yourself, you should immediately take action and not wait until it doesn't work anymore, because otherwise you'll be in trouble. Now let me run through a quick demo which is all about deprecation and what you can do in case features are deprecated. So in the cKAD Git repo, you will find redis deploy. Let's run redis deploy kubectl create -f redis deploy.yaml. And oh no, what do we get? We get unable to recognize redis deploy no matches for kind deployment in version apps v1 beta 1. So what is it telling me? It's telling me, hey dude, you are using an API version that I no longer support. So what are you going to do if that happens? Well, you are going to use kubectl API versions. And in kubectl API versions, you can see there's apps v1. v1 beta 1 is no longer available. You should pay special attention to those cases where you have 2 different versions of the API and you are still on the old version of the API. If that is happening, you might not immediately see the deprecation, but already that means that there is work to do. What do you think of this? There are even 3 versions of the API. Again, that means work to do. Now, if there is work to do, well, sometimes it is very easy. And you just go into the redis deploy.yaml and you change v1 beta 1 to v1. But that is not enough. I would advise you to carefully look at the output of kubectl explain -recursive deploy. Why is that? Well, that is because API version differences often mean that specific properties of your resources have changed as well. And you should carefully check and see if these properties that you are using are still available. kubectl explain recursive is giving an overview of all the different properties in a hierarchical way. You should check your code against it. Let's see if that is also necessary for our redis deploy. And apparently not. Let's go have a look at another example of deprecation. I need a pod. So I have a curl Nginx. Let's work on curl Nginx. So I am going to use kubectl exec -it on curl Nginx. Oops, I need to copy the pod names. kubectl get pods. And there we go. And now we can use kubectl exec -it on this specific pod. /bin/sh, something like that. This is what I wanted to show you. This is telling us that kubectl exec pod command is deprecated and will be removed in a future version, and you should use kubectl exec pod ---- command instead. This is one really confusing thing, because in Docker you don't separate the Docker run command from the commands that you are running inside the container with a --. In Kubernetes, they want you to use the --, which is good, by the way, because it makes it a lot easier to distinguish between what should be interpreted by kubectl and what should be running as a command inside the pod. You can see it's deprecated, but still you can see it is working. And that is what deprecation is all about. It's about giving you the time to adopt your procedures. In this video we are going to talk about authorization and authentication. So what is this all about? Well, it's about topics that are not really that important for cKAD because they are extensively covered in cKA as well as in CKS. But you need to know a minimum about it anyway. Authentication is about where Kubernetes users are coming from. By default, and that's a standard and it's not going to change at any point in cKAD, a local Kubernetes admin account is used and further authentication is not required. We have seen that you installed Minikube, you installed kubectl, and at no point you have ever provided a password to tell Kubernetes who you are. That is not the perfect solution, and for that reason, in more advanced setups, you can create your own user accounts. That's what we are going to do in cKA. The kubectl config is what is used in the background to specify to which cluster to authenticate. And you can use kubectl config view to see the current settings. And the config is read from the file .kube/config. Authorization is about what the authenticated users can do. Behind authorization, there is a system that is called Role-Based Access Control, or RBAC, which takes care of the different options. You can use kubectl auth canary, like kubectl auth can I get pods to find out what you can do given your current authentication status. So for advanced setup, you are definitely going to configure role-based access control. And we will see a little bit of role-based access control because without understanding role-based access control, I can't tell you what service accounts are all about. And service accounts are a topic in cKAD. So what is role-based access control? Role-based access control is used to provide users with access to API resources. And in RBAC, three different elements are used. There is the role, which is an API resource that defines permissions to specific resources in the cluster. There is the user or the service account, which is used as an entity in Kubernetes to work with the API. And there's a role binding. And the role binding connects a user or a service account to a specific role. You need all three of them. So let me show you just a little bit about current authorizations and what is going on. So first, I would like to show you kubectl config view. That is the current configuration. And in this current configuration, we have a definition of clusters, of contexts, and of users. So what do we see? We see the cluster being set right here with the certificate authority, and we see where the cluster is listening. And that is on the Minikube IP address with a specific port, which happens to be the API server port. Then there is the user. We should have a look at the user first. So in users, we have a user with the name Minikube. And this user is defined as a client certificate as well as a client key, which refer to client certificate and key that have been created in the user home directory. And this user is used in the context. So in the context, it is using the cluster Minikube, the namespace default, the user Minikube, and the name is Minikube. So this is where user and cluster are brought together in this specific context. We can also see that the current context is set to Minikube. And you want to keep it that way. I don't even care about telling you how to change the default namespace in your configuration, because that's dangerous. If you are going to do that on the exam, you might forget about changing it back, and that will bring you in big trouble because you will find out that all your resources have been created at the wrong location. I don't want that to happen, so let's not talk about it. What I do want to talk about is what is behind this config, and behind this config there is a file. Let me do a less on tilde.kube/config, which happens to be the name of the file. And if you think, hey, that looks very similar to what we have just seen with kubectl config view, that is right. Kubectl config view is just showing you the contents of this file. In cKA, you will learn more about this file. Not now. For now, I want to show you two more commands. commands that are really useful in case you ever need to troubleshoot what you are doing in the cluster related to authentication. So kubectl auth. Can I is what we want to do. Can I get pods? And it's saying yes. And you can do this can I also with the --s option. So can I get pods as bob@example.com? And no, for the simple reason that we don't have a Bob user. This is about all you need to know about authentication and authorization in cKAD. But hey, a little bit of insight is quite important anyway.
In this video, we'll talk about API access and service accounts. What is a service account? Well, a service account is a solution for the problem that all actions in a Kubernetes cluster need to be authenticated and authorized. Service accounts are used for basic authentication from within the Kubernetes cluster. You will need a service account if a pod, for instance, needs to get information about other pods that are running in the same cluster. Role-based access control, also referred to as RBAC, is used to connect a service account or SA to a specific role. So service accounts and role-based access control go together. No worries about role-based access control. You don't have to set up role-based access control on the cKAD exam, but you need to understand how it works and how it connects to a service account. Every pod by default uses a default service account to contact the API server. In every namespace, you have a service account with the name default, and this service account is used as a default by all of the pods. And it allows your pods to get information out of the API server, but not much else. You cannot even list pods with this default service account. Each service account uses a secret internally to automount API credentials. You may have noticed that in a pod description you will always see a mount of some secret. Well, that is a secret that is related to the service account. Before I'm going to demonstrate, let me make a drawing in which I'm going to show you how service accounts relate to role-based access control and authentication and authorization. So let me explain what this is all about. This is all about accessing the API server, because the API server is providing access to the heart of Kubernetes, which is the etcd. Now, we have seen how accessing this API server can work in two different ways. You can go through the .kube/config. That's a Kubernetes configuration in your home directory, and this is what allows the kubectl utility to access Kubernetes in a secured way. Now, as an alternative way to access the kube config, there is this kube proxy. And the kube proxy can be used by other utilities like curl. So that allows you to send a role HTTP requests to the API server. But how about applications within Kubernetes, like pods that need access to the API server? Well, they are already in the proper environment, so they don't have to go through the .kube config, and they need another mechanism, and this mechanism is the role. In the role, verbs are used to define what exactly is allowed. And in order to get access to the role, the service account is used, SA for service account. Now, the service account is not accessing the role directly, it is using a role binding. The role is an independent object. The service account is connected to the role binding, and that allows your Kubernetes pods or other applications running in Kubernetes to access information from the API. Let's continue and further explore how this works. All right, let's talk about service account secrets. So service accounts come with a secret, and this secret contains API credentials. By specifying the service account that is to be used by the pod, the service account secret is auto-mounted to provide API access credentials according to the service account RBAC connections. That's something that we will have a look at shortly. Now, let's first explore the default service accounts that I used. So let me use kubectl get pods -o YAML. might be a little bit too much. Let's just pick out one pod, the busybox pod. Minus o YAML, pipe less. And here on the bottom you can see service account and service account name default. Both are referring to the service account default. And that is this default service account that exists in all of the namespaces by default. In case you are wondering, why do we have service account and service account name? Well, one is the old way of referring to it. The other one is a new way of referring to it. There's no real difference. Let's do a kubectl get SA. It will get you the service account from the current namespace. And if we have a look at the contents of these service accounts, you can see that there's not so much going on in these service accounts. Now, if we use kubectl describe on the pod nginx again, then you can see that there's a mount. And this mount is var run secrets kubernetes io service account from kube API access whatever. This is how the service account is integrated in the pod. Now it's interesting to note that many more service accounts are available. If we use kubectl get SA minus uppercase A, then you can see that a lot of service accounts exist, in particular in the kube system environment. Because the kube system environment is where all your Kubernetes core components are running, and every single one of these core components needs a service account to allow it whatever it needs to be doing. This is giving you some insight into service account itself. In the next lesson, you will learn a little bit more about role-based access control. In this video, we are going to explore role-based access control. Do notice that you do not have to configure role-based access control yourself on the exam, but role-based access control plays such an important role in the service accounts that you need at least to understand what it is all about. And that's the focus of what we are doing here, understanding. So role-based access control is something that a cluster administrator can configure to specify what exactly can be accessed by users or service accounts. To do so, you can create custom service account and configure them with additional permissions for enhanced access from pods to cluster resources. That's the use case. You have an application that's running in your cluster that needs to get information about other applications running in the cluster. That is where you are going to set up non-default service accounts as well as RBAC. For additional permissions, these are permissions that you can create for yourself. You can use namespace or cluster scope roles as well as role bindings. Now the role or the cluster role, if it's for a cluster scope, defines access permissions to API resources. If it's a role in specific namespaces, if it's a cluster role in the entire cluster. And the role binding connects the service account to a specific role. Now, cluster role and cluster role bindings are used to configure access to cluster resources. Let me show you some roles and role bindings. All right, so in the cKAD directory that is coming from the course GitHub repository on github.com/Sander van Vught/cKAD, we have two example files. There is listpods.yaml. What is listpods.yaml? It's a very simple example of a role. So in the role, we can see that it has a name, listpods. It has a namespace. That is a namespace in which this role applies. The API groups, these are the API groups that the role applies to, where we have the double hyphen, which means any. Then we have resources, and the resources is about pods, and the verbs is about list. Notice that the resources lists all of the resources that this role is providing access to. In this case, we just have pods, but if you wanted to do pods and deployments and daemon sets, well, you just list them with a hyphen in front of every single resource. And the verbs is about the operations that you can use, like list, which allows you to list, or create, which allows you to create, and so on. Now, if you define this, and we can do that, kubectl create -f on list pods, then the role exists in the cluster. But the fact that the role exists in the cluster doesn't mean anything. You need to create a role binding. And what is this role binding? Well, let's have a look at list pods mysa binding.yaml. And what do we see here? We see the connection that's being made between the role and the subject. So the role ref identifies the role. That is the role list pods. That's a role that we've just seen. And the subject identifies the service account. And the service account is mysa. Hey, did we already create mysa? Well, I can do that in just a little moment. So if I'm using kubectl create -f on list pods mysa binding, then we need to check kubectl get sa if we have this mysa. Oh no, we don't. So kubectl create sa mysa. That will create a service account, and now we have all the components that are needed. The service account, the role, as well as the role binding. And that means that we can go on and use it now. In the next video, I'll show you a pretty advanced example of usage of these cluster roles. At this point, I would like to show you a video in which we are going to bring everything together. So we are going to configure a service account. This video is a little bit complex. No worries about it. You will not have to do something like this on the cKAD exam. But by understanding what is happening with these service accounts, you will be able to troubleshoot everything related to service account that you might see on the cKAD exam. So here we go. It starts with the management of service accounts. And every namespace has a default service account with a name called default. Additional service accounts can be created to provide additional access to resources. Theoretically, you could enhance the access privileges for this default service account, but that's really not a good idea. After creating this additional service account, it needs to get permissions through RBAC. That's a role-based access control consisting of the role and the role binding that we've just seen in the previous video. So the first step is to create additional service accounts. That is actually quite easy. Just use kubectl create service account mysa. The service account is a resource that doesn't have any significant properties. That is because the configuration of the service account is all about roles and role bindings. While creating a service account, a secret is automatically created to have the service account connect to the API. And this secret is mounted in pods using the service account, and it's used as an access token. We've already seen that as well. Again, using a service account by itself doesn't serve to anything. You must configure role-based access control afterwards. In the next demo, I'm going to show you how this works. For your convenience, I have written out the complete demo on the slide. The demo is on 2 slides. It's a bit of a complex demo, but just try to understand, as I mentioned before. So here we go. All right, I will start using a pod, defining a pod. In order to do so, I have mypod.yaml. Everything in this demo is YAML files. So you can see it's a pretty simple pod that is running Alpine, which restarts once an hour. So kubectl apply -f on mypod.yaml will create the pod. And if we use kubectl get pods mypod -o YAML, then we can see that this pod is running a service account. So where is it? Here, service account default and service account name default. Okay, now I would like to show you what we can do with this default service account. And in order to do so, we are going to enter the pod kubectl exec -it mypod --sh. That is opening a shell on the pod. And I would like to use curl to invoke some direct API access from the pod. Now, normally, of course, you wouldn't use curl, but normally your pod is trying to interact with other resources in the cluster. And that is the equivalent to what we are going to do here. But I am just going to use curl to simulate that. So let's do apk add -s update curl. APK is the package manager in Alpine. And we need to make sure that curl is installed. It's not installed by default. And now let me use curl https Kubernetes /API /v1 -- insecure. The -- insecure is identifying that we don't do any TLS certificates in curl. And what do we get? We get forbidden. User anonymous cannot get path API v1. In terms of service account, what is happening here? Well, in terms of service account, nobody knows who I am. I'm the anonymous user, and we need to change that. In order to change that, we are going to use the default service account token. So I'm going to set the variable. Token is $cat /run /secrets /kubernetes.io service account token. Now, echo token is showing the contents of this service account secret, and this is really the token that allows me to identify myself. In curl, we call that bearer authentication. That means the one who is carrying the token will get access. So curl -h authorization :bearer $token. That is really like, hey, I'm showing you my token. Can I have access now on https://kubernetes /API /v1 -- insecure. And now we can see contents of the API. What is this? This is just a list of all the different resources that are defined in the API. That is about as much as you can get based on this default service account. Let's try to do something more advanced and repeat this command to go to Kubernetes API v1. And now we go into namespaces /default /pods / insecure. What is this command doing? This command is trying to list all pods in the default namespace. And oh boy, what do I get? I get forbidden. Who is forbidden? Users system service account default. That's the default service account from the default namespace. Does not have permissions to list pods, and that is what is happening. That's how far you can get with this default service account. Okay, so I'm using exit. We don't need this anymore, and we are going to fix this. Before showing you the steps in the demo, here you have the slide listing all the steps that I'm going to run. I'm going to continue kubectl create SA my SA. Oh, it already exists. That's even better. We also need the roles and the role bindings. Well, we already created them in the previous video. So let's do a kubectl describe roles list pods. And what do we see? We see this is a role that allows the resource pods to be listed. And kubectl describe role binding list pods my SA binding. And what do we see? We see the configuration that we just created, where the role list pods is connected to the service account my SA. All right, now we need to use it. How are we going to do that? Well, we are going to do that in this case by creating a new pod. If the pod will be a part of deployment, you can even do it easier. You can use kubectl set SA to set a service account on a running application. That's also possible. Here, I have a naked pod, and naked pods don't do these dynamic updates. So I'm just using service account name mySA in mySA pod. The result is the same. The approach is just different. So kubectl create -f mySA pod.yaml. Here we go. And I'm going to exit this pod again. So kubectl exec -it mySA pod --sh. Again, we need to install curl. And we need to fetch the token. So token is, and this time we relate to a run secrets kubernetes.io service account /token, which is the location where this pod mounts the token of the current service account. So let me first use curl -h authorization bearer $token to https://kubernetes /API /v1 -- insecure. And there we get the list of resources in the API. That's nothing new. We already knew that. The change here should be in the fact if we go deeper. If we go to the API and we address Kubernetes API v1 namespaces /default /pods. So let's see if it works now. And oh no, it does not. And why doesn't it? Well, looks as if I made a typo. Do you see that? Defaults, that's not working. That should be default. And there we go. At this point, from the pod, I can list all of the other pods. So that means that the service account is working. And my pod now has authorization to list other pods. So that's cool. And this was maybe not too easy. Let's talk about how this relates to the exam. So what should you expect about service accounts on the exam? Well, on the exam, you need to know how to configure an application to use a specific service account. You will not have to configure any roles or role bindings. And for troubleshooting, check if additional service accounts are provided. So let me show you on the command line a little bit what you might expect on the exam. So on the exam, you might see an application throwing security errors. Maybe even in kubectl described, you will see security errors that refer to role-based access control or service accounts. What are you going to do then? Well, kubectl get SA, that is showing you if there are several service accounts. And I can tell you if there are more service accounts, then most likely you need to reconfigure your application to run this second service account. The easiest way, do it straight in a pod YAML code by including the service account name mySA and run your application again. You know how to export a running application to YAML, how to modify it, and how to create it again. Otherwise, you can also use kubectl set. Kubectl set has a service account option. And this kubectl set, oh boy, that's a lot of information. This kubectl set command allows you to do stuff like this. Kubectl set service account deployment, nginx deployment service account 1. So if it is a deployment on which you need to set the service account, it's even easier. This is what to expect on the exam. In this video, we will talk about the Helm package manager. So Helm is used to streamline installation and management of Kubernetes applications. Helm consists of the Helm tool, which needs to be installed, and a chart, which is really the package that you want to install. So in this Helm chart, you will find a couple of components, which are a description of the package and one or more templates containing Kubernetes manifest files. Charts can be stored locally, or you can access them from remote Helm repositories. Before you can work with Helm, you need to install it. Let me show you how to do that. So we need to fetch the latest version of the Helm binary. And that is coming from GitHub. Let's go there. So here we can find the different releases. And as you can see, 3.71 is the most current release. And we are going to use the AMD64 package. Helm binaries exist for different platforms. If you're on Linux, the most common platform is AMD64. So just click it, save it, and that will download it for you. There we go. And then you can extract it. This is a Linux tar archive, so tar xvf on Helm will do that for you. And it will create a subdirectory. In that subdirectory, there's the Helm binary. And we need to work on that Helm binary. So I am going to use sudo mv move is that for the Helm package to user local bin. In Linux, the convention is that everything that's not a part of the operating system and that can be used without root privileges should be in user local bin. In order to perform that operation, we need elevated privileges. And these elevated privileges is what we get using sudo. That doesn't go without entering the password. And here we go. And at this point, it should be possible to run Helm from the path. So if I use Helm version, then we get version information. As you can see, we are on 3.7.1. So that makes us ready to go. Let's talk about Helm charts a little bit before continuing. So Helm is all about using Helm charts. And in order to get access to Helm charts, you should go to artifacthub.io. Artifacthub.io is like a registry for Helm charts. And it's a good way for finding Helm repository names. So you can search for specific software here and run the commands to install that software straight from the Helm repositories. For instance, to run the Kubernetes dashboard, you could use Helm repo add Kubernetes dashboard followed by the exact link, https kubernetes github.io dashboard. And Helm install Kubernetes dashboard is what you can do next. So it's a two-step procedure. Step number 1 is where you are going to add the Helm repository. And after adding the Helm repository, you can safely install the software. Notice that in Minikube, if you want to install the Kubernetes dashboard in an easier way, you can also use Minikube add-ons enable dashboard for easier installation. The thing is that even if you are using the Helm chart, you will still need to do a little bit of additional work after configuring the dashboard. Let me demonstrate how to work with Helm repositories. So first I want to show you the Helm webpage, artifacthub.io. So in here you can search for the different packages and you can see there is a few thousands of packages available. So let's look for this dashboard. And if you search for the dashboard, we see many matches that contain the word dashboard. You can also conveniently browse different categories. For instance, if you want to do something with storage, then we do need to clean the search option. And select the category, and there you can find the different categories that are available. These categories really make it easy. For instance, regarding storage, if there is some storage that you would like to use, which is not available as a persistent volume in Kubernetes, you can have a look like here. So Helm is pretty cool, and I would advise you you check out what is going on. If you found something that is interesting, then you can find the further documentation of this thing in the artifacthub.io website. So this is providing all the details that you need to know about before continuing. So you should really spend some serious time on artifacthub.io to figure out what is possible. Now I would like to continue and show you how you can add a Helm repository. So that would be Helm repo add bitnami, https://charts.bitnami.com/bitnami, for instance. Bitnami is pretty well known in Kubernetes environments. Bitnami is making packages, especially packages that work well in Red Hat environments, like OpenShift and stuff. Now we can use Helm repo list. And Helm repo list is showing the repos that are available, including the Bitnami repo. Helm search repo Bitnami can also be used. And what is this command giving us? It's giving us a list of everything that is available in the Bitnami repository. And every now and then you will need to do a Helm repo update. to make sure that the latest information about your repository is locally available. Once you've done that, you are ready to start helming. And that is what we will cover in the next lesson. All right, now that we have Helm up and running and we know a little bit about Helm repositories, let's work with Helm charts. So Helm charts need to be installed. First thing to do after adding repositories is you use Helm repo update. That makes sure that you have a local cache of the most up-to-date information. After doing so, you can use the Helm install command to install the chart with default parameters. So we will talk about parameters and Helm charts a little bit later, but Helm chart is an easy way to get yourself started. Once you have installed at least one chart, you can use Helm list to list currently installed charts. And optionally, you can also use Helm delete if you want to remove currently installed charts. Let's go check this out. So let me start with Helm install Bitnami MySQL. Now with Helm, there's some templating involved, and we will explore that in more detail later. You can modify these templates before installing your Helm charts, and you can also use command line parameters like -- generate name, which will tell the chart to automatically generate a name for you. So here we see the result, and we can see that we have to be patient while the chart is being deployed. And it is telling me that we can watch the deployment status, and it is adding some services, and it's telling us some usage as well. So use the following to get administrative details. So that's really something that you want to do. You want to fetch the administrative details, and then you can connect to your database. So this is the usage information, and that's pretty cool. It's telling you how to get started with the specific Helm chart. So read all of it, and once you're happy with it, you are ready to get started with your application. I mainly want to show you what the Helm chart has been doing. So kubectl get all. And what do we see? We see that this Helm chart has created a stateful set. Now, what on earth is a stateful set? I will explain by the end of this lesson. For now, just consider it a little bit kind of a deployment but different. So we can see that the stateful set is creating a container, and it's doing a couple more things, like it adds a service as well. So at this point, the Helm chart has done its work, and it has installed a couple of resources. Now, if you want more details, then we can use Helm show chart Bitnami MySQL. Which is doing what? Well, which is giving information about the Helm chart and what it is doing. Also interesting is Helm show all Bitnami MySQL. Because in the result of the Helm show all command, we get more details about what exactly has been done. And this is really interesting because when you install a Helm chart, the Helm chart is making specific choices for you. It works with templates, and in these templates, it's doing specific settings for you. And you can work with these default settings, but hey, honestly, I wouldn't do it with the default settings. I would do it in the way that I'm going to explain shortly. But first, let's investigate what we see. Helm list. Helm list is giving me information about resources that have been created with Helm. And if we use Helm status on MySQL 136634503, then what do we get? Probably me making a typo. Oh, I can already see the typo, missing a 6. So here we can see the current status of the Helm chart. And in this current status of the Helm chart, you can scroll up a little bit. You can see the usage parameters. So make sure you know what the Helm chart has been doing before you are actually going to start the application. Now, amongst the things that are really powerful while working with Helm is the option to customize before installing. So a Helm chart consists of templates to which specific values are applied. And these values are stored in the values.yaml file, which is within the Helm chart. And the easiest way to modify these values is by first using Helm pull to fetch a local copy of the Helm chart. And next use your favorite editor on chart name values.yaml to change any of the values that you want to change. And honestly, I think that should be your default procedure while working with Helm, because who wants an application that is coming with values where you have no idea what exactly the values are that have been used? So let's see how we can customize before installing. I'm starting with Helm show values bitnami nginx, which is doing what? Showing all the different values in bitnami nginx, which would be used and which you can change as well. So you can see all of this comes with examples, but none of these examples have been set. That's not what we want. So let's go to a different directory and do a Helm pull bitnami nginx, which is doing what? Well, as you can see, it has fetched the nginx tgc file. So we need to extract tar xvf on nginx will do that for you. And now we can get into the nginx directory. It's interesting, by the way, to see the structure, but don't look at it too much because there's YAML code involved and there is chart-specific code. The most important part is where you get into the nginx directory and you have a look at the values.yaml. So what do we see in the values.yaml? We see all the settings that you can do. So name override, if you want to override the name. Cluster domain with the name of the cluster, and well, just scroll down and you will find all the different tunables that you can see. And as you can see, there's a lot of them. So you should really have a look at what you want to do. If, for example, you want 3 replicas, change the replica count, and you can see that really there are tunables for most of the parameters that you can set for your resources, like node selector and tolerations, and well, whatever you can imagine, even containing security context, for instance. So it's pretty rich. Now, if you want to see what is going to happen, you can also use the Helm template command. So Helm template --debug on nginx will do that for the nginx template. Notice that the template corresponds to a directory name. So if you are getting error messages that you should do this against a template, well, that basically means that you should do that in a location where the template is available as a subdirectory. So here you can check all the different values that are going to be used. And if these values are to your liking, then you just install. And if they are not, then you can tune the contents of the values.yaml in the template. So for now, I am going to use helm install -f nginx values.yaml my nginx /. So what is that going to do? This is going to run the Helm template to create a new my nginx chart. So this is giving me information about my nginx chart. We can see that a service resource has been created, and if once again I'm using kubectl get all, then you can see it's getting really busy, but my nginx has been created. And my nginx, well, we have some pods, and these pods are in a status of container creating, will be there in a while. This is a very brief introduction, but hopefully enough to get you started with Helm. Another feature that's a little bit related to Helm is customization, or customize. So what is customize? Well, customize is a Kubernetes feature that uses a file with the name customization.yaml to apply changes to a set of resources.
And that is convenient for applying changes to input files that the user does not control himself, and which contents may change because of new versions appearing in the Git. In fact, customization is another way to implement decoupling. You can use kubectl apply -k // in the directory with the customization.yaml and the file it refers to apply the changes. Or use kubectl delete -k in the same directory to delete all that was created by the customization. Now in customization you use this customization YAML file, and this is what it looks like. So it defines the resources, which is just a generic definition of the resources. Then we have name prefix. Name prefix test hyphen will create resources with that specific prefix. You can put them in a specific namespace. You can use common labels, and you can use so much more in customization. It's not my intention here to give you full explanation of all the features that customization is presenting. I just want you to know what it is whenever you come around, because you will sooner or later. Extremely cool is that you can use customization overlays. Now, when you are going to work with customization overlays, you can do things that come close to a CI/CD pipeline. So you can work with different deployment scenarios where every scenario is implemented as an overlay. For example, a dev, a staging, and a prod deployment scenario. If you are going to do that, then in the configuration, the main customization YAML defines a structure. So we have base, and in base you have deployment and service and customization. And then we have the overlays for dev, staging, and prod, each of which has its own customization. And in these specific customization environments, well, you are going to set the parameters that you want to work for that specific environment. Like for instance, you are going to work with a dev prefix and a namespace development and a common label, which is setting a label on your resources to make sure that you can easily get through these different staging scenarios. You know what? Let's go check it out by having a look at a simple example. Again, I try to make it easy because the intention here is just to make you familiar and have you know what is going on in this customization. Alright, so in the course GitHub repository you will find a subdirectory with the name customization. It's a very simple subdirectory with a deployment, a service, and a customization.yaml. Let's check out the deployment. So the deployment is, running a deployment. The deployment is Nginx Friday 20, and we can see all the different parameters. Then we have the service. The service is the service that is exposing the deployment. And most important, we have the customization.yaml. So what are we doing here? Well, very simple. It is working on the deployment as well as the service, and it's applying a name prefix test and a common label environment testing. So if we are going to run that by using kubectl apply -k dot, the dot stands for the current directory, then it is going to create all of this for us. So you can already see that the prefix is there. And what was the label again? The label was environment testing. So if we use kubectl get all -- selector and environment is testing, then we can see all the resources that have been created by this customization.yaml. And that's where I stop our brief introduction to customization. You will notice that customization can be quite awesome, especially if you want to deploy more complex services. You can use this customization to define the relations between the different components. As of now, it's not really a part of the cKAD specs, and that's why I'm not continuing, but you should read the documentation and check out all the features that it is providing. In this video, we are going to talk about blue-green deployments. So what is this about? Well, blue-green deployments are a strategy to accomplish zero downtime application upgrade. Essential in the blue-green deployment is the possibility to test a new version of the application before taking it into production, but still in a way that represents real usage. In this scenario, the blue deployment is the current application, The green deployment is a new application. And once the green deployment is tested and ready, traffic is rerouted to the new application version. Blue-green deployments can easily be implemented using Kubernetes services. We will see that services are essential in blue-green as well as in canary deployments, which are discussed next. So what is the overview of the procedure? Well, you will start with the already running application. Then you create a new deployment that is running the new version and test with a temporary service resource. If all the tests pass, you remove the temporary service resource. As you know, the service is just exposing the application. Bringing down a service doesn't really bring down the application, only makes it unreachable. Now, in the blue-green deployment, you are next going to remove the old service resource, which points to the blue deployment, and immediately create a new service resource exposing the green deployment. And after successful transition, you remove the blue deployment. Now, in this procedure, it is essential to keep the service name unchanged so that the front-end resources, such as ingress, will automatically pick up the transition. Because do remember, the service is a key part in this blue-green deployment, but in the end, users are addressing ingress. Before continuing, I would like to visualize what we are going to do in a small drawing. So let's visualize what the blue-green deployment is all about. We have the user, and this user is pointing to a service. So this service has a unique name, and you are going to keep the unique name. In the old configuration, the service is going to point to old deploy. In the new configuration, you are first going to bring up the new deployment. And in order to test that everything is working, you are going to run a test service. So you, as admin, are going to work with the test service to see if everything is doing all right. If everything is doing all right, well, then you are next going to remove the test service. And what are you going to do next? Well, you are going to reconfigure this service. And reconfigure means that you are going to delete it, immediately connect it again in such a way that it exposes access to the new deployment. The cool thing about it is that the relation between the user and the service at no point will be disturbed. So the only thing that the user might experience is a very small hiccup in time, which is the time that the old service is being removed and the new service is being added. But that is a hiccup that normally falls within the tolerances of the TCP/IP protocol. So that's the essence of blue-green deployments. So now that you have an understanding of what it's all about, let me demonstrate how to work with blue-green deployments. So to start with, I'm using kubectl create deploy blue nginx -- image is nginx 1.14 -- replicas is 3. So kubectl get all is showing the new blue nginx deployment being started. So we can continue and use kubectl expose deploy blue nginx. Port is 80. And then the service name is going to be bg nginx. So here we have the bg nginx service, and I am going to create the green deployment based on the blue deployment. So how are we going to do that? Well, kubectl get deploy blue nginx -o YAML and redirect that to green nginx.yaml. In case you are wondering, hey Sander, why this complicated approach? Well, the complicated approach makes it easy to exactly mirror the current settings of the deployment. True, in this case, it wasn't really necessary. I could have used just a new deployment as well. But in the case where you have applied lots of modifications to your deployment, this is better. You just go into the green Nginx YAML file, and in this green Nginx YAML file, you apply the modifications that you want. Of course, this is a YAML file, so we need to do the usual cleanup. Let me do that first. And there we go. And then we need to change the image version as well as blue to green throughout. I want to make sure that we don't do anything silly here, so I'm not doing it the automated way. So here we have the label set to green. This one will be set to green. Then the match label needs to be set to green as well. And the label in the pod template needs to be set to green. And the Nginx version, let's make that Nginx 1.17. So that is creating the new version. So I can use kubectl create -f green nginx.yaml. kubectl get all is showing all of these pods, and of course we need to test before we can conclude that everything is working all right. And in order to test, we bring up a temporary service, and this temporary service we are creating it using kubectl expose deploy green nginx, because that is after all what we are working with. -- port is 80, -- name is green. So based on this service, you can do your testing. I'm going to skip over the testing for obvious reasons. I just want to show you kubectl get endpoints so that we can see that bg nginx is referring to the blue deployment, and green is referring to the IP addresses being in use by the green deployment. Good. Then at some point your testing is over, and you can use kubectl delete svc green. And now the important step is kubectl delete svc bg nginx. That will delete it, and I'm using semicolon because I want it to continue immediately. The downtime for the service should be as short as possible so that it falls within the tolerations of the TCP/IP protocol. You know, if there's a temporary hiccup, almost all applications have some tolerations that they try again within a certain time frame, and if it takes too long, only then they will generate a failure. So here we use kubectl delete svc bg nginx and kubectl expose deploy green nginx. Port is 80, name is bg nginx. So the result is that bg nginx will now provide access to all these new pod endpoints. Is that so? kubectl get pods -o wide is showing the IP addresses. So we are looking at 74, 78, and 79. And if we use kubectl get endpoints, then we see 74, 78, 79. And that means that the blue-green transition is completed. Of course, you do your testing again. Shouldn't be really necessary, but hey, you still want to do it. And once you are really sure everything is okay, kubectl delete deploy blue nginx can be issued. And then kubectl get all will just show you that everything is in the green deployment. So this is one simple way how you can use the service in a blue-green deployment scenario in Kubernetes. All right, in this lesson we are going to discuss another DevOps migration scenario, which is a canary deployment. Let me first explain and then let me demonstrate. So in the canary deployment, there is an update strategy where you first push the update at small scale to see if it works well. In fact, canary deployment comes from history. In the old days when people were working in the mines and the miners wanted to know if it was safe to go in, they sent in a canary. If the canary would die, then it wasn't safe, but at least, well, they sacrificed the canary, but no people have died instead. If the canary would fly back after some time, then they knew that it was safe and they could go in. And that's the idea of the canary. You send in one pod and you test one single pod. And if it's erroneous, then okay, some people bad luck, but at least not all of your customers are affected. If it's doing well, then you can complete the migration and turn up the number of pods and phase out the old version of the application. So in terms of Kubernetes, you could imagine a deployment that currently runs 4 replicas. Next, you add a new deployment that uses the same label. Using the same label is essential in the canary deployment because then you can create a service that uses the same selector label for all. So the service should use the selector label to connect to the old application as well as the new application. And as the service normally is load balancing, only 1 out of 5 requests would be serviced by the newer version, provided that you have brought in one single pod instance in a new version. If that doesn't work out well, you can easily delete it. And if it does work out well, then you can complete the canary deployment. Let me visualize what I have in mind by making a quick drawing about this. So let me visualize what canary deployment is all about. Canary deployment strategy, or deployment update strategy is a better word, is based on the following. So we have an old version of the application. And in the old version of the application, you are going to use a selector label. Let's call it type is canary. You can put any selector label that you want. And there is going to be a service, and this service is going to provide access to the old application by using this selector label type is canary. And that will be the selector label type is canary, which is not the same as the name of your deployment. Then you are going to bring in the new application. At first, your new application, let's just call it new. You bring in one specific pod replica because you need to test. But you are going to make sure that you use this selector label type is canary while bringing in the new application. Now the Kube controller manager continuously scans for pods using a selector label that matches a selector label of a service. So if you have one new pod instance, the pod instance will immediately become accessible through the service. And the service is going to do load balancing. So initially you will have 75% of the requests going to the old and 25% of the requests going to the new. If you had 3 pod instances here and 1 pod instance here. So that allows you to test. And in this testing, you deliberately take the risk that anything is going wrong with the type is canary. That is why this canary update strategy typically comes pretty late in your testing. At the moment that you are pretty positive that it is going to work out all right, you bring in one new instance and you let your users test. And if anything turns out to be not all right, then only a limited number of your users is affected. And if it turns out to be okay, then you are going to scale. You are going to scale this up. So scale this to replicas is 3. Then you have a 50-50 moment, and if you wish so, you can continue testing while you are at 3 replicas here and 3 replicas here, and then you scale this guy down to replicas is 0, or even delete it. I wouldn't delete it. I would scale it down to replicas is 0. You keep it around for a couple more days so that if anything bad happens to be the case, that you can easily get back. Now the thing is that your users are just connecting to the service, and during the entire canary update strategy, your service is always available, just redirecting to different pods. All right, now that you have an idea of what we are going to do, I'm going to demonstrate. So this demo is a 4-part demo, and I will take it step by step. Here's part number 1. Let's talk about it no more. Let me just show you. So I'm going to start with kubectl create deploy, and I'm calling it old nginx. dash dash image is nginx 1.14 dash dash replicas is 3. Dry run is client, and -o YAML, and I'm writing that to old nginx.yaml. Oh, I just realized that I'm in a directory where I don't want to be. So I'm using Ctrl-A to bring my cursor all the way to the start of the line, and I'm using CD without any arguments with a semicolon, and that will make sure that this old nginx YAML is created in my home directory. Do you see that? The CD without arguments brought me into my home directory out of the cKAD customization. Right, it's a little bit of off topic, but I like explaining what I'm doing. Because I know that sometimes it's the easy stuff that people think you already know about that is confusing, because hey, maybe you're not a Linux expert. That's okay. So I should tell you a little bit about Linux as well. Good, let's have a look at old nginx.yaml. And what are we going to do? We are going to set a label, type canary, in the deployment metadata as well as in the pod metadata. So here we go, type canary. We keep the label old nginx because that's the regular deployment label. That's also used as a selector label, so that is totally fine with me. But I need this type canary to be available throughout. So type canary, there we go. And in case you are wondering, hey Sander, why didn't you do that while running the deployment? Well, as we will see later, it's convenient if we have a YAML file in this canary deployment procedure. But hey, once you understand the procedure, you will notice that there are different ways to complete it. So you want to do it in a different way? That's okay. So now that we have the YAML file in place, we can use kubectl create or apply if you prefer, whatever, on this old nginx.yaml. And kubectl get all is showing you that the old nginx is up and running. Good, now I'm going to use kubectl expose because we want it to be accessible. So kubectl expose, deploy, old nginx, dash name is old nginx, dash port is 80, dash selector, and this is the important part. We are using the selector and we are setting the selector to type is canary. If you expose normally, it would use app equals old nginx as a selector label. But here in the canary deployment, I don't want that to happen. I want a specific selector label so that I can work with that selector label in the old application, in the new application. And that is really going to make the transition easy. Good, if you use kubectl get svc, then what do we get? We have an old nginx, and kubectl get endpoints is showing the old nginx. With 3 pod backends, kubectl get pods -o white is showing the pod backend IP addresses, and you see there is a match. Now, time for testing. Minikube SSH. Obviously, in a regular cluster environment, you would go to one of the cluster nodes and run the testing command from there. But here I'm going to use curl on the service IP address. That is the service IP address, not the pod IP address. So 10.101.201.38, and we do that a couple of times, and well, it won't be any surprising that we get welcome to nginx all the way through. Because there's only one version of the application. So now it is time to prepare the second deployment, and in order to work with the second deployment, I'm going to throw in a config map. This config map is providing some uniqueness to the newer version of the application, which allows us to perfectly verify that it is working as intended. Let's go do it. So I also wanted to take the opportunity to show you some things that we haven't done yet. So I'm using kubectl cp. Cp allows you to copy from the old nginx pod. Just pick a random one. I want to copy the user share nginx HTML index.html to index.html. That is kind of cool, but hey, I'm not even going to use this index.html because this index.html has way too much information. Let's just, let's use it anyway. Let's make that welcome to the canary. And once again, in the header, welcome to the canary. And if we are at a canary, then we should speak canary, right? So let's make that p tweet. Oh, nicely embedded in HTML code. So here we have the new index.html. And I am going to create a config map. So kubectl create cm canary -- from file is index.html. And kubectl describe cm canary is going to show us this config map with the tweet, welcome to the canary. Hey, this is not really a necessary step, but it's nice to throw in a config map and to make this example more alive. I mean, if you would do a real application update, as a user, you would be able to see the difference as well. And that is what this is all about, showing you these differences. So now it's time for the third step. The third step is summarized right here. And in this third step, we are going to make sure that the old Nginx is replaced with the canary deployment. So in this canary deployment, we are also going to mount the config map as a volume. If you want to, you can use the git repo canary.yaml to do so. I don't want you to do that. I want you to look up the information from the documentation because, hey, come on, do you really think that on the exam you can use my git repository for the easy example? I don't think so. So let's do that without the git repository. And let's just go check it out. So let's copy old Nginx to canary.yaml. I like having different configuration files so that if anything is messed up, it's easy to revert. Then we go to the canary.yaml. And in the canary YAML, we are going to change the image. So the image is going to be Nginx latest. We are going to set the replicas to 1. That is very important because that is what it is a canary for. Okay. If you immediately change it to 3, that would make the approach entirely different. The idea is that if anything is wrong in the new application, only a certain percentage of your users is going to be affected. Then, and that is something that we need to do as well, we need to make sure that every occurrence of old is changed with new. On the slide I've used a vi command. Of course, you are welcome to do this in any editor that you want. But I want the deployment as well as the pods to have the new prefix. Then we also need to mount the config map as a volume. So do we still have that somewhere? There we go, mount config map as a volume. So volume's name config map, that's the first part. That is in the spec, and we are opening right here volumes. And that is a list value name, canvol, and config map. Name, canvol, and config map. And what else did we need to do? Oh yeah, of course, in the config map we need a name again. That's the internal name. I'm messing up the indentation a little bit, so this is better. Oops. And the name that we are going to use right here is the canary name. So next we need to mount this thing back to the documentation so that we can see how we are going to mount it. That is right here, volume mounts, name and mount path. So volume mounts, name and mount path is what we are going to put in the container definition. A volume mounts, name, that is going to be canvol, and mount path, that is going to be the actual path to the index HTML. So user share nginx HTML index.html. That should be working. Let's just do a final verification. Volume mount name mountpad. So volume mount name mountpad, that's looking okay. And then we have the volumes name configmap name, referring to the external, and that is looking okay as well. So I think we are good, and we can use kubectl create -f canary.yaml. And oh no, invalid type for got_map expected array. Hey, what did we do wrong? We used a volume mount, and this volume mount, it has an S. So if it has an S, then it expects multiple, right? So here we go again, and that is working so much better. You will see, and I still do that. I always make typos when editing the YAML file directly. So that is why throughout this course, I've tried to teach you how to do it without editing the YAML file directly, but sometimes it's just unavoidable. Good. Now kubectl get svc is still showing old nginx. Kubectl get endpoints is showing what? Is still showing old nginx. What is going on? Kubectl get pods -- show labels. And aha, we have a run container error. Why do we have a run container error? That is unexpected, but that may happen. So let's investigate kubectl describe pod new nginx whatever. And what do we see? We see error response from daemon, OCI runtime, container process, container init field, mounting var lib pods, canvol to root fs cause mount to procfd, not a directory unknown. Are you trying to mount a directory onto a file? All right, so there is a problem in the mount. So let's check it again. So canary.yaml, what were we trying to do? Oh yeah, that's not smart. You see what I'm doing wrong? I'm so focused on the final file that I included, index.html. The error message was pretty clear. We can't mount a file on a file. Right, that means that we need kubectl delete -f canary.yaml and kubectl create -f canary.yaml. And now, before doing anything, I'm using kubectl get pods. Container creating, okay, kubectl get endpoints. I'm a little bit impatient, and kubectl get endpoints is showing me +1 more. That's exactly what I need. So that means that the canary is in the coal mine right now. So I can use minikube. So I can figure out the IP address of the service, and then I can use minikube SSH. And from minikube SSH, we can use curl to 10.101.201.38. Going once, yeah, welcome to the canary. Going twice, welcome to the canary. Going 3 times, welcome to nginx. This is what round robin load balancing is looking like. Every now and then we see welcome to the canary, and every now and then we are redirected to the old version. So that is looking good. Time to take the next step. So now we are at the point that the canary is in the coal mine and it's still singing. So we can complete the canary deployment migration. How are we going to do that? Well, we are going to use kubectl get deploy to verify the names. Then we use kubectl scale on the canary deployment to scale up the canary deployment. And once that has been done, we use kubectl delete deploy to delete the old deployment, and then we are all good. Let's go complete this. All right, kubectl get deploy is showing us new nginx and old nginx. So kubectl scale new nginx -- replicas is 3. Of course, kubectl scale needs me to specify a resource type. Kubectl get deploy. So it is working on it. It will be there in a little bit. Do not continue until that is confirmed, okay? kubectl get pods. Do we see that we're in business? We're in business. Kubectl get, or better, kubectl describe service old Nginx is showing us all of these endpoints. So we have 6 endpoints right now. Now we can use kubectl delete to delete the old deployment, or use kubectl skill deploy old Nginx -- replicas is 0. That is not as brutal as immediately deleting. If you scale it down to 0, then in case you find out that something was not alright anyway, you can easily scale it up again. And if it's deleted, well, then it is deleted. With this, the canary deployment is completed and we only have new Nginx. You still want to try? Well, if you have been successful in your testing in the canary deployment, you shouldn't have to try it right now. In this video, we are going to explore custom resource definitions. So what are custom resource definitions about? Custom resource definitions, also known as CRDs, allow users to add custom resources to the cluster. And doing so allows anything to be integrated in a cloud-native environment. So you want to store it in a cluster? Go ahead, write your own CRD. The CRD allows users to add resources in a very easy way. The resources are added as an extension to the original Kubernetes API server, and no programming skills are required. There's an alternative way to build custom resources, which is via API integration. And that will build a custom API server, and in order to do so, programming skills are required. We are not going to do that here, we are just going to do CRDs. So how does that work? Well, it's a two-step procedure. First, you will need to define the resource using the custom resource definition API kind. Then, after defining the resource, it can be added through its own API resource. Let's go check how this works. So in order to work through this demo, there's a couple of YAML files. You can find them in the Git repository. So first there is CRD object. What do we find in CRD object? We see that it's using the API extensions API group. The kind is custom resource definition. And then the metadata is defined as backups.stable.example.com. In which the group is stable.example.com. And then we get to the entire naming definition. So what do we find? We find the schema, OpenAPI v3 schema, in which we define properties. And the properties are backup type. This is really what it's all about. Backup type, image, and replicas. Scope is namespace. So this custom resource is going to be living within a namespace. And then it has names. The plural names is backups, the singular name is backup. We have a short name BKS and the kind which is set to backup as well. So this is going to allow us to create a backup resource. Let's apply it to the cluster. kubectl create -f crd object.yaml. And we can see that the CRD backupstableexample.com has been created. So if at this point we use kubectl API versions and we grab the result on backup, so if at this point we use kubectl API resources and we grab the result on backup, then we see the backups resource, just the way we just created it, does exist. Let's have a look at the CRD backup.yaml, because the reason we create custom resources is that we want to store site-specific information in the cloud. So this custom resource is all about backup. And what are we going to do? Well, we are going to do according to the three specs, the three property specs that have been defined in the custom resource. First, there's the API version. The API version is stable.example.com/v1. So we need to refer that, and that needs to correspond to the API version that was used in the CRD itself. Then we have the kind backup. The metadata, which is the name, and the spec is set to backup type and image and replicas. So if we are going to use kubectl create -f on crd backup.yaml, then it will be created, and kubectl get backups is showing us that we have this backup. And kubectl describe backups. It's interesting to look at the contents of this resource. There you can see everything currently existing in this custom resource. So that is a quick introduction to working with custom resources. Honestly, are you often going to do it this specific way? Probably not. But you are most likely to be working with operators. Operators are using custom resources all the time. And I will tell you about operators in the next video. In this video, I want to introduce operators. So what is an operator? Well, an operator is a custom application, which is based on custom resource definitions. Operators can be seen as another way of packaging, running and managing applications in Kubernetes. But not like Helm, operators are specifically for new applications that add functionality that did not yet exist in Kubernetes. Operators are based on controllers, and the controllers are Kubernetes components that continuously operate dynamic systems. In order to work with controllers, there's a Kubernetes controller loop, which is the essence of any controller. And in this controller loop, the thing is that it will continuously poll to see if any changes have been applied. So the Kubernetes controller manager itself runs a reconciliation loop, which continuously observes the current state, compares it to the desired state, and if any changes are necessary, it will adjust. Operators themselves are application-specific controllers. Operators can be added to Kubernetes by writing them yourself. That is not something that many people are doing. So most people will be using operators from community websites. Have a look at operatorhub.io, but do notice that operatorhub.io is rather OpenShift oriented, and you may find that the operators in Operator Hub are using components that are not present in your Kubernetes environment. Many solutions from the Kubernetes ecosystem as well are provided as operators, like Prometheus, a monitoring and alerting solution, like Tigera, the operator that manages the Calico network plugin, or Jaeger, which is used for tracing transactions between distributed systems. In the demo right here, we are going to rebuild Minikube, and while rebuilding Minikube, we are going to use the Tigera operator. Do notice that this demo will destroy everything you have done so far. So if you like what you have created in your cluster, make sure you catch it into a YAML file and store it locally. Also notice that any YAML files that you've created so far will not be deleted by using this demo. So let's start with Minikube stop, because we are going to reconfigure networking in Kubernetes. And networking in Kubernetes is, for most people, the first time they ever work with an operator. So that is why I want to show you how that works. We also need Minikube delete to really delete it. And now we can run Minikube start -- network plugin is CNI. That's a common network interface, common standard provided by Kubernetes to allow people to develop networking on Kubernetes. And we need some extra config, and the extra config is in kubeadm .pod -network -CIDR is 10.10.0.0/16. Just take my word for it, we need it in order for this demo to run. In Certified Kubernetes Administrator, you will learn more about what is actually happening right here. Right here, the purpose is not to reconfigure your network. The purpose is to see an operator in action.
That is interesting. We can see Minikube here advising and telling us that we are going for the complicated way. Because if you use network plugin in CNI, you need to provide your own CNI. And the CNI is the actual network agent. Previously, we have used --CNI's Calico. That's a lot easier, but not as insightful and not as directly related to operators. Right, kubectl get all is giving me what? Is giving the usual thing, because nothing is running in Kubernetes right now. Now we are going to use kubectl create -f https://docs.project-calico.org/manifests/Tigera operator. Hey, you see, Tigera operator. So this operator is doing stuff, and this is what I wanted you to see. You can see custom resource definition, API extensions, kubernetes.io, and this is all that is added in crd.projectcalico.org. And this is adding a lot of stuff. And that is the reason why we are doing this. So if I use kubectl get ns, what do we have? We have a Tigera operator. And if I use kubectl get all -n in Tigera operator, what do we get? Well, we get a deployment and a replica set and a pod in this Tigera operator. And if we use kubectl API resources pipe grep Tigera, then what do we get? We can see we get some new resources, which are all from the API group operator.tigera.io. So that's an operator in action. Now I do want to complete this procedure, and in order to do so, I am going to use wget to, back to the home directory, wget to https://docs.project-calico.org/manifests custom resources.yaml. So this custom resources.yaml, that is the configuration file that is added to this Tigera operator. You can see it addresses the operator tigera.io, the kind installation, which is one of these resources that we have seen being added. Now we need to make sure that in this file the CIDR matches the CIDR that we have used before. So I'm going to manually do that. 10.10.0.0, there we go. And now I can use kubectl create -f custom resources.yaml to actually create these resources. And there we go again, still working in the Tigera operator. kubectl get installation -o YAML. This is one of these resources that has been created by the operator, and you can see there's a bunch of YAML code behind it that specifies the actual network. And the result, kubectl get pods -n Calico system, and that is showing that the Calico system is currently in the process of being created. Notice that this may take 1 or 2 minutes, and once all these Calico system pods are up, you have fully functional software-defined networking. And there we go, all the pods are running, so we have networking thanks to this Tigera operator. Again, you will see operators all the time to add additional components to Kubernetes. Alright, as the last topic in this lesson, I want to talk about stateful set. Stateful set is one resource that you will come across sooner or later, and I need you to understand what it's about. So what is it about? Well, stateful set is like a deployment, but main purpose of a stateful set is to provide a persistent identity to pods as well as pod-specific storage. Each pod in a stateful set has a persistent identifier that it keeps across rescheduling. And stateful set provides ordering of the creation of resources as well. And using stateful set is required in some specific cases, especially for applications that need one of the following. Like a stable and unique network identifier, stable persistent storage, ordered deployment and scaling, or ordered automated rolling updates. Now, stateful sets do also come with a couple of limitations. First is that storage provisioning based on storage class must be available.
So that means that if you are working in a cluster that you have created for yourself where storage class is not available, you must look for a storage provisioner that talks to your local storage to implement storage class. To ensure data safety, volumes that are created by the stateful set are not deleted while deleting the stateful set, because you don't want your data to be automatically deleted. Also, a headless service must be created to provide application access. Now, what is that? That's a service, but without an IP address. And to guarantee removal of stateful set pods, you should scale down the number of pods to 0 before removing the stateful set, because the stateful set cannot decently remove pods. So there's a couple of things that you need to be aware of, but if you are, you can use stateful set. I have prepared a simple example. Let's go check it out. So in the course GitHub repository, you will find sfs.yaml. And in sfs.yaml, you will find everything that is involved. So to start with, as it is a requirement for every stateful set to have a service associated as well, we have the service. So the service is using kind service, and it's setting a port and cluster IP, and this is the interesting one, cluster IP is set to none. That makes it a headless service. But the service is required for API level access to all the resources that are created with the stateful set. Then we have the stateful set definition itself. So what do we see? The kind is set to stateful set. It has a name which is set to web. Then it has a service name as well. That's kind of unique. You don't see that in deployments or in daemon sets, but in stateful set it's a requirement. Services belong with the stateful set. We have some replicas also, and then we have the specification. So in the specification we have a container, and this container has a volume mount. Now the volume mount is the next thing that is specific about the stateful set, because in a stateful set we have a volume claim template. Now what is a volume claim template? A volume claim template is something very handy. It's a solution to automatically create volume claims. So in this volume claim template, we use the metadata name www, and then we specify access mode, storage class name, and resources. And the request is set to storage of 1 gigabyte. Storage class name actually is pretty important as well, because this storage class name allows you to reach out to a specific storage class in case that is required. So before running this, kubectl get storage class is showing what? Is showing that we have a storage class with the name standard. And that's what the stateful set is going to use. And then if we use kubectl create -f sfs.yaml, it is creating the service as well as the stateful set. We need to give it a tiny little bit of time, and then we can use kubectl get all. And what is that doing? Well, we can see that the stateful set is there, and the pod web is in a state of container creating. Now you can see that the pod name is not your regular pod name. You can also see there is no replica set. Stateful set does not use a replica set. You know, replica set, in fact, it's still in deployment, but deployment could even do without it. Stateful set is doing it without it. While it's working, let's have a look at kubectl get pvc, where we can see that for all the pod instances, and this is what it really is about, for all the pod instances, it has created a persistent volume claim. Now this persistent volume claim is handled by storage class, and our storage class has automatically create a persistent volume for it. This is just the regular way of working with storage like we have seen it before. So if we do our kubectl get all again, there we can see that the pod web0 is actually running. And that is the stateful set. Stateful set keeps an eye on the pods, makes sure that a sufficient number of pods is available. But most important, stateful set helps you to run applications that have a persistent state. And that's why you might use stateful set in some specific cases. In this video, I would like to visualize the flow of events whenever you are going to create resources. So let's say you start with kubectl run, whatever you want to run. Then what is going to happen? Well, your request is being forwarded by the kubectl client to the API server. The API server is next going to write your resources to the etcd. So that is the first stage. Well, we should say this is number one, this is number two. Then once the resource has been successfully submitted to the etcd, the kube scheduler will come in place. So from the etcd, the scheduler is going to talk to any of the kubelets. And the kubelet is the part that is running on your Kubernetes nodes. And this kubelet is going to talk to the container engine. And this is going to run the container. So what does that mean? Well, in your troubleshooting procedure, that means that no matter what you are going to do in Kubernetes, you will always end up with your resources being added to the etcd. If anything is going wrong with these resources in the etcd, then kubectl describe is going to be your big help. So kubectl describe works for any resource type, and kubectl describe applies to part 2 and also to part 3 and even to part 4, where you can see that the kubelet has successfully scheduled your application. Now in kubectl describe, in the end, when the kubelet is running your application, the kubelet will provide feedback to the Kubernetes cluster, and you can find your application status. Now if the application status is off, then kubectl logs is what you are going to use. kubectl logs allows you to go directly into the container to investigate the container log and to see if there were any issues running the application. kubectl logs make sense if kubectl describe is showing you that the main application in the container has stopped with an exit codes other than 0. If there was an exit code other than 0, that means that the application has logged information. Well, should have logged information, because in the end it all depends on your application. If the exit code of your application was 0, or if it goes wrong before, kubectl describe is going to be your number one location for troubleshooting. So now that you know what is involved in starting up resources in Kubernetes, let's do a quick overview before we are going to attack some real problems. So after using kubectl create or kubectl run, the requested resources are written to the etcd database. Next, the scheduler will look up a node eligible to run the application. And after finding an eligible node, the pod image is fetched. Next, the pod container is started and it runs its entry point application. And based on the success or failure of the entry point application, the pod restart policy is applied to determine further action. In the next couple of videos, we will investigate a couple of scenarios that help you in practicing troubleshooting. Let's talk about analyzing failing applications. So before you can analyze failing applications, first thing to do is kubectl get pods, and you will see a pod state. So the pod can be in different states. To start with, there is pending. If a pod is pending, then the pod has been validated by the API server and an entry has been created in the etcd, but some prerequisite conditions have not been met. For example, the pod has a resource request and there is no node available with the requested resources. Running is what you want to see. That means that the pod currently is successfully running and nothing is wrong. Completed is what you see if the pod has run to completion. This is what you typically get if a pod was started with a job and it has just finished. If you see completed, there is always a restart policy never that is involved. Failed means that the pod has finished but something has gone wrong. Crash loopback off means that the pod has failed and the cluster has restarted it. Unknown means that the pod status could not be obtained. Current pod status can be obtained by using kubectl get pods. And that is always the first thing to do if you want to troubleshoot failing applications. Once you have found that something is wrong, the next step is to use kubectl describe to investigate the application state. First, in the kubectl describe output, you will have a look at the events, and next you will have a look at the application state to investigate what is going on. And in the application state, you should check the last state, and in particular the application exit code. If the exit code is 0, then the application has completed successfully and no further investigation is needed. That basically means that from the Kubernetes perspective, there is no problem. So maybe you have just started the application the wrong way. If the exit code is other than 0, then there is a problem with the entry point application. And you need to use kubectl logs to investigate the application logs. Let's go through a quick demo so that I can show you. So let's go through a first example. When we use kubectl create deploy failure 1 -- image is busybox, then kubectl get pods is showing us this. Oh no, we have crashed loopback off. So that's a typical situation, might not even be a surprise. So what is happening? Well, first line of attack is kubectl describe on the pod failure 1. And that is showing us back of restarting failed container. Well, we already knew that. Most important piece of information is in the container, where we can see right here, the last lines of the highlighted part. We see a state terminated, reason completed, exit code 0. Last state terminated, reason completed, exit code 0. That means that from the Kubernetes perspective, nothing is wrong. That means that the entry point application is just completed successfully. So you need to wonder, what exactly is this entry point application? Well, this is a busybox container, and in a busybox container, the entry point application is just a shell. And if you start any of these operating system-like containers, they start a shell. And Kubernetes brings it up, it starts a shell, and then it's done. It's not going to wait for you to do anything. So this is expected behavior, and this behavior can only be fixed by passing a command. So kubectl delete deploy failure 1. And if we go back to the create and we add the command sleep 3600, then kubectl get pods will show us a successfully running pod. Obviously, sleep 3600, that means that after an hour it will stop and then it will be restarted again, but you just won't see it as a failure anymore. So this was scenario 1. Here we have the other scenario. It's in fact a scenario that we have seen already a couple of times before in this class. But in this context of troubleshooting, we should see it again. So here we go. I'm running kubectl create deploy failure 2. This image is MariaDB. So next, kubectl get pods. Obviously it needs a little bit of time. So next, we are going to investigate using kubectl get pods. And we see it's still in the status of container creating. In case you are wondering, hey, why don't you do kubectl get all? Well, that is easy. In pod troubleshooting, it's the pod that is running the application. So errors on the deployment or errors on the replica set are pretty rare. Kubectl get pods will show you what you need to see. I know it's still in container creating, so apparently it's downloading the image and that takes a little bit. And now, hey, that is surprising. It is running? Of course not. It is crash loopback off. And crash loopback off, well, we just got it at the wrong moment. Sometimes you have a false positive. So if you see that it is running and you are not sure about it, just run kubectl get pods again. So kubectl describe on pods failure 2 is showing us that we can see it on the top here. Last state terminated, reason error in exit code 1. It's the exit code 1 that it's all about, and exit code 1 means that we are going to use kubectl logs on this failure 2 pod. And what do we see? Well, we see the MariaDB root password. So in order to fix kubectl set env, this is also something we have seen a couple of times before. This is what we are going to do. So deployment slash key equals value. So kubectl set env deploy failure 2 MySQL root password is password, and that will fix it for us. kubectl get all this time, and we can see that failure 2 is in the status of container creating, and we still have the crash loopback off. That's because we've been too fast. Right now we can see failure 2 is running, and that's what we wanted to see. So that's all. The next thing that can go wrong is in accessing pods. So let's investigate. In order to access the workload that is running in a pod, there is a service that is involved. And the service is used to load balance between the available pods. So without a service, no access to the pods. To connect to the backend pods, the service is using a selector label that matches the pod label. And if services don't work as expected, you should check these labels first. Also, use kubectl get endpoints to check services and corresponding pod endpoints. Oh, and don't forget the nature of your services. If your service is cluster IP and you are trying to reach it from the outside, that won't work. So in service troubleshooting, best thing to do is to start from a cluster node, so that at least you don't have that specific problem. Next there is ingress. Ingress uses a service to forward traffic to pods. And in order to do so, the pod labels are used as well in ingress. Ingress also requires an ingress controller to be configured and running. Troubleshooting the ingress controller can be complicated and is beyond the scope of cKAD. So no worries, you won't see it on the exam. Next component in accessing your workloads is the network policy. So network policies can be applied to pods, namespaces and IP ranges to restrict traffic in both directions. If you think that your problem is related to a network policy, use kubectl get netpol -A, just to figure out if any network policies exist. If they do exist, use kubectl describe on the network policy, and if you don't like what they are doing, you can delete the network policy. Because the standard behavior in network policies is that if a network policy applies to a specific workload, then all access is denied, unless there is a rule specifically allowing access. Then there's a network add-on to consider as well. There are different network add-ons available for Kubernetes, and changing a network add-on may fix or break network-related problems. The Flannel add-on, for instance, doesn't support network policy. If you run Minikube out of the box, you don't get network policy, and that is why you might have to change the network add-on. Earlier in this course you have learned how to do it. And you should always consider using the Calico add-on for a rich feature support. In all of my demos, I like using Calico. Calico works with ingress, Calico works with network policy, so Calico is cool. Go Calico. Here we have a small demo. I'm going to walk you through this demo so that we can pay attention to troubleshooting of services related problems. Alright, I'm going to start with kubectl create deploy trouble -- image is nginx, and kubectl expose deploy trouble -- port is 80 -- type is node port. And in fact there is no way in which this command can go wrong. Because if you use kubectl expose or kubectl create service, it will automatically work with the label that is detected in the application. kubectl get endpoints is showing me that trouble is connected to the backend pod. And kubectl get svc is showing the service IP address. And in order to test, well, we are going to use curl on this Minikube IP address, the Linux command substitution again, which is giving me the result of the command Minikube IP on the node port 32166. And there we can see, yeah, welcome to Nginx. This is the default Nginx welcome page, so this is working all right. Now a typical problem can be kubectl edit svc trouble. We are going to edit it. And in the edit, we find the selector app is trouble. Let's make that an uppercase T. How realistic is this? I don't know. But if on the exam they want you to run on network troubleshooting related to services, I can only imagine a problem related to the selector label. So what is the result? Well, the result obviously is that it doesn't work anymore. And if it doesn't work anymore, what are you going to do? Well, kubectl get endpoints is a good start, where we can see that kubectl get endpoints. Oh no, trouble doesn't have any endpoints anymore. Yeah, of course, that is because we just changed the selector label. Let's change it back so that we can also see that this is immediately giving us a solution. So kubectl get endpoints, did you see that? That's instantaneous. And and curl to the node port again, and the service is accessible. So that is about what you can do to troubleshoot services. Also, do not forget the nature of your service. If your service is cluster IP, you really need to go on the cluster node to access the service, because cluster IP can't be accessed from the outside, not even from the node where you are using kubectl. Another step in troubleshooting is the cluster event logs. The cluster event log is giving a generic overview of everything that has happened. So how does that work? Well, you can just use kubectl get events to provide an overview of cluster-wide events. And if you use kubectl get events -o wide, then you get an overview of cluster-wide events with more details. You can use kubectl get events in case you have no idea where you should be looking. Because kubectl get events is giving a generic overview. If you have an idea what resource your problem relates to, better get there directly. Or alternatively, use kubectl describe on the different resources to see if anything odd is going on your resources. Let's go check this out. So here we have kubectl get events. And kubectl get events is showing us sorted by time. That's the amount of minutes ago, and the last minute, the last message is last. It's showing us what has happened in the cluster. And we see the events. If we pipe that through less, you can see the header line. Last seen type, and the type, well, you can see most of it is type normal. And the reason, and then you get the object and the message. You might want to grab on warning, so grab warning to see warnings only. And there you can see, oh no, we have warnings, back of restarting failed containers. That's interesting to see that back of restarting failed container doesn't show as an error, it shows as a warning, so that is what needs further investigation. We have seen kubectl describe on numerous occasions. I can recommend you use kubectl describe nodes on your node as well. So in this case we have one node only, and if you want to know what is going on that specific node, use kubectl describe, because kubectl describe is giving a nice overview of everything that is happening, including the events. You know, if things are going wrong, then in most cases your cluster node or one of the cluster nodes will be involved. So using kubectl describe on a node might not be a bad idea at all. And look at that. Here we can see, for example, the conditions, what has happened, and memory pressure, and the status is false. So these are the basic critical conditions that you can find on a node. Can be quite useful as well. And other settings are in here also. But cKAD is mainly about troubleshooting applications. So kubectl describe nodes can be useful, but you shouldn't have to go into advanced node troubleshooting. Another type of problem that may occur is the authentication problem. That is mainly in real life. This is also one problem that I don't expect you need to troubleshoot on cKAD. It's more like a cKA problem. but let's go through it anyway. So access to cluster is configured through a kubeconfig file. You will find it in .kube/config. And this file is copied from the controller node in the cluster, where it is stored as etc kubernetes admin.conf. You can use kubectl config view to check the contents of this file. And for additional authorization-based problems, you can also use kubectl auth canary, like kubectl auth can I create pods. And it will tell you simply yes or no to indicate whether or not you can do that. Advanced troubleshooting of RBAC is covered in cKAD and mostly in CKS, but let's go over a simple problem. Here we have the demo. Let me show you what's involved. So to start with, I am going into the .kube directory where we have this config, and let me move config to .config. Oops. And now what is going on? If I use kubectl get all, oh no, the connection to the server was refused. That is what an authentication problem looks like. So what can we do next? Well, we can go fetch it from the Kubernetes controller host. Minikube SSH is where I'm starting. I do need a root shell. sudo -i is what we need to get access to a root shell. And I'm using cp of etc kubernetes admin.conf to the tmp directory. Oh, that's an error. tmp it is. Also, I need chmod 644 on tmp admin.conf. And now we can use exit and another exit. And then I can use scp -i using minikube ssh key, docker add minikube ip tmp admin.conf to ~.kube/config. So let's analyze this command. In this command we have command substitution twice. This is the first time. Here we use the result of minikube SSH key. So this is the SSH key that we need in order to reach out to the minikube machine. On the minikube machine, the default user account is called docker. So we are using docker add minikube IP, which is obviously the minikube IP address. In case you are wondering, what is this thing with this docker user? Well, we need this docker user to access the admin.conf file. The docker user cannot directly copy from etc kubernetes admin.conf, and that's why I've put it in this tmp directory as a temporary solution. So now we go and yes, that is okay. So now if I use kubectl get all again, then we can see all the resources running again.
One useful help in troubleshooting are probes. Let's talk about probes. So a probe is a test that you can use to test access to pods. And they are part of the pod specification. There's a readiness probe, which is used to make sure a pod is not published as available until the readiness probe has been able to access it. And the liveness probe is a probe that is used to continue checking the availability of a pod. There's also a startup probe. It's a little bit less important. It was introduced for legacy applications that required additional startup time on first initialization. There are different probe types, but the most important thing to understand is that the probe itself is just a simple test. Often, it's just a command. If you look at the probe types in pods.spec.container, you will find the following. exec is a command that is executed. And this command returns 0 exit value, which means that it was executed successfully. There's HTTP GET, which is an HTTP request that returns a response code between 200 and 399. And there's TCP socket, which is testing connectivity to a TCP socket, which is basically an available port. And if the connection could be made, the probe is successful. The Kubernetes API provides 3 endpoints itself that indicate the current status of the API server. And these 3 endpoints are commonly used in the probe tests as well. There is health Z, there is live Z, and there is ready Z. You can use any of these endpoints by the different probes. Now let me demonstrate how to use probes. First, we are going to test for the existence of a file. So this demo is in a YAML file, and the name of the YAML file is busybox ready. And in the YAML file, you can see a readiness probe. What is the readiness probe doing? Well, with an interval of 10 seconds, it's executing the command cat tmp nothing. So I am going to use kubectl create -f busybox ready .yaml. And kubectl get pods is showing busybox ready in a state of container creating. And a little bit later, it's showing it in a state of running, but 0 out of 1. That's not good. Let's investigate kubectl describe pods busybox ready. And we can see why it is showing the 0. It's telling us readiness probe failed. Cat can't open tmp nothing, no such file or directory. So the pod is not listed as available yet. Can we change that? Well, you might want to try kubectl edit pods on busybox ready and change it to etc host. What do you think? Is that going to work? There's only one way to figure out. Try it. If you get back after kubectl edit in something like this, then the edit was not valid. And it's telling you that there's only a limited number of fields that can be edited this way. So let's get out of here and let's do it in a different way by using kubectl exec -it busybox ready touch /tmp /nothing. And now I'm using my kubectl get pods again, and there we can see, oh no, it's still busybox ready 0 out of 1, but that doesn't take long. As you can see right now, it is listed as available. This was probe demo 1. Let's do another demo. In this demo, we use Nginx probes. So what is this doing? Well, Nginx probes is showing a readiness probe as well as a liveness probe on TCP socket port 80, port 80. So on the readiness probe, that is managing the initialization. It has an initial delay of 5 seconds, and then every 10 seconds it will check again. And then we have the liveness probe, which is checking the availability. So this should be a very simple one. kubectl create -f nginx probes.yaml. And kubectl get pods is showing what? It's showing nginx probes container creating. It's showing nginx probes running. It's still showing nginx probes running. We are within 9 seconds now, so we need to wait just a little bit, and then it will see nginx probes as running and 1 out of 1. So this is what we are looking at, the 1 out of 1 as opposed to 0 out of 1 and 0 out of 1. That's how you use probes. All right, let's start the sample exam with some exam tips. First, be fast and use the most efficient tools. Many people, driven by what they do at work, want to do it in a nice way. Don't do it in a nice way, just do it in a fast way. So don't create YAML files if you can do it the imperative way, for instance. If you need to work with YAML, do not write YAML, but generate it. And also train using kubernetes.io/docs. If you know what information can easily be found on kubernetes.io/docs, if you have trained that, especially for the difficult parts, then on your exam you may find that you can just copy-paste code from kubernetes.io/docs. You are going to work in a secured environment with a browser that is provided by the environment. So you won't work in your environment with your browser. You can't set any bookmarks. So make sure you practice and you know how to find the more difficult parts in the documentation. So that you don't have to figure out, for instance, how to mount a config map manually, but you just copy paste it from the documentation. Also, you might like the kubectl cheat sheet. You find it in the documentation, and this documentation is legal. Also, use kubectl explain a lot, because kubectl explain is what you need to get this fast overview of parameters that matter. And make sure you know how to deal with Kubernetes namespaces. Pay attention to the namespace in every single question. You might have to change between namespaces, and if you create your resources in the wrong namespace, it's not going to work. One final thing, when you start the exam, you get a list of allowed websites. Make sure you are only on the allowed websites. If you are going to move to a website that is not allowed, the proctor might stop you and you can even be excluded from the exam. Discuss.kubernetes.io is a notorious website where you cannot be. Kubernetes.io/docs, I think that's the only website that you should study. Most relevant. I hope these tips are helping. In the next video, I will present the example question overview. All right, it is time for the practice exam. So I'm going to present all the practice exam questions. What I would advise, pause the video at every single exam question and work on it. And do all of the exam questions. If you are almost ready for the exam, I would say try to do them in 2 hours. It should be doable in 2 hours. And if you are doing this for the first time, take the time that you need. Just use it as a practice. Once you are done, you can play all of the remaining videos in which I'm providing solutions. I'm not saying it's the solution, I'm saying it's a solution that helps you to verify your work. Here we go. So first is working with namespace. Create a namespace with the name cKAD NS1 in your cluster, and in this namespace run the following pods. A pod with the name pod A, which is running the HTTPD server image, and a pod with the name pod B, which is running the Nginx server image as well as the Alpine image. Next, you are going to use secrets. Create a secret that defines the variable password is secret, and create a deployment with the name secret app, which starts the Nginx image and uses this variable. Then create a Docker file that runs an Alpine image with the command echo hello world as the default command. Build the image, export it into OCI format to a tar file with the name greet world. Then create a multi-container pod with the name sidecar pod that runs in the cKAD NS3 namespace. The primary container is running busybox and writes the output of the date command to the var log date.log file every 5 seconds. The second container should run as a sidecar and provide Nginx web access to this file using a hostpath shared volume. Mount this on user share Nginx HTML. Make sure that the image for this container is only pulled if it is not available on the local system yet. Next, start the deployment from the redis.yaml file in the course Git repository and fix any problems that may occur while starting it. Then you are going to use some probes. Create a pod that runs the Nginx web server. And the web server should be offering its services on port 80 and run in the cKAD NS3 namespace. And this pod should check the health Z path on the API server before starting the main container. Then write a manifest file with the name Nginx exam that meets the following requirements. It starts 5 replicas that run the Nginx 1.18 image. Each pod has the label type is webshop. Create a deployment such that while updating, it can temporarily run 8 application instances at the same time, of which 3 should always be available. And the deployment itself should use the label service is Nginx. Update the deployment to the latest version of the Nginx image. Next, in the cKAD NS6 namespace, create a deployment that runs the Nginx 1.19 image and give it the name Nginx deployment. Ensure it runs 3 replicas, and after verifying that the deployment runs successfully, expose it such that users that are external to the cluster can reach it by addressing the node port 32,000 on the Kubernetes cluster node. Configure ingress to access the application at mynginx.info. Then create a YAML file with the name mynwpolicy that runs 2 pods and a network policy. The first pod should run an Nginx server with the default settings. The second pod should run a busybox image with the sleep 3600 command. And use a network policy to restrict traffic between pods in the following way. Access to the Nginx server is allowed for the busybox pod, and the busybox pod itself is not restricted in any way.
Then you are going to use storage, and you make sure that everything is created in the cKAD 1311 namespace. Create a persistent volume with the name 1311 PV. It should provide 2 GB of storage and read-write access to multiple clients simultaneously, and use the host path storage type. Next, create a persistent volume claim that requests 1 GB from any persistent volume that allows multiple clients simultaneous read-write access. And the name of this object should be 1311 PVC. And finally, create a pod with the name 1311 pod that uses this persistent volume. It should run an Nginx image and mount the volume on the directory/web data. Then you are going to set some quota. Create a namespace with the name limited, in which 5 pods can be started and a total amount of 1000 millicore and 2 GB of RAM is available. Run a deployment with the name restrict Nginx in this namespace with 3 pods, where every pod initially requests 64 MB of RAM with an upper limit of 256 MB of RAM. Then you'll create some canary deployment. Run a deployment with the name myweb, using the Nginx 1.14 image and 3 replicas. And ensure this deployment is accessible through a service with the name canary, which uses the node port service type. Update the deployment to the latest version of Nginx using the canary deployment update strategy, in such a way that 40% of the application offers access to the updated application and 60% still uses the old application. Then you are going to manage pod permissions. Create a pod manifest file to run a pod with the name sleepybox. It should run the latest version of busybox with the sleep 3600 command as the default command, and ensure that the primary pod user is a member of the supplementary group 2000 while this pod is started. And finally, create a service account. Create a pod with the name All Access, also create a service account with the name All Access, and ensure that the pod is using the service account. Notice that no further RBAC setup is required. Good luck, and don't forget to check all of the solutions in the next videos. Alright, let's have a look at some solutions. To start with, the assignment about namespaces. So the task was to create a namespace cKAD NS1 in your cluster, and in this namespace you run the following pods. A pod with the name pod A, running the HTTPD server image, a pod with the name pod B, running the Nginx server image as well as the Alpine image. Alright, let me show you the solution. First we need a namespace, so kubectl create ns cKAD ns1. Use kubectl get ns to verify that it was created. Then we need a pod with the name pod A running the HTTPD server image. Well, kubectl run pod A dash image is HTTPD. Should be doing it. Is that all right? Of course it's not. But that is what I want you to realize. On the exam, you will be working with namespaces. And you will be creating resources in these specific namespaces. So if you don't specify -n followed by the name of the namespace, then your resource ends up in the wrong namespace and you get 0 points for this assignment, even if it's an easy assignment. So -n cKAD ns1. You might be able to switch your current namespace. I'd advise against it, because you get the same problem. If you switch your current namespace and then you forget about it in the next assignments, all of your resources are in the current namespace. That's not very smart, so better don't do that. Now we need a pod with the name pod B running the Nginx server image as well as the Alpine image. Aha, Nginx as well as Alpine. That's a multi-container pod. So how are we going to do that? Well, I would advise you just use kubectl run pod B dash image is Alpine. I'm doing that for a reason. Let me put the -n cKAD ns1 before. So dash image is Alpine dash sleep 3600. Dry run is client. -o YAML.
greater than task1.yaml. This is how I normally work on the exam. On the exam, you have the numbered tasks. I like to create YAML files, so that makes it easy to verify what I've done later. And I would name the YAML file according to the task. So task1.yaml. So let's verify task1.yaml. Hey, pod B created. What's going on? Well, if we analyze the command, then you notice that the dry run is client and the sleep 3600 are in the wrong location. So sleep 3600 really needs to be to the end of it. So let me repeat it, minus sleep 3600 to the end of the command this time, and have a look at this task1.yaml again. And now it's looking better. And now we can start this additional container. The reason why I use Alpine and I ran this Alpine with the command is that the syntax to specify commands that should be started by a pod is not always obvious. Let me also change the name here. Alpine, it's not very pretty. And let me just manually put in the second container. So name Nginx. And the second container can be very simple, image Nginx. Did we need anything else? No, we didn't have any little things to take care of. So kubectl create -f task1.yaml should be doing it. And oh boy, pod B already exists. Did I do it right? Well, apparently not, but hey, that is easily fixed. Pod B already exists. I'm using kubectl delete to delete the YAML file. That will delete pod B. And now I'm going to run it again, and we can check kubectl get pods -n. What was the name of the namespace again? cKAD ns1. And there we can see pod B is running 2 out of 2, so that is looking pretty alright. Maybe you also want to verify using kubectl describe -n cKAD and ns1 pod B, just to verify that you have these containers in there. And you can see Alpine is in here, Nginx is in here. That seems to be the correct solution for this first assignment. All right, next assignment is about using secrets. Create a secret that defines the variable password is secret and create a deployment with the name secret app, which starts the Nginx image and uses this variable. Good luck. This assignment is one of these assignments where you should keep it simple. kubectl create secret -h. You can do all of this from the command line. What do we see? Oh yeah, we need a generic. So kubectl create secret generic. I'm just showing you how to easily get access to the help. And what we need from file is key 1 is super secret. Okay, so kubectl create secret generic. Oh, we don't need a name, so let's call it secret pw -- from literal is password is secret. Just clean up the command a little bit. That should be doing it. kubectl describe secret secret pw. There we go. It has this password 6 bytes. I'm not going to verify it. This command is so straightforward, there's no need to do it. Next, we need to create a deployment. So kubectl create deploy secret app -- image is Nginx. And I'm going to use kubectl set_env -h. There is no way to pass an environment variable while creating the deployment directly from the command line. That's why I'm doing it in 2 steps. There's nothing wrong with that. So kubectl set_env. And where do we have it? We have, oh, there we have it. kubectl set_env. This is what we need. So I like to copy it. and use a pound sign and paste it behind the pound sign. And then I'm using kubectl setenv dash dash from is secret slash secret pw deployment secret app. Oh, that was a typo. From equals secret. And then we can see deployment apps secret app env is updated. It is kindly telling us that it has transferred the secret to password in uppercase. That's okay with me. Now kubectl get pods should show us secret app. So now I use kubectl exec on secret app dash dash env to print the environment. And in the environment, we can see the password is secret. That didn't only provide the solution, but also tested the solution. And we are good. Time to continue.
Let's have a look at the solution for the next assignment. So in the next assignment, you needed to create a new custom image. Create a Docker file that runs an Alpine image with the command echo hello world as the default command. Build the image and export it in OCI format to a tar file with the name greet world. So let's have a look at the solution. So let's get started, and let me create a Docker file in the current directory with a from Alpine and a CMD. And in the CMD we have all of the elements in the array notation. Echo is element number 1. The argument is element number 2, so echo hello world. It can be simple like this, and the question doesn't ask for anything more complex. So let's use docker build -t greet world on dot. And there we can see that it has created the image. So Docker images should show us greet world latest created 7 seconds ago. Next we need to export it in OCI format to a tar file with the name greet world. So that would be docker save -h or -- help to get more information. And there we can see that docker save has some options. Really the options are very simple. Docker save -o greet world .tar on greet world should save it. And now ls -l should show us greet world .tar. And that is all. Now there is one confusing thing here. Export it in OCI format. What do we need to do with it? Well, nothing. Because Docker images are OCI compliant as they are. So you can just ignore it, build the image, and use docker save to save it. That's all. Let's continue. So time for the next assignment. In the next assignment is about sidecars. The question was to create a multi-container pod with the name sidecar pod that runs in the cKAD ns3 namespace. Where the primary container is running busybox, writes the output of the date command to varlog date.log every 5 seconds. And the second container should run as a sidecar and provide Nginx web access to this file using a host path shared volume. And make sure that the image for this container is only pulled if it's not available on the local system yet. Alright, in this assignment we have a little bit more work to do. Let me show you how to approach this. So the best approach here is the documentation, kubernetes.io/docs. And just look for sidecar. And that will bring you communicate between containers in the same pod using a shared volume. That is the one that is really useful. Because in here we can see something really worth copying. We have a shared data here and an Nginx container and a Debian container, and that is bringing us close enough. So let's put that in task
15.6.yaml, copy it and modify it. So first we need the name. The name needs to be sidecar pod. So there we go, sidecar pod. Namespace, we also need a namespace. cKAD-ns3. Then we need this volume. So the volume needs to be host path. And host path, that's not empty there. That is host path. So how exactly do we define a host path volume? Well, can we find that in the documentation? For this assignment, I really recommend you go for the documentation. So configure a pod using a persistent volume for storage. Maybe it's in there. So let's look it up. Yeah, there we go. This is what I was looking for. We have host path with a path argument in MNT data, but it's a persistent volume, so it's not exactly what we need. But it's the same thing. So path my data or whatever. They should be doing it. So the path on the host path is not specified in the assignment, so we don't care about it. And we can continue with the Nginx container. So let's have a look. The Nginx container is a second container that should run as a sidecar and provide Nginx web access to this file. So the Nginx container just needs the volume mount. And the volume mount is going to be to share data, and it is mounted on user share Nginx HTML. How convenient that it's already there. Then we have the primary container, which is running BusyBox. So let's give it a name, BusyBox container, and an image, which is BusyBox, and a volume mount. And the volume mount is shared data, and the mount path is var log. So /var/log. And then we need the arguments. So what are we going to do in the arguments? Well, we have a command and arguments. And oh boy, how exactly do we generate a command syntax in the right way? Don't you also think it's complicated to get commands in with the right syntax? Well, if you do, it might be worth generating some YAML code. So let's do that. kubectl run busybox dash image is busybox, and then dash dry run is client, minus o YAML, dash sh minus c, and then we can put in the entire loop. If you have some shell scripting structure that you want to put in, use it as an argument to sh minus c. So while sleep 5 date greater than /var log date dot log semicolon done. Oops, we're forgetting a do here. Let's put the do in there. And there you can see the YAML code. And in the YAML code, as you can see, the arguments option is what is used. So now I can copy the arguments. So let's get back to the text file that I was generating. That is vim on task 15.6. Now I'm lost. Oh, I know where it is. That is vim on task 15.6 YAML, where we have the Nginx container, and we have the default line, which is command and arguments. But hey, I'm going to remove this default and replace it with what we have just generated. We need to fix the indentation. So args is a child to the container, and sh minus c while belongs to args, and this should be doing it. So let's do a kubectl create -f on task 156.yaml. And oh boy, we have an error when creating task 156 YAML. Pod in version v1 can't be handled as a pod. Unknown field. Spec container volume mounts.args. Hey, what is that showing? That is showing that we messed up the indentation. And we did, because right now we have volume mounts, and volume mounts is using dash args. That's not good. That must be just args. Because dash args is a volume mount, makes it a child to the volume mounts, and the args belongs to the container. So here we go again. And oh boy, namespace is cKAD -ns3 not found. That's a minor problem. kubectl create ns cKAD ns3. And kubectl create -f. Now it is created. So if we use kubectl exec -it on sidecar pod -n cKAD -ns3 sh, then we run a shell. And what are we looking for? Well, we are looking for the nginx container. Would have been nicer if I would have used kubectl exec -it sidecar pod -c nginx container, but nginx container was listed first, and in this case that turns out well. So in cat user share nginx html, we should have date.log, and this date.log, look at that, is doing all right. So it was a little bit of work, but this is how you create the sidecar container. Let's do an exit, and let's continue with the next assignment. All right, the next assignment should be an easy one, fixing a deployment. Here we go. Start the deployment from the redis.yaml file in the course Git repository and fix any problems that may occur while starting it. All right, so let's have a look at this redis.yaml. It's always good if you think something is going wrong to understand what will be going wrong. And how do we like API version apps v1 beta 1? Well, let's figure out. kubectl create -f on redis. Redis.yaml is giving me a resource not found. No matches for deployment in version apps v1 beta 1. kubectl API version is going to tell you what is going wrong, and it's telling us that we have apps v1. We don't have apps v1 beta 1 installed as an API anymore on this system. So how are we going to fix this? Well, in this case, it is going to be super easy. We just fix the API version in the YAML file, and we use kubectl create -f redis.yaml again, and then it is doing all right. In some cases, it may be harder because sometimes it's not just the API version number that changes, but the API properties as well. And then you need kubectl explain or the documentation to figure out what exactly is happening. But in this case, it was easy enough. Let's continue with the next assignment. All right, time for the next assignment, using probes. So create a pod that runs the nginx web server, and the web server should be offering its services on port 80 and run in the cKAD ns3 namespace. And the pod should check the health path on the API server before starting the main container. So what is going on here? Well, this assignment is about probes. And a probe is a test that you are going to run before releasing access to the main container. So we need to look up what the probe is doing. The specific thing here is that this probe is about the health Z path on the API server. And before we are going to focus on the probes, we should investigate the health Z path on the API server. Let me show you. This is absolutely an assignment where you are going to need the documentation. So let's start with health Z. API
And there we can see Kubernetes API endpoints. That's where I want to start with. And what do we see? We see this line. This is a curl command, and this curl command allows you to address an API endpoint. And the curl command will show you output about what is going on. So we need to do this for health Z, and we need to change it a little bit. So we do need this curl command. Let me copy this curl command, and let me go to a command line and run it. And is it working? No, it's not working. And that's because this curl command is going to localhost, and it's going to live Z, and it's going to port 6443. Now, live Z, that should be health Z. Localhost 6443, that should be Minikube 8443. And the Minikube IP address 192.168.49.2. And there we can see what this health Z is doing. Now, the essence of a probe is that you run a command successfully. So we need to include this curl request in some way in the probe that we are going to use. So we are definitely going to remember this. And here you can see the OK and the OK and the OK. Echo dollar question mark is showing a 0. So all of this is looking good. Now, the thing is, how do I know about this Minikube IP address and port 8443? Well, if you go into the Minikube host, Minikube SSH, and I use PSAUX pipe grab API, then I can see my Kube API server, and the Kube API server is using an advertised address 192.168.49.2. And we can see all the details about the Kube API server in here. We can also use kubectl get pods -n kube system -o white, oh that's typo, to figure out that this API server right here is listening on IP address 49.2. And in the pod details you can find the actual port that it is listening to. Right, that is what we are going to need from the pod definition. So now we are going back to the documentation, and we are going to look for probes. Now in here we can see configure liveness, readiness, and startup probes. This is a readiness probe, because a readiness probe is what you use to verify that your main container can be starting successfully. So here we have a liveness probe. Well, liveness probes and readiness probes are not that different. So let's just take this code and let's put it in a configuration file. So I'm creating task158.yaml, and I am going to put everything we found in the configuration file. So what do we see here? We see the command, and the command is cat. Well, I am going to use the command curl, and we need curl with the argument -k, and we need to curl to, what was it again? Well, we can just look it up in the history. This is the one. So HTTPS, this entire string is what we are going to check. So let's copy it. And let's put it in the YAML file. Initial delay of 5 seconds, that is okay. Period seconds of 5, that is okay as well. You don't really need the verbose because the only thing that matters is do you get answer. And in the liveness probe, verbose output doesn't really matter. So I would say move this out. Then we have a web server, and the web server, well, that is just an Nginx web server. So name Nginx and image Nginx. And we don't need any of these arguments here because this web server is not supposed to be doing anything. So do we have a name requirement for this pod? We don't have a name requirement. So liveness exec, for now that is okay. And I know I'm not done yet, but let's focus on the hardest part first before we are doing anything else. Oops,
one more thing, liveness probe. This is a liveness probe. We should change that into a readiness probe. So it's executing a command, and that's a simple way, but simple ways should be working as well. So kubectl create -f on task 158.yaml, and there we go. And kubectl get pods, and let's monitor what this liveness exec is going to do. It shows as running. It has been around for 3 seconds. 3 seconds is not enough to actually execute the probe because the probe has an initial delay time. So let's run it again, and after 20 seconds we can still see it as running, but 0 out of 1. And the 0 out of 1, that is problematic. So we need to figure out what is going on. kubectl describe pod liveness exec is what we are going to use. And what do we see? We see readiness probe errored, RPC code, code is unknown, deadline exceeded, context deadline exceeded. That's not good. What is the readiness probe doing? Well, the readiness probe is doing a curl K. Hey, a curl K. Is that all right? Let's investigate. Of course, curl K is not all right. That must be -K. Here you can see how kubectl describe can really be good to figure out what is going on. So kubectl delete -f on task 158.yaml to delete it, and let's run it again. And not too fast, let's type kubectl get pods. We need about 15 seconds for this test to be successful, and yay, here we can see liveness exec with 1/1 is running. Hey everybody, you might be wondering, how about the 3 different probe types? Well, of course, you can use the 3 different probe types that are defined in the documentation, but you have an HTTP request and you have the TCP port access. Feel free to do so if you feel comfortable with it. But what I'm showing here is that in essence, the probe is just a command that is executed, and curl -K or an HTTP port request comes down to the same. You have a test, and this test is successfully executed. That's the thing that matters. Now I'm going to edit my task 158 because we need this thing to be running in a specific namespace. And the namespace is cKAD NH3, and let's double check. The web service should be offering its services on port 80 and run in the cKAD NH3 namespace. Didn't we have something like port in the container specification? Let's kubectl explain on pod.spec.containers.port. I'm just guessing it is port. Is it port with an S? Yeah, it's port. Port with an S. So what do we see here? Container port is the number of port to expose on the pod IP address. Must be a valid port, so container port is what we are going to include here. That's just an additional complication, but it's not too difficult. So container port colon 80. So let's run it again. kubectl create -f on task 158.yaml. And oops, did I make a typo in container port? Well, apparently I did. Let's have a look at kubectl explain pod.spec.containers.ports, and aha, we are missing 1 level. So now that we know about the port, let's get back to the task 158.yaml. Where we need to include ports and container port 80. So once we've done that, kubectl creates -f task 158.yaml. So the pod is now created, and kubectl get pods -n cKAD NH3. And we can see liveness exec with an age of 8 seconds in a state of running. And with an age of 15 seconds and a state of running, we can now see the 1 out of 1. So that means that we successfully completed this assignment. All right, time for the next assignment in which you are going to create a deployment. Write a manifest file with the name nginx-exam.yaml that meets the following requirements. It starts 5 replicas that run nginx 1.18 image. Each pod has the label type is webshop. Create a deployment such that while updating, it can temporarily run 8 application instances at the same time, of which 3 should always be available. The deployment itself should use the label services nginx and update the deployment to the latest version of the nginx image. That's all. Let's go check it out. So the core question is to write a YAML manifest that creates a deployment. So kubectl create deploy nginx exam dash image is nginx colon 1.18 dash dry run is client minus o YAML greater than nginx exam.yaml. So here we have nginx exam.yaml. And what do we need to do? We need to tweak the number of replicas. So replicas is set to 5. Each pod has the label type is webshop. So let's add type webshop. The question is not asking you to replace any of the labels. So I would say just add them. Now that we are talking about labels, the deployment itself should use the label services nginx. So here we go, service colon nginx. And then we have these strategy settings. So you need to create a deployment such that while updating, it can temporarily run 8 application instances at the same time, of which 3 should always be available. That is in deployment.spec.strategy. So let's kubectl explain recursive deployment.spec.strategy. And what do we see? We see a rolling update, which is set to max search and max unavailable. These are the options. So we need rolling update. That is 1. It can temporarily run 8 application instances at the same time. That is max search. So max search should be 3, of which 3 should always be unavailable. So max unavailable should be set to 2. So we are going to copy these options and put these options in the nginx exam.yaml and as strategy options, space them in there. So a rolling update, that is the object, so that does not have any specific arguments. We do need proper indentation. Max search, that's 3, and max unavailable, that should be 2. This should be doing it. And now we can run it, kubectl create -f nginx-exam.yaml. So there we go, it is created. Kubectl get all probably. And we can see nginx exam 0 out of 1, but that's because it's still in a state of container creating. And oops, something went wrong here. We don't have the right number of replicas, do we? So kubectl delete -f nginx-exam.yaml. The question is so specific about the file that we need to create that really you need this number of replicas to be in the file. So running it again. Let's do a kubectl get all -- selector app is nginx exam. And there we can see it's doing all right. And kubectl set image -h. We need to update the deployment to the latest version of the nginx image. So this is how we are going to do it. This is the structure of what we need. Kubectl set image deployment / nginx exam. Nginx is nginx :latest. So kubectl set image deployment nginx-exam. Nginx is nginx :latest. And now we are going to do this selector thing again. And there we can see that we have 8 in total. We have 3 running. And that is already proving that the deployment update parameters are applied the right way. That's all. In this assignment, you are going to expose applications. In the cKAD NS6 namespace, create a deployment that runs the Nginx 1.19 image. Give it the name Nginx deployment. Make sure it runs 3 replicas. And after verifying that the deployment runs successfully, expose it such that users that are external to the cluster can reach it by addressing node port 32,000 on the Kubernetes cluster node. And configure ingress to access the application at mynginx.info. Good luck. So let's start with the things that you probably don't have to do on the exam. That's sudo vim etc host, in which we need to make sure that mynginx.info is resolved to the Minikube IP address. That is something you don't need to do on the exam because this is DNS and DNS is external stuff. Also, what you don't have to do on the exam is Minikube add-ons list, in which you can see that ingress is already enabled. So we don't have to do a Minikube add-ons enable on ingress. So that allows us to focus on the rest of it. To start, kubectl create ns cKAD ns6. This is so annoying, we need to do anything in the cKAD ns6 namespace. But better think about using this -n cKAD ns6 option every single time. So kubectl create deploy nginx deployment. -- image is nginx :1.19. -- replicas is 3. -n cKAD ns6. So are we missing anything? No, not so far. That is doing all right. So next, we can use kubectl expose to expose it. I would really advise kubectl expose -n cKAD ns6, because as soon as the namespace is known, you can use tab completion. That's convenient. So deployment nginx deployment, and that requires me to use -- port is 80. So that is exposing it. And now I can use kubectl edit -n cKAD ns6 on the service that has been created. The service is nginx 6 deployment. And we need to specify the type. So here is the type. The type is currently set to cluster IP, and we need to make that node port. And the port, we need to add a port, and the port is node port 32,000. Let's save it. So what do we see here? Spec type unsupported value. Node port needs an uppercase N in the type. So here is the type. Let's make that an uppercase N. And then it's doing all right. So kubectl get svc -n cKAD ns6. And there we can see that indeed we have this node port. Next, we can use kubectl create ingress -h for some help. Pipe it through less so that you can see the easy examples. Now, what do we need? We need a rule that is connecting some virtual hostname to some port. Do we have a nice rule that is doing that for us? I think this one is pretty acceptable. There's too much information in it, but I do like to have it in front of me so that we can make it a little bit easier. So based on what we see here, it should be relatively easy to use kubectl create ingress, nginx deploy, -- class is default. It's just a default parameter that you need. -- rule is my nginx.info / is service, and that would be nginx deployment : 80. And there we go, ingress has been created. So, oops, did we do something wrong? Of course we did something wrong. kubectl delete ingress nginx deploy. We needed to create this dir ingress in -n cKAD -ns6. This is so annoying, but you need to be so very careful about this on the exam. kubectl get ingress -n cKAD ns6. And there we can see that the mynginx.info ingress exists. So we can see that mynginx.info exists. Time to curl it. So here we have a curl on mynginx.info and we get the welcome to nginx page. So that completes the assignment. So it is time for the next assignment, which is about network policies. So create a YAML file with the name mynwpolicy that runs 2 pods and a network policy. The first pod should run an nginx server with the default settings, and the second pod should run a busybox image with the sleep 3600 command. And next, use a network policy to restrict traffic between pods such that access to the nginx server is allowed for the busybox pod, and the busybox pod is not restricted in any way. Good luck with that. So to start with, go to the documentation and look for network policy. And haha, even if I made a typo, it has found network policies. In the documentation, there is only one reasonable example about the network policy that has way too much information. But I'm going to use it anyway. So here we have it. So let's create this YAML file, mynwpolicy.yaml. And in the YAML file, we will put the network policy configuration. Now, in YAML file, you can use these hyphens. I feel better in doing the pods before. So you know what? Let's get back to the documentation. So I'm looking for pod, and I just need a pod specification. So pods. Do we have a pod specification? Here we have a pod specification. This is good enough. I am going to copy it. It's pretty rough, but I like having my rough code in the YAML file so that we can tweak it from there. So hyphen, 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 and doing it again. And again, the hyphen, 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 and now we can start thinking about it. So we should have an nginx server with default settings. If it should be default settings, then really keep it as simple as possible. So name nginx and delete these 2 lines. The second pod should be busybox image with the sleep 3600 command. So kind pod metadata name busybox. And spec containers name busybox. And image is busybox. Now I wouldn't guess, if I were you, about the command, because I know, oh no, how are we going to get the command in the right way? Well, do this, kubectl run busybox dash image is busybox dash sleep 3600 and put a -o YAML in there. So -o YAML, and don't forget dash dry run is client. Small typo. And there you can see what you need to do. So args sleep 3600, and that's working okay. So copy that and put it in your configuration. It is so easy to make mistakes and waste too much time on relatively simple stuff like this. Don't do it. Generate it. So args sleep 3600. This is going to do it. So that is fine. Then we need a network policy to restrict traffic between pods in the following way. Access to the Nginx server is allowed for the BusyBox pod. What does that mean? That means that we need the pod selector to be set such that we have a label, and the label applies. So we need to set labels, and let's call it app Nginx. And here on BusyBox, we use labels, and let's set access true. That's what network policies are doing. Network policies are using labels. And now we can tweak the network policy. I'm keeping the name. I'm okay with the name. I'm so happy that this time we can run it in the default namespace. We have the pod selector. So the pod selector is using the label app Nginx, because this is about ingress traffic to the Nginx app. So app Nginx. Policy types, that would just be ingress. So we can remove egress. And then in the ingress selection, we can remove the IP block. We can remove the namespace selector. So that is 7 lines of deletion. And the pod selector, that is the one that we need to get in there. Now, pod selector role front end, you know what? I'm going to keep it in there because it allows me to test. And then let's check if there's anything else. No, we can delete all the way until the end. So we have an ingress policy that matches the BusyBox, the Nginx pod based on the label, and it applies to pods that have the match label role front end. So kubectl create -f my nw policy.yaml. And we already have a pod with the name Nginx. Yeah, that's a risk if you copy paste too much. So kubectl delete -f my nw policy.yaml. And of course we are getting some error. That is not a problem. We need to make sure that this pod, let's change both of them, nwp Nginx and nwp BusyBox. The names don't matter. What matters is the labels. So let's use kubectl create -f my nw policy, and what do we get? Error, unable to decode JSON, cannot unmarshal bool into Go structure. Bool is what it is about. So we have a boolean in the label. It's complaining about a boolean in the label. Yeah, that's true. Access true. That's a boolean. We don't like it to be a boolean. It needs to be a string value. It's a nasty error message, but it's interesting to see. So I am going to clean this up. Kubectl delete -f my nw policy.yaml. And I am going to tweak the code, and we make that access allowed. So kubectl create again, and now it's doing everything, and everything is okay. Just a little thing, kubectl expose pod nwp Nginx -- port is 80. We need this pod to be accessible, and to test accessibility, you need a service. Now we can test kubectl exec -it nwp busybox -wget -spider timeout is 1 Nginx. And what are we getting? We are getting download timed out. And guess what? That is exactly what we need. Because the network policy, let's have a look at the code again. The network policy is allowing ingress traffic only for pods that have the match label role front end. And my BusyBox doesn't have a label role front end. That can be fixed. kubectl label pod nwp busybox role is front end. And now we are going to do this kubectl exec again, and then we get the remote file exist. So that is how you create a network policy. Network policies are all about the labels. And as long as you make sure that labels are set correctly, your network policy is going to be all right. All right, time for the next assignment, which is about storage. Notice that all resources in the assignment should be created in the cKAD 1312 namespace. Create a persistent volume with the name 1312PV. It should provide 2 GB of storage and read-write access to multiple clients simultaneously, and you can use any storage type you like. Next, create a persistent volume claim that requests 1 GB from any persistent volume that allows multiple clients simultaneous read-write access, and the name of the object should be 1312 PVC. And finally, create a pod with the name 1312 pod that uses this persistent volume. It should run an Nginx image and mount the volume on the directory/web data. Let's check it out. All right, for this one also, I would like to start at the documentation. For the simple reason that persistent volumes and such cannot be easily configured from the command line. But in the documentation there is configure a pod to use persistent volume for storage, and I would advise you go for that. So just copy paste the YAML code. Here we have part number 1, that's a persistent volume. And let's put it in task 1512. So vim on task 1512.yaml. And there we have the persistent volume. Good, dash, dash, dash. And do we have a persistent volume claim as well? There we go, we have a persistent volume claim. Let's add it also to the YAML file, and again, dash, dash, dash. And the last part, that is about the pod. So here we have the pod. Putting it in the YAML code as well, and that is giving us a nice blueprint. All right. So we need to make sure that the resources are created in the cKAD 1312 namespace. So metadata, namespace, 1312, cKAD 1312. And here also namespace, cKAD-1312. And one more time, namespace cKAD-1312. Before doing anything else, do yourself a favor and use kubectl create ns cKAD-1312, because if you don't do it now, you are definitely going to forget it later. So now we can have a look at the details. Create a persistent volume with the name 1312 PV. So persistent volume name 1312 PV. What else? It should provide 2 GB of storage. So capacity 2 GB. And it should allow read-write access to multiple clients simultaneously. That would be read-write many. Use any storage type you like, so we keep the host path. Then create a persistent volume claim that requests 1 GB from any persistent volume. So let's call it 1312 PVC. And it should claim 1 GB of volumes that are offering read-write many. So there we go, 1 GB, 1 GB. Notice that from the examples we have obtained storage class name manual, storage class name manual. These are optional parameters. You may have them in, you may also remove them. If you remove them, then you don't know which PV the PVC is going to bind to. If you keep them, the PVC is more likely to bind to the PVC we are creating here, because it's looking for a matching storage class name as well. Last, create a pod with the name 1312 pod that uses this this storage. So 1312 pod, and it should use this storage and run an Nginx image. That's too much information. So the important thing is that the pod has a volume, and the volume refers to the claim name, not task PV claim, but 1312 PVC. This is making the relation. Then we have the container, task PV container. We do not care about the name. Nginx is fine as well. And we can keep the ports if you want to. And we need a volume mount. Now it's a little bit curious that the volume mount is not in user share Nginx HTML. That is what you might be expecting, but the assignment is pretty clear. It wants web data. So web data, let's check it. Web data is connecting to task PV storage. Task PV storage is the internal volume, which is referring to 1312 PVC. 1312 PVC is right here. It is looking for read-write many and 1 gigabyte. We do have read-write many and 2 gigabytes on the persistent volume, so that is looking kind of okay. kubectl create -f on task 1512.yaml, and we see all of it. kubectl -n cKAD dash 1312 pods PVC PV. Oops, my mistake. Get pods PVC PV, and we see this pod is running. The persistent volume claim is bound to the volume 1312 PV. The volume 1312 PV is bound as well. So here we are. And if you want to, kubectl exec -it. Let's insert the -n cKAD dash 1312 as well. So kubectl exec -it on 1312 pod dash touch / web data / test file. And oh, my mistake, typo in the namespace. And there it has written web data test file. Now the thing is, what exactly is web data test file? Well, that is something that we should be able to verify as well, because we have this host path mnt data. So if I use Minikube SSH, it's one of the bonuses of using Minikube, and I use ls on mnt / data, we can see that test file is right there. And that means that this assignment has successfully been completed as well. All right, time for the next assignment, using quota. Create a namespace with the name limited in which 5 pods can be started and a total amount of 1000 millicore and 2 gigabytes of RAM is available. And next run a deployment with the name restrict Nginx in this namespace with 3 pods where every pod initially requests 64 megabytes with an upper limit of 256 megabytes of RAM. Good luck. So for this one, the advice is to go for imperative mode. kubectl create ns limited. Then kubectl create quota -h pipe less, where we can see a pretty decent example. So I like to paste the example behind a hash, makes it easier. kubectl create quota limited quota -n limited, because that is where we want it to apply. -hard is CPU is 1. 1000 millicore, yeah, that is 1 CPU. Memory is 2 uppercase G, and pods is 5. Does that meet everything? In which pods? 5 pods, 1000 millicore, 2 gigabytes of RAM. That seems okay. kubectl describe ns limited is showing the current quota settings. Good. kubectl create deploy restrict genx minus n limited. Minus minus replicas is 3. Minus minus image is nginx. And next, kubectl set resources minus h, because we have some pretty good examples. This is about what we need. So let me copy this example and paste it so that we can use kubectl set resources minus n limited on deployment restrict genx. Minus minus limits is, what do we need as limits? We only need RAM limits, so 256 megabytes. So limits is memory is 256 MI, minus minus requests is memory is 64 MI. And there we can see resource requirements updated. And if we use the kubectl describe ns limited again, then do we see anything? Oh, I don't see anything yet. So did we do this the right way? And it looks as if we did. So kubectl get all minus n limited is showing what? It's showing that we have a deployment and we have a replica set and we have a new replica set, and this new replica set doesn't get any further. So let's analyze kubectl describe minus n limited replica set restrict genx 6d whatever is showing what? Filled quota, limits quota, must specify CPU. And you know why? That is because we have CPU on the namespace quota. You need matching CPU information on the deployment. So we need this kubectl set resources again, and this time I am making that limits is CPU is 1 and requests is CPU is 1, for instance. And now we can check again. I would advise starting by the kubectl describe. There we go. Kubectl describe is looking all right. And hey, what do we see here? Well, we see that the CPUs is not doing all right. We have a limit, a hard limit of 1, and we have 1 CPU for every single pod. So the CPU is not good. How are we going to fix that? We need to set millicore instead of entire CPU cores. Can we investigate how this works? Because the millicore that wasn't too obvious from the help output. So kubectl set resources minus h pipe less. Do we see anything in here? Yeah, there we go. 200 M. So take 2. We make that CPU is 200 M and request CPU is 200 M. That will set millicore instead of an entire CPU. Checking it again. And now we can see that, hey, for some reason, the resource has not been updated yet. Is that because we've been too fast? Apparently not. So maybe kubectl delete deploy restrict genx minus n limited to delete it. And let's create it again. And then let's use this set again. So here we have the CPU limits and another time for the set where we are using the memory requests. And once more, kubectl describe ns limited where we can see that this time, finally, we are doing all right. Nasty little thing. We had to recreate the application in order for it to pick up the resource limitations. Eventually it would have been picked up, but hey, this is speeding up things a little bit and makes that we can check off this assignment as well. In this video, we are going to do canary deployment. So run a deployment with the name MyWeb using the Nginx 1.14 image and 3 replicas. And ensure that this deployment is accessible through a service with the name Canary, which uses the node port service type. Next, update the deployment to the latest version of Nginx using the Canary deployment update strategy in such a way that 40% of the application offers access to the updated application and 60% still uses the old application. Let's go check it out. So let's start with kubectl create deploy MyWeb -- image is Nginx colon 1.14 -- replicas is 3. Now in Canary it is essential that we are using labels. Can we do that? kubectl edit deploy MyWeb and add the label type colon canary. We need to set the label throughout. So throughout, that means that it doesn't only need to be on the deployment, we also need it on the pods. So type canary. There we go. And kubectl get all -- selector type is canary. And that is showing the pods, the deployment, and the replica set as well. So that's good. Now we need to ensure that the deployment is accessible through a service with the name Canary. So kubectl expose deploy MyWeb -- selector type is canary. That is essential in the Canary deployment, that the service is not using the ordinary label, but the specific Canary type of label. And oops, we need a port as well. -- port is 80. And there we go. Now let's use kubectl describe on the service MyWeb to verify that it is doing all right. So we have the label type is canary and the selector type is canary. So that is looking all good. And now we need to update the deployment to the latest version of Nginx using the Canary deployment update strategy in such a way that 40% of the application offers access to the updated application and still 60% still uses the old application. Now you should really carefully think about updates, because update in Canary really means that you are going to run another instance of the deployment. In this case, the change is very simple. And we are just going to run the deployment again using replicas is 2 and using the image Nginx latest, so without any arguments. And we need a new name, my new web. It's not about the name of the deployment, it's about the experience of the user. The user is accessing the service, and the service will bring the user to the related pods. Now we are not ready yet, because we need kubectl edit deploy my new web. And in this kubectl edit, we need to set the label to type canary for the deployment, but most important for the pods as well. So type canary. Here we go. And now if you use our kubectl describe on the service, don't be too fast, because it might need a little bit more time. There we can see that at this point it has plus 1 more. Is that correct? Plus 2 more. We were a little bit too fast. At this point it has 5 endpoints. So kubectl get endpoints is another way of seeing that. Here we can see my web, 5 endpoints in total, and these 5 endpoints are the 3 replicas in the old version and the 2 replicas in the new version. So that's all. Alright, this assignment is about pod permissions. Alright, second assignment is to create a pod manifest file to run a pod with the name sleepybox. It should run the latest version of busybox with the sleep 3600 command as the default command, and ensure that the primary user is a member of a supplementary group 2000 while this pod is started. Let's go check it out. So if you know what this assignment is about, it's not too complicated. Let's use kubectl run sleepybox. -- image is busybox. -- dry run is client. I need to generate some YAML because we can't do it directly from the command line. -o YAML. -- sleep 3600 greater than task 1515.yaml. So what are we going to do? Well, we need to talk about security context. So in security context, you take care of problems like this. So kubectl explain pod.spec.security context pipeless. And there we can see everything that we need. Here we have this parameter fs group, and this fs group is a special supplemental group that applies to all containers in a pod, and it has an integer as its value for the simple reason that on these file system groups you can't use names because who is going to create a group by that name? So fs group 2000 is what we need in pod.spec.security context. So back to the YAML file task 1515.yaml. So in pod.spec we have the security context which is set to fs group colon 2000. Another quick check on the syntax. So security context is an object and fs group with an uppercase G is an integer. This should be okay. So let's run it. kubectl create -f task 1515.yaml. And oh boy, unknown field spec security context fs group. Do you see what is going wrong here? I can see it. We need fs group to be uppercase G. There we go. Let's try it again. And there, pod sleepybox is created. As always, kubectl get pods sleepybox -o YAML. That is going to tell you if this security context is applied the right way. There we go, fs group 2000. So it's applied the right way. And that's all. Right, time for the final assignment, using service account. So create a pod with the name all access. Also create a service account with the name all access and ensure that the pod is using the service account. No further RBAC setup is required. Okay, let's have a look. So this one is not too complicated. kubectl create SA to create a service account. And the service account is all access. So here we go. kubectl run pod kubectl run all access -- image is busybox -- dry run is client -o YAML. Do you see how incredibly important this is to generate the code dynamically? -- what are we going to do? Sleep 3600 greater than task 1516.yaml. And let's edit task 1516.yaml.
so that we can edit this service account. So service account all access. We need this to be indented the right way. And just to be sure, as you see it in default configuration all the time, service account name, all access, and that should do the trick. So kubectl create -f task 1516.yaml and kubectl get pods -o YAML on all access. And we are looking for the service account setting. So as you can see, service account is right there. That's all.